Hello students, am I audible to you all? And is video and audio crystal clear to you? Hi everyone, how have you been? Just give me a quick reply that whether video and audio is clear, and then we will start very shortly. Good evening everyone. Is audio video clear to you all? And are you prepared? Venkat, there is no limit on the marathon, right? We just have to reach the end point. And are every one of you is prepared? And are you excited or not? Hello. Namaste. Come on, come quickly, and I will apologize first for JEE students that we had to delay it by 1 hour, reschedule it by 1 hour because the previous live class ended a little bit late. But now it's all good, we are going to start. I know JEE students were waiting from 4 p.m. Okay. So in this session, we are going to do, you all know that we are going to do complete physical chemistry. Yes, the 12th, 11th portion of physical chemistry we are going to cover, as you have already covered inorganic with me previously and organic with Sagar sir, right? Yes, this session is for both JEE and NEET, and this is your end game. We are at the end game now, and after this session, I don't think you will be needing to revise physical chemistry anymore before your NEET exam or your JEE main attempt next attempt. Yes, so this session is beneficial for both NEET and JEE exam, JEE main exam. We are going to revise complete physical chemistry, mostly with MCQs and some of the numerical problem for JEE oriented student as well. Okay. My name is Kamal Sharma and I am your chemistry teacher. Yes. So what we have done, we have divided this whole session into 4 sections. 2 sections are of mainly 11th oriented and another 2 sections are of 12th chapter. So we will do 11th chapter of physical chemistry in this session, starting with the 3 basic chapter of mole concept, atomic structure and states of matter. After that, you will be given a short break so that you can rest, you can re-energize, you can refuel yourself and be back again with more energy. Okay? Yes, we will cover totally. Hello Inayat, hello Puneet. If I say your name, that doesn't make an impact. If the whole world says your name, that will make impact. If everyone in the education industry knows you that this is the student who scored very good AIR in NEET or very good AIR in JEE or very good AIR in JEE Advanced, then that will be impactful. So it is not beneficial for me to say your name, right? Yes. Notes will be available on PW app. After this, we will start with thermodynamics, equilibrium, redox reaction. Then we will move to the 12th portion. In the 2 session, your 11th physical will be done for once and for all. Then we will move to solid state solution chapter and electrochemistry, chemical kinetics, surface chemistry. And after that, your physical chemistry will be over. So this is a very quick thing, right? Do not ask me the duration of class. Just remember, there is a quote written for you that you have to do your best until you know better. And when you know better, you can do more better, right? Yes. Yes. Do not be stressed. See, taking pressure is not the solution to score rank or get selected. You have to just do your best. Just target that you have to do your best, and after exam there should not be a line of tension on your mind. that you could do better or you could do more good. If you have done your best, that is your duty and responsibility. Okay, so we will start with first chapter of today's session, which is first chapter of physical chemistry as well chemistry, basic concept of chemistry. Let's see what are the things that we are going to see here. First of all, I think everyone know what mole is. So this whole chapter can be done in 3 diagrams. We are going to use 3 diagrams to solve this whole chapter. First is whether you have mole, then you have mass, then you have number of particles. It could be atoms, it could be molecules, it could be ions, electrons, protons, anything. And then you have volume of gas at STP. So we are having 4 different type of quantity which will be used for interconversion. This is called as mole calculation. Whenever you want to go from mole to any direction, remember you have to multiply. And multiply by what? Multiply by the number that is contained in 1 mole. Suppose you have to go from mole to mass, you have to multiply by molar mass. You have to go from mole to number, you have to multiply by molar number, that is number of particle in 1 mole, Avogadro number. And if you have to go from mole to volume, you have to multiply by 22.4 liter. So it is very easy to convert mole to any quantity and any quantity to mole. Just remember, from mole outward direction you have to multiply, and towards mole direction you have to divide by the same number. So this includes your 3 of the conversion formula that every one of you will be knowing. So this is your first diagram that is required for mole calculation. Okay? Yes. Mole, you can remember the formula as well, but this will help in doing calculation very quickly. Suppose we want to go from volume to mass, the path is in front of you. Volume to divide, mole, mole to multiply, mass. Just divide and multiply and we will be done. No, that didn't happen. Do not worry about that. We will complete full as we completed full previously as well. Second, if you want to convert from mole to atom or atom to molecule, we have a diagram for that as well. Mole of atom and mole of molecule. As molecule is a bigger one always, molecule is formed from atom. So if you want to go from atom to molecule, you will divide, and if you want to go from molecule to atom, you will multiply. Divide by atomicity, that is number contained in 1. Every time we are going to divide or multiply by the number contained in 1. So this is your second diagram. In that diagram, you can convert from molecule to atom and atom to molecule. The third diagram is the stoichiometric calculation for balanced reaction. Suppose you have a balanced reaction of A and B giving C and D. So mole and stoichiometric coefficient is always equal. And in this diagram, you can also use the limiting reagent as well. If the question is of limiting reagent concept, then just compare the ratio of reactant side, and whichever is lesser will be our limiting reagent. And then onwards we can solve on the limiting reagent. So these are the main 3 diagrams that are used during mole calculation. Okay? Let's start with the question now. Let's start with the questions now. Or if you want to learn one more diagram, that is of concentration. Concentration is every time amount of solute divided by total amount of solute or solvent. Total amount of solute or solvent. So any concentration term, you have mass percentage, mass of solute divided by mass of solution, multiply by 100. You want to have mole fraction, mole of solute divided by total mole of solution into 1. You want to have molarity, mole of solute divided by total volume of solution. So in any type of concentration, you are every time going to have this formula. Just the amount will be replaced by either mass, volume or number of particles. Right? Yes. Yes, yes. Okay. Now we are going to start our question and answer session. Let's see what is the first question. And try to solve this question by yourself first, right? The weight of NaCl decomposed by 4.9 gram of H2SO4 if 6 gram of sodium hydrogen sulfate and 1.825 gram of HCl were produced in the reaction. We have to find the weight of NaCl decomposed. Now, whenever you have a question of physical chemistry, first of all, read the question at least twice, have the meaning of question clear in your mind, and then focus on the data given. You will be given datas every time in the physical chemistry question. Now, based on the datas and the question statement, we can say that mole of NaCl, weight of NaCl decomposed, that means NaCl is reacting with by H2SO4, and then it is producing sodium hydrogen sulfate and HCl, right? This is our reaction. And we want to find the weight of NaCl decomposed. This we want to find. Yes, you can depend on PW. PW is for student, by student, and again for student. Now we are given with mass of H2SO4, mass of sodium hydrogen sulfate that has been formed, and mass of HCl. Okay. Now let's focus on a question little bit. You all know that whenever we do some reaction on paper, we assume that reaction is going 100%. But it may be case that sometimes reactions are not completing due to some factor, like it could be stopping of the reaction, not proper mixing of reactant, some other experimental condition. So whenever you are given with amount of reactant and product are always the sure side. This is only the sure side that you can be dependent on, because some of the reactant may be left unreacted. We are not completely sure that whole of 4.9 gram H2SO4 is reacting. And if you solve on this 4.9 gram H2SO4, your question get incorrect. So always whenever you are given with reactant and product diagram, always focus on the product side. Okay. Now the reaction is balanced. So I can use the stoichiometry, mole of NaCl divided by 1, mole of H2SO4 divided by 1, mole of NaHSO4 divided by 1, mole of HCl divided by 1. Every time we are going to use the stoichiometry, we will apply in the mole analysis. I am not going to use this. I can use this or this. Let's say I am going to use this. So mole of NaCl will be equal to mole of HCl. We are given with mass. We are going to use first diagram, mass to mole divided by molar mass divided by 36.5, which is the molar mass of HCl. So clearly it is 1 by 20. And then mass of NaCl, again mole to mass multiply. Whenever we are going from mole outward, multiply by 58.5. So that will give you 29.25 divided by 10. Can you find the answer? 2.925 gram. Option C is our quickest answer. Option C is our quickest answer. Yes. No, option 1 is not correct. How many of you could solve this question? See, in physical chemistry, you cannot do question very quickly like inorganic. You have to solve it on paper by yourself. Yes. How many of you could do this answer? Option C is our correct answer. 2.925 gram of NaCl will be decomposed. We are approximately 250 plus questions. We are having approximately 250 plus questions. So, if someone is getting this as the answer, they might have solved based on this analysis. Okay. Moving to the next question now. 6.02 into 10 to the power 20 molecules of urea are present in 100 ml of its solution. the concentration of urea. See, this question is about concentration and that in molarity. That means mole per liter. So every concentration term is having the same formula, amount divided by amount. For molarity, we will use mole of urea divided by volume of solution in liter. So we are given with the molecules of urea. So we have to go from molecule to mole. Anytime going towards mole, we are going to divide it. So 6.02 into 10 to the power 20 divided by Avogadro number 6.02 into 10 to the power 23. Volume is 100 ml. So you can convert it into liter by dividing with 1000. Rest is only calculation. Rest is only calculation. That will be 10 divided by 10 to the power 3. That will be 10 to the power minus 2, 0.01 moles per liter. 0.01 moles per liter, option B will be our correct answer. Some of the NEET aspirants are always reluctant to do calculation. They avoid calculation. They say that, okay, we have arrived till this, and after beyond this we will solve in the final exam as well. But that doesn't happen. Whatever you haven't practiced during your preparation, you will not be able to solve that in your exam. So if you want to solve completely in your exam, do complete question. Yes. Yes. Okay. Moving to the next question. Keep the Josh high, keep up the spirit high, and do all the questions. If we consider that 1/6 in place of 1/12, mass of carbon atom is taken to be the relative atomic mass unit, the mass of 1 mole of substance will. What will happen here? What will happen here? See, we have defined 1 AMU as 1/12 of mass of 1 carbon atom. Right? Mass of 1 carbon atom. We are going to solve this question logically. This is the relative mass unit. Relative atomic mass, or you can call it RAM. Prabhu Shri Ram. So 1 AMU is equal to 1/12 of mass of carbon. That is our standard convention. That is our standard convention. Now the question is saying, consider that 1 AMU in the new system is 1/6 of mass of carbon atom. This is now our 1 AMU. What will happen with the mass of 1 mole of substance? First of all, think logically whether 1 mole of a substance will occupy or will contain different particles than Avogadro if we change our relative unit. If we change our relative unit, whether 1 mole will contain Avogadro number or not. So your answer will be, it will be 1 mole will be Avogadro number, because we are changing mass relative, not number. And if 1 mole is having Avogadro number, how can the mass of 1 mole will be changed? So clearly the answer should be remain unchanged. The answer should be remain unchanged. But we will find it here. Let's talk about oxygen. The mass of 1 oxygen atom is 16 AMU in the previous unit. If this is halved, that means now the mass will be, you can see that if from the previous convention, if we divide, it will become half AMU. So it will become double of that. But in AMU unit. So relative mass will change. Relative atomic mass will change, but not the mass of 1 mole of substance. Look here like this. 1 mole, we already know that, contains 6.02 into 10 to the power 23 oxygen atom. This number is not going to change. Then how can the mass of this number change? Okay, so option B is going to be the answer here. Moving on to the next question. Notes will be in PW app. We will consider the theory part with numerical. We will do the theoretical part through numericals, through MCQs question. Yes. Okay. Moving to the next question. How many moles of magnesium phosphate will contain 0.25 mole of oxygen atom. Now this is a question from NEET PYQ, and this could be done in one line if you know the diagram. If you know the diagram that I just taught you, that we are given with the mole of atom, and the question has asked from us the mole of molecule, right? Atom to molecule, we want to go from atom to molecule. I just told you atom to molecule, divide by atomicity. Divide by atomicity. So mole is 0.25 mole of oxygen. The atomicity of oxygen here is 8. 8 oxygen atoms are present in magnesium phosphate. 8 oxygen atoms are present in magnesium phosphate. So we will divide it by 8, and that will become mole of magnesium phosphate. One line question if you know the diagram. Especially in NEET, the mole calculation can be done in one line. Is it clear to you? What will be the answer here? I think it will be 0.0125. Just see it. No. 0.0312. Something like this. Option D will be the correct answer. Option D will be the correct answer. 0.03125 moles. Correct. Very good, very good. Okay, moving to the next question. A gas occupies a volume of 300 cc at 27 degrees Celsius and 620 mm pressure. The volume of gas at 47 degrees Celsius and 640 mm of pressure. See, whenever we are discussing about volume of gas, if the condition is not STP, not the standard condition, there is only one thing to do for a gas: use PV is equal to nRT. Use PV is equal to nRT. From here you can use P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. And in this equation, only temperature should always be in Kelvin. The temperature should always be in Kelvin. Rest of them can be in any unit, but the unit should be same. Pressure is 620. Volume is 300 ml. The quantity of gas is not changed. The quantity of gas is not changed. The quantity is not talked about. And temperature is 300. After that, the pressure became 620. Volume we have to find. Moles is not changing, but the temperature has become 320 Kelvin. So see, this will be cancelled out. This will be cancelled out. V2 will be, the pressure is also okay. The pressure has become 640 here. So V2 will be 620 divided by 640 multiplied by 320. You can solve this easily as well. You can solve this easily as well. Or you can find the answer through some logic as well. What is the logic here? This is 32 and this is slightly smaller than 1. This is slightly smaller than 1. That means the answer will be slightly smaller than 32. Slightly smaller than 310. Option B is the correct answer. Option B is the correct answer, not C. 310 ml. 310 ml. Ruchi, this is a pure English session. English session, physical chemistry will be done on some other channel. Okay. Let's move ahead. Solve this question. This is again a very, very usual question, very, very known question if I am to say. Hemoglobin contains 0.33% of iron by weight. The molecular weight of hemoglobin is approximately 67,200. The number of iron atoms present in one molecule of hemoglobin. We have to find number of iron atom in one molecule of hemoglobin. That is, we have to find atomicity of iron. Right? Yes. Okay. See, let's say hemoglobin is having certain formula and the formula has X atom of iron. One molecule of hemoglobin, let's say, have X atom of iron. That means the percentage of iron. Whenever we want to find percentage of anything, we have to have the total mass of iron. That will be X multiplied by 56. because one atom has a mass of 56, divided by total mass of molecule, that is 67200, multiply by 100. And this percentage is given as 0.33. X multiplied by 56 divided by 672. So X will be 672 multiplied by 0.33 divided by 56. Divided by 56. Yes. Okay, Soumyadeep, if some question of stoichiometry is a tool. Physical chemistry is a tool to help you understand inorganic and organic. So in physical chemistry, reaction from both sections can come, physical as well as organic. And in order to do that question, you have to just strengthen your organic and inorganic reactions. Okay? In I we will talk about it later. We will talk about it. So you can solve for X, I think approximately 1 by 3, 200, approximately 4 will be the answer. So we can say that one molecule of hemoglobin contains 4 atoms of iron. 4 atoms of iron. Option D is the correct answer. Yes. The number of atom cannot be fractional. So if you are getting 3.96, just approximate it to the nearest integer. Approximate it to the nearest integer. Yes. Let's see the next question. We are given with another reaction. 11.2 liter hydrogen at STP is produced for every mole of HCl, and we have to compare all the options for this reaction. Let's see the reaction. The reaction says 2 mole of aluminum will react with 6 mole of HCl to produce 2 mole of aluminum iron, 6 mole of Cl minus iron, and 3 mole of hydrogen. See here. For aluminum, they are not talking about anywhere gram. Okay. They are just talking about only the mass and liter of hydrogen. So this 3 mole will be either 3 into 2, that is 6 gram, or 3 into 22.4, that will be 67.2 liter at STP. What we did here, we use stoichiometry. For hydrogen, they are using liter and gram in the option. So for hydrogen, I converted into gram as well as liter. Now analyze it. Per mole of HCl, 6 mole of HCl are producing this much of hydrogen. So 1 mole of HCl will produce this divided by 6, 11.2 liter. That is correct. Our first option is correct. Let's check another option. 6 liter of HCl. HCl is aqueous, liquid. So for liquid, we cannot directly convert volume without using density. For liquid, we cannot directly find volume without considering density. So at this point, this option is not correct. 33.6 liter hydrogen is produced regardless of temperature and pressure. No. Whenever the gas is talked in question, temperature and pressure are required. Volume of gas is not a finite term. So because of temperature and pressure, this statement is not correct. 67.2 gram of hydrogen. No. 1 mole of aluminum will produce 2 divided by 2, that is 3 gram of hydrogen. 1 mole of aluminum will give you 3 gram of hydrogen, not 67.2. So only option A is our correct answer. We found option A as the correct answer in the first step, but still we checked all options B, C and D. B, C and D. Right? Okay. Let's see the next question. The concentrated sulfuric acid that is peddled commercially is 95% H2SO4 by weight. If density of this commercial acid is this, then find the molarity of this solution. See, you can use the direct formula for conversion. Yes, Devdut, they are enough. Okay. Okay, no problem about the speed. You can use the direct formula percent into D into 10 divided by molar mass. This is the direct relation between molarity and percentage composition, or you can go by step analysis as well. So molarity will be 95 multiplied by density into 10 will be 18.34 divided by 98. Now again, without calculating, we can see that this will be slightly less than 1. 95 by 98 will be slightly less than 1. So 18.34 multiplied by something less than 1 should give you less than 18.34. Let's see, less than 18.34. Closest answer is option A. Closest answer is option A. I am seeing some of the students are mentioning answer, but they are mentioning incorrect. They are mentioning incorrect. I am here. Okay. Let's see the next question. Is this previous question clear to you all? Now moving to the next question. What is the mass of precipitate formed when 50 ml of 16.9% solution of AgNO3 is mixed with NaCl solution? See, if you read a question and anytime you feel reaction is occurring, write the reaction. The best method is write the reaction. AgNO3 is reacting with HCl. Whenever silver and halide ion reacts together, they form a precipitate of silver halide. For AgCl, the precipitate will be white color, white in color. We are given with 16.9% of solution, but 50 ml only. So 16.9% we can assume it to be weight by volume. That means 100 ml will have 16.9 gram. So 50 ml will have just half, that is 8.45. 8.45 gram of silver nitrate. Similarly for HCl, HCl is given as 50 ml of 5. Just a minute. Okay, this was not HCl. I must apologize again. This is NaCl. So that will be NaNO3. Okay. So this is given as 50 ml 5.8%. So this will become 5.8 divided by 2 or 2.9 gram. Because percent always refer to 100. So 50 will just contain half of amount. 50 will just contain half of amount. Yes. Now we want to find the precipitate. Again, we are given with both reactant. Whenever we are given with more than one reactant, you have to find limiting reagent. Mole of AgNO3 divided by 1. Mole of HCl divided by 1. First of all, mole of NaCl. First of all, we are going to compare both of reactant with their stoichiometry. So AgNO3 is 107.8, nitrogen is 14, 3 oxygen 48. So that will be 8, 8, 4, 12, 7, 9, 4, 1, 5, 1, 6, 16, 169.8. 169.8. Am I not audible? Am I not audible? Some students are saying my voice is not audible. Yes, this is first chapter. This is not the case that if you haven't read whole year, you cannot do anything right now. Okay, am I audible to everyone now? Yes. So this will be 16.9 divided by 2. Instead of 8.45, I am using 16.9 by 2 into 169.8. This is 5.8 divided by 2 into 58.5. You can see that this is approximately 1 by 20. This is also approximately 1 by 20. If both are equal, if both reactant are coming equal, you can take any of them as the limiting reagent. So the mole of AgCl by 1 will be equal to 1 by 20. So mole of AgCl will be 20 multiplied by 143.5 approximately. 143.5 divided by 20, that will be approximately 7 point something. 7 point something, 7 gram is the correct answer. Option C is our correct answer. Yes. Tell me what doubt you have. Just tell me what doubt you have. Okay. Okay. If you have any doubt, just write it in the chat box. Then until then, we are moving to the next question. Now this is very good question. This is very good question. We have around 20 to 25 questions per chapter. Let's see this question. What is the question saying? Number of valence electron in 4.2 gram of nitride ion. Now, some of you have a old school method for this question. That first of all, you find the number of nitride ion by multiplying with Avogadro number, and then you multiply by the number of electron per atom. What we are going to do, 4.2 gram of nitride ion, we will convert it into mole. 4.2 divided by molar mass of nitride, that is 42, so that will be 0.1 mole. Now nitride ion has 3 nitrogen atom, right? 3 nitrogen atom will have 3 into 5. Per nitrogen atom we have 5 valence electrons. So 3 nitrogen atom will have 3 into 5 plus 1 electron extra. So we have a total of 16 valence electron. 16 valence electron per of azide ion. So we will multiply by this atomicity of electrons. So this will give you 1.6 mole of electron, of valence electron. And if valence electron is 1.6 mole, so that will be 1.6 into Avogadro number. 1.6 into Avogadro number. Option C will be the correct answer. Option C will be the correct answer. Why mass is precipitation? In the previous question, mass percentage were given, and according to that, AgCl was being precipitated. So we first found the limiting reagent by converting mole by ratio. So mole by ratio came equal for both of them. So if both are equal, both can be taken as limiting reagent. So we took one of them and equate to the mole by stoichiometric ratio for AgCl, because this is the one which is being precipitated. Mass of precipitate will be mass of AgCl. Okay. See, don't worry about the chat box. The chat box is for you to write your answer so that you can have a boost of confidence and for you to check other doubt as well. Rest of anything is no longer required, no longer needed for you. You just have to focus on the screen here and the paper sheet that you have in front of you. Yes. Okay. And I have always seen the one that is studying silently have his victory. Have his victory, have his success. So this is our next question. A transition metal M forms a volatile chloride which has a vapor density of 94.8. Which have a vapor density of 94.8. If it contains 74.75% of chlorine, then formula of the metal chloride will be. See, vapor density is given only because of the finding of molar mass. So vapor density is molar mass divided by 2. Molar mass will be 2 times of 94.8. That will be 8 to 16, 4 to 8, 9, 9 to 18. 189.6 is the molar mass of this metal chloride. Now this is also given that metal chloride contains 74.75% of chlorine. Let's see here. Suppose metal has a valency of X. Chlorine always have a valency of 1. So 1 here, X here. MClX should be the formula. MClX should be the formula. Right? Now, if percentage of chlorine is 74.75, percentage of metal will be 100 minus 74.75, that will be 25.25. 25.25. Now you can find X using either metal percentage or chlorine percentage. How? The percentage of metal will be mass of metal divided by total molar mass that we already know into 100. From here we can find the mass of metal, or percentage of chlorine will be mass of X multiplied by mass of chlorine divided by total mass 189.6 multiplied by 100. See, what we did three things in this question first. First, we found molar mass. Then we found an approximate unknown formula for the metal chloride. And then we use the percentage of chlorine or percentage of metal. From both you can find your answer. If you find X, you can directly find the option. If you find the mass of metal, you can check from the option which option is having 189.6 gram as the mass. Vapor density is ratio of density of any gas with respect to hydrogen. That is the concept behind vapor density. Ratio of density of gas with respect to density of hydrogen gas. But the concept is not required, only this conversion is required all the time whenever they are giving you vapor density. Whenever they are giving you vapor density. Okay? Can you find the answer for this question? What is the value of X? That will be around 200. So I think MCl2 should be the answer. MCl2 should be the approximate answer. Just check it once. Okay. Moving to the next question. You can find X from here, but now we are moving to the next question. A gaseous hydrocarbon upon combustion gave 0.72 gram of water and 3.08 gram of CO2. The empirical formula of the hydrocarbons. Now this question is based on POAC. This question is based on POAC. See how we are going to do this question. CXHY. Let's say the hydrocarbon is CXHY. As the question is saying hydrocarbons, so only carbon and hydrogen are going to be present. What is the mass of CO2? We are going to analyze CO2 first. 0.72 gram. That means 0.72 by 44 mole, gram to mole divided by molar mass, right? Tell me your doubt. Tell me your doubt. Street right? Just tell the doubt. Your doubt of vapor density, I already told you the use of vapor density is only to calculate molar mass. Sonu, tell me your doubt. Okay. Till then we are going to move forward. Now here, carbon is having atomicity of 1, so 0.72 by 44 into 1 mole of carbon. Mole of carbon. Similarly, we can analyze for water. Water is 3.08 gram. So that will be 3.08 divided by 18 mole water. As the atomicity of hydrogen is 2, so that will be 3.08 by 18 multiplied by 2 mole of hydrogen. For empirical formula, we always want to find the mole first. Now we can say that whatever amount of carbon was present here would go in CO2 because the combustion is producing CO2 from hydrocarbon, and whatever amount of hydrogen was present here will go completely in H2O. That is our principle of atomic conservation. That is our principle of atomic conservation. Only this is to be used in this empirical formula calculation. Okay, just a minute. Okay. Just a minute. CO2 is 3.08. I'm sorry. So that will be 3.08 divided by 44 mole of CO2 multiplied by 1. That will be 3.08 by 44 into 1. That will be mole of carbon here. H2O is 0.72 divided by 18 mole. So 0.72 divided by 18 multiplied by 2. In some haste, I misprinted the value of CO2 and H2O. Yes, we did it correct. Okay, thank you for that. Now, the mole of carbon here is, this will be 47. So 0.07 and this will be 18 into 4, 0.08. And mole of hydrogen is 0.08. So the simplest ratio will be 7:8. Formula will come as 6C7H8. C7H8. Yes, right. Okay. In order to solve any question rapidly, you have to be very quick in mole conversion. Very quick in mole conversion. In the last question, you can solve for x. I haven't done the complete calculation here, so you can solve for x and find the correct answer. Okay, now moving to the next question. Okay, moving to the next question now. Following is the composition of washing soda sample. Na2CO3 is there, NaHCO3 is there, NaCl is there, and mass percentage is also given. On complete reaction with excess HCl, 1 kilogram of the washing soda will evolve how much? 1 kilogram of washing soda will evolve how much of CO2? Let's see here. This is a carbonate salt. This is a carbonate salt. This is normal sodium chloride. Whenever you have a mixture, you have to write every reaction separately. You have to write every reaction separately. So we are having three things in this composition. We will write the reaction of every one separately. That will have no reaction because this is a neutral salt. Neutral salt will not react with acid or base. Carbonate salts are basic salt, so they will react with acid to evolve CO2 gas. Carbonate salts are basic salts, so they will react with acid to evolve CO2 gas. We can easily balance it. 1 mole of HCl will be balanced here and 2 mole of HCl, 2 mole of NaCl. Now this is balanced. So you can see that CO2 gas is being evolved from these two, sodium bicarbonate and sodium carbonate. Let's see now. 1 kilogram, that means 1000 gram of washing soda is given to us. We are given with 1000 gram of washing soda. The percentage of sodium carbonate is 84.8. So sodium carbonate will be 848 gram. 848 gram in the 1000 gram sample. Bicarbonate is 8.4. So 8.4, it will be 84 gram in the given sample. 84 gram in the given sample. First of all, we are going to analyze reaction number A. Mole of sodium bicarbonate 84 divided by molar mass of sodium bicarbonate 84 divided by coefficient, that is 1, is equal to mole of CO2 divided by 1. So mole of CO2 will come as 1 mole. In the reaction A, we can see here 1 mole of sodium bicarbonate is present, so 1 mole of CO2 will be obtained, right? Okay. Now see here, 848 gram. So 848 divided by 106 divided by 106, which is a molar mass of sodium carbonate, multiplied by 1 is equal to mole of CO2 by 1. So mole of CO2 will be 8 moles. So here we can say that 1 mole of CO2 is produced from reaction A and 8 mole of CO2 is produced from reaction B. A total of 9 mole of CO2 has been produced. 9 multiplied by 44, that will be 9436. 9436 plus 3, 396 gram. 9 mole of CO2 or 396 gram. Option A is going to be our answer. Yes. Very good, Aditya. Okay, I will tell him. I will tell him, but that is very much rare that he will come. Okay, let's move to the next question. This is clear to everyone. Now, this is a very simple question. You have to tell me the answer for this. You have to tell me the answer for this. Arrange the numbers in increasing number of significant figure. We have to arrange the number in the increasing order of significant figure. Increasing order of significant figure. Yes. The easiest way to find significant figure, if ever you are confused in finding significant figure, just convert every number into scientific notation. Just convert every number into scientific notation. Here if I convert this, this will become 0, 0, 0, 2.600 multiplied by 10 to the power 1, 2, 3 minus 3. 2.6000. This is already scientific notation. 2.60 multiplied by 10 to the power minus 1. So if you are ever confused in finding number of significant figure, just convert it into scientific notation. Now, any zero before a non-zero number is insignificant. So 1, 2, 3, 4, 4 significant number. 1, 2, 3, 4, 5, 5 significant number. 1, 2, 2 significant number. 1, 2, 3, 3 significant number. So 2.6000, then this, then this, then this. Option A will be our answer. A for answer. Yes, good. So significant figure can be very easily found if you can convert it into scientific notation. Moving to the next question. Dissolving 120 gram of a compound whose molar weight is 60 in 1000 gram of water gave a solution of density this, the molarity of the solution. See, we have to find here molarity. Molarity can be found by using volume. So molarity will be mole of solute mass divided by molar mass. Volume of solution. See, solution is 1000 plus 120. Solution is 1120 gram. The mass of solution is 1120 gram divided by density 1.12. That will be the volume in milliliters or 1000 here. So that will be 2 into 1000, or we can write it 1120. This will go above and become 1120 divided by 1120. So clearly 2 is going to be our final answer. Option B is the correct answer. So some questions are very one-liner questions from this chapter. Some question require some of the chemistry. Yes, correct. Option B is the answer for this question. Do not retract your wrong answer. That should be a learning to you that you should solve every question completely. It doesn't matter how fast or how slow I solve. It matters that how much fast you can solve it. Okay. A gaseous compound of nitrogen and hydrogen contains 12.5% of hydrogen. Now this is again a question based on molar formula. The density of the compound relative to hydrogen. See, now this is an interesting line here. The density of the compound relative to hydrogen. If any of you haven't understand about the vapor density, if any of you don't know what vapor density is, you will be unable to solve this question. This is just the definition of vapor density written here. Density of any compound relative to hydrogen is nothing but called as vapor density. So if vapor density is 16, the molar mass is going to be twice of vapor density, that is 32. Twice of vapor density, that is 32. Yes, I'm writing all the important formula while solving the question. Now, you can either use further information to found the value, but these are given in percentage. Another alternative, easier method is find the molar mass here. 14 plus 2, 16. No. 14 into 3, 42 plus 1, 43. This is 16. This is 43. No. 14 plus 3, 7. No. 14 into 2, 28 plus 4, 32. Only option D is having molar mass as 32. So that will be our correct answer. That will be our correct answer. Yes. Okay. Moving to the next question. You could solve this question by empirical formula analysis, but that will require more time than finding the molar mass of every option and then finding the correct answer. Okay. Moving to the next question. The amount of barium sulfate formed, again a similar question like AgCl. 100 ml of 20.8% barium chloride and 50 ml of 9.8% H2SO4 solution. This is written again. Will be. We have to find the amount of barium sulfate. Now this is another very important reaction of test of barium sulfate. Sometime it feels that you have forgotten everything, but if you are seeing a question and you are only able to solve that question, that means your preparation is up to the mark. Sometime before 2-3 days before exam, we have a tendency to feel that we have forgotten everything. Nothing comes in our mind. But that time is to relax, not to feel depressed. That time is to be motivated, not to be demotivated. Yes, Raghav, yes. I will tell him definitely. See here, we are with barium chloride and H2SO4. Barium always form a precipitate, a white precipitate of barium sulfate. So we have to find the mass of this precipitate. Again, similar to the previous problem, we are given with both. So we are going to find limiting reagent as well here. 100 ml 20.8 barium chloride. So that will contain 20.8 gram of barium chloride. 50 ml 9.8. So that will contain 9.8 divided by 2 gram of H2SO4. This should be clear to you that percentage is always telling information out of 100. Okay. Now we are going to find limiting reagent because amount of both reactant is given. Barium chloride divided by 1, H2SO4 divided by 1. We will compare both of them by mole. So that will be 20.8. The mass of barium is 71 plus barium 137, that is 208. 9.8 divided by 2 molar mass of H2SO4. You should be able to find the molar mass all the time. 1 by 10, 1 by 20. As H2SO4 is less, so this will be the limiting reagent. This will be the limiting reagent. Anytime in any question you are given mass of more than one reactant, you are going to find limiting reagent. You are going to find limiting reagent. Okay? Yes. Yes, yes. Now we can find the mole of barium sulfate. As H2SO4 is the limiting reagent, so that should be equal to 1 by 20. Just equate mole and stoichiometric ratio. So that is 1 by 20. Mass of barium sulfate. We have to find the mass, right? That will be barium sulfate 137 plus 96, 233. Yes. 233 by 20. That will be 11 point something, 11.65 gram. Option B is our correct answer. Option B is our correct answer. Again, I am telling every student out there, don't feel tension. Tension, depression, demotivation will only bring you down. There is no use to feel tense. See, NEET and JEE are very good thing to do, are very good thing to crack. But your life will not stop even if you are not able to crack it. But just give your best for that exam. Just give your best for that exam and continue giving your best in your life all the time. So there is no use to feel depressed, stressed, demotivated. They are just bringing you down. No, Satyam, not right now. Not right now. Okay? Moving to the next question. Just keep on hustling. Keep on doing what your responsibility. Just for example, our parents have a responsibility to give us good upbringing, right? To support us financially, mentally, emotionally, every way. So they do that. Our responsibility as a student is to study, to do hard work, to be loyal, to be honest towards our preparation, and we should be doing that only. Nothing else. We should be doing that only, nothing else. Just be responsible and be honest towards your preparation. Yes, that is the case. Relatives sometimes are the problem. Just avoid them. Number of moles of KMnO4 required to oxidize 1 mole of ferric oxalate in acidic medium. See, now I will want everyone to focus on the screen because this is an important concept. Let's say the acid is H2SO4. The question is wanting to find the number of moles of KMnO4 required to oxidize 1 mole of iron oxalate. 1 mole of iron oxalate in acidic medium. Either you can balance such equation, but if you are having a bigger redox reaction, there is another method to solve that question by using the equivalence concept. In equivalence concept, you no need to balance the equation. You can directly equate the equivalence. Equivalence of KMnO4 will be equal to equivalence of ferrous oxalate. You can directly solve like this using the concept of redox reaction. Now KMnO4 is +7, ferrous is +2, carbon is +3. In acidic medium, KMnO4 always reduces to Mn2 plus, and iron will be oxidized. It can be oxidized only to +3. Carbon can be oxidized only to +4. Right? Okay. Okay. Yes, we are doing that by equivalent masses. Yes. Okay. Now, for equivalent analysis, you need to find n factor. For n factor of redox reaction, you can use the formula atomicity multiply by change in oxidation number. For whatever molecule, ion, species, you are finding oxidation number, you can find the n factor by this formula. See, +7 to +2 change is 5. And atomicity of manganese atoms are 1 in this molecule, so 1. Now for iron, changes of +2 to +3, atomicity is 1. For carbon, changes of +3 to +4, 1, and atomicity is 2. So the n factor for iron and carbon both will be calculated separately. Now, okay. Now, as both are getting oxidized, so if both are getting oxidized, you can add n factor. If both are getting reduced, you can add n factor. If both are undergoing the same process, you can add n factor. So 1 + 2 total n factor will be 3. So n factor multiplied by mole of KMnO4, that will be equal to n factor of ferrous oxalate multiplied by mole of ferrous oxalate. N factor of ferrous oxalate will be 3. Now 1 mole of ferrous oxalate will require 3 by 5 mole of KMnO4. 3 by 5, that means 0.6 mole of KMnO4. You could solve this question either by balancing, but that n factor method will be the short method. Okay? Okay. Let's move to the next question now. A gas mixture of 3 liters of propane and butane on complete combustion at 25 degrees Celsius produce 10 liters CO2. Find out the composition of gas mixture. We have to find propane to butane ratio. Propane to butane ratio. Okay. Let's see. We are with propane. Propane on combustion will give you CO2 and H2. We are given butane. Butane on combustion will give you CO2 and H2. 1 mole of propane will give 3 mole of CO2 because of this 3, and 1 mole of butane will give 4 mole of CO2 because of 4. Right? Or should that formula will be used in disproportionation reaction. That formula will be used in disproportionation reaction. Now this is a total of 10 liter. Let's say x liter of this and 10 minus x liter of this are present. So 1 liter is producing 3 liter, x liter will produce 3x liter. 10 minus x liter will produce 4 into 10 minus x liter. What is the total volume of CO2? 3x plus 40 minus 4x, that is given as 10 liter. That is given as 10 liter. So 30 is equal to x. 40 minus 10. Yes. X liter. Okay. We are with 3 liter of total. 3 liter of gas. So 3 minus x of butane, that will give you 4 into 3 minus x liter of CO2. So that will be 12 minus 4x plus 3x. That is the total volume of CO2 that is being produced. And this is given as 10 liter. So x will be 2. X will be 2. Now if x is 2, the ratio of propane to butane is 2:1. Option A will be our answer. Option A will be our answer. Yes, right. Okay. Let's move to the next question. An organic compound contains 49.3% carbon, 6.84% hydrogen, and its vapor density is 73. See, Can you solve this question similar to the way that we solve for nitrogen 1? Similar to the way that we solve for nitrogen 1. Similar for same way like we solve for nitrogen 1. We are given vapor density. So the molar mass will be 146. Let's see. 36 plus 5, 41. 41 plus 32. That is not going to be 146. 48 plus 10, 58 plus 32. 72 plus 10, 82 plus 32. 48, 36 plus 10, 46. 46 plus 32. Let's see. Okay, this is 82 plus 64, 6, 146. Only option C is having a total mass of 146. Option C is having a total mass of 146, so that will be our answer. Similar to the way that we solve for nitrogen 1. Similar to the way that we solve for nitrogen 1. Yes. Okay. Let's moving to the next question. Now this is a numerical type question. 10 to the power 22 molecules are removed from 200 milligram of CO2. 10 to the power 22 molecules are removed from 200 milligram of CO2. Calculate the moles of CO2 left. See, we have to calculate mole of CO2 left. So the simplest way to solve this question is what? Just convert both of them in mole. Just convert both of them in mole. Bhuvan Singh, in the previous question, we just used the concept that vapor density is half of molar mass. So molar mass will be double of vapor density. Then we find the molar mass of all the option C match, and that becomes the correct answer. So find moles. Here 10 to the power 22 divided by, let's say Avogadro number is approximately 6. So 1 by 6 multiplied by 10 to the power minus 1. That is the moles that have been removed. 200 milligram. 200 into 10 to the power minus 3 divided by 44 mole. So mole of CO2 that are left will be, total mole present were 2 by 44 into 10 to the power minus 1. Moles that have been removed, 1 by 6 multiplied by 10 to the power minus 1. You can solve this and find the answer easily, right? We converted milligram into gram, then gram to mole by dividing molar mass, and number to mole by dividing with Avogadro number. Okay, let's move to the next question. What volume of hydrogen gas at 273 Kelvin and 1 atm pressure will be consumed in obtaining 21.6 gram of elemental boron from the reduction of boron trichloride by hydrogen gas? Question based on stoichiometry. Yes. Okay. BCl3, boron trichloride, is being reduced with hydrogen, right? Boron trichloride is being reduced by hydrogen. You have to understand how to build the reaction. And then question is saying we are getting pure boron. And the remaining H and Cl, obviously they will be combining to give you HCl. So sometimes some of the reactions will not be taught to you, or you will not be remembering them. So you can build those reactions using the question. Yes, tell me your doubt. Whenever you have any doubt, just post the doubt. I will try to answer that. Now, if we balance this reaction, we are going to have 2 here, 3 here, 6 here, 2 here. So mole of hydrogen divided by 3 is equal to mole of boron divided by 2. Why? Because this has been given, this has been asked. Right? Let's see. Mole of hydrogen will be 3 by 2 multiply mole of boron. Boron is 21.6 gram divided by 10.8. Mole will be mass by molar mass. So that will come to hydrogen mole will be 3 mole. we have to find volume at standard temperature and pressure. So that will be mole multiplied by 22.4, 67.2 liter. 67.2 liter. That will be our answer. Yes. 3 mole of hydrogen. Correct. 3 mole of hydrogen. Correct. Okay. Okay. Raghavendra, try to understand the concept through the question, because we are not left with that much of time that we have all the concept told to you and then do the practice, because ultimate goal is to practice more of the question. The number of question, the more you practice, the more you can solve in your exam. It can happen that you see some question in your final exam and you see, okay, similar type of question I have done and I can try to solve that. Okay, 3 mole of hydrogen is the correct answer, and we have to find the volume of hydrogen, so we convert mole to volume by multiplying with 22.4 liter. Okay, moving to the next question. What will be the density of a 3.6 molar sulfuric acid solution, that is 29% by mass? So this question is again based on molarity. If you read the question, and percentage. So molarity and percentage have a direct relation, and it is better to learn this relation. This is very useful. Molarity is equal to percent D10 by molar mass. Molarity is 3.6. Percentage is 29. Density multiplied by 10 divided by molar mass is 98. So density will be 3.6 multiplied by 98 divided by 29 into 10. You can find the density easily from this relation. Can you find it? 3.6 multiplied by 98 divided by 290. It should come approximately as 1.2 gram per ml. 1.2 gram per ml. Yes. Yes, yes, yes. Okay. Let's move to the next question. 2 gram of a mixture of carbon monoxide and carbon dioxide. Okay, consider this question to be a challenge to you. Consider this question to be a challenge to you. 2 gram of a mixture of carbon monoxide and carbon dioxide on reaction with excess I2O5 produce 2.54 gram of iodine. What will be the mass percentage of CO2 in the original mixture? I am giving you the molar masses: carbon 12, oxygen 16, iodine 127. Yes. And calculator, use of calculator is not allowed to you. If you look at the reaction, I2O5 is being converted into iodine. I2O5 is being converted into I2. Now, this is a typical reduction, removal of oxygen. CO2 is already being oxidized. CO2 is already completely oxidized. It cannot reduce further. CO can be a reducing agent. Can you understand this? That iodine needs to be reduced in this relation, and that's why CO2 cannot do this reaction. So carbon monoxide will absorb all the iodine from here and will produce CO2. But we have to find percentage of CO2 in the original mixture. We don't have to consider this CO2 that has been produced here. Right? The faster calculation is just only by practicing and do some approximation, try to look for the options. Now we are producing, this amount is given, and we can find this amount from here. Mole of CO divided by 5, mole of iodine divided by 1. Every time I am using the same stoichiometric analysis, mole divided by coefficient. So mole of carbon monoxide will be 5 multiplied by mole of iodine, that is 2.54, divided by molar mass 127, double will be 254. So that will be 5 into 10 to the power minus 2. So mass of carbon monoxide in the original mixture will be 5 multiplied by 10 to the power minus 2 multiplied by 28. 8 5 40, 5 to 10, 140. That means we have 1.4 gram carbon monoxide in the original mixture. 1.4 gram carbon monoxide in the original mixture. Yes. Now, we need to find the percentage of CO2. That will be total 2 gram of mass is there. Out of that, 1.4 is carbon monoxide. So, obviously 0.6 should be the mass of CO2 in the original mixture. Multiply by 100. So, 0.6 into 50, that will give you 30%. The mass of CO2 in the original mixture is 30%. Okay. We will see concept of equivalent weight in the redox chapter in a detailed way. Concept of equivalent will be seen in redox chapter. Is this question clear to you all? Moving to the next question. What is the weight of oxygen required for the complete combustion of 2.8 kilogram of ethylene? Ethylene is C2H4. Common name of ethene is ethylene. Common name of ethene is ethylene, C2H4. Let's see. We are going to have combustion of C2H4 with the help of oxygen. That will give us CO2 plus H2O. That will give us CO2 plus H2O. Any organic compound upon combustion will always produce oxides of element present in the compound. Oxides of element present in the compound. Raj Manov, total mixture is 2 gram. Out of that, 1.4 gram is of carbon monoxide. 1.4 gram is of carbon monoxide. We have to find the percentage of CO2. So out of 2 gram, 1.4 is carbon monoxide. So remaining will be, that is 2 minus 1.4. Remaining mass of mixture will be of CO2. That's why 0.6. That's why 0.6. Okay, let's see here. We are given 2.8 kilogram of ethylene. So we have to find the mass of oxygen. Let's balance it first. 2 CO2, 2 H2O, 2, 4, 6, 3 O2. Mole of ethylene divided by 1 is equal to mole of oxygen divided by 3. Right? Now, mole of ethylene will be mass of ethylene in gram divided by molar mass of ethylene is equal to mole of oxygen divided by 3. So mole of oxygen will come 0.3 into 10 to the power 3. Mass of oxygen will come mole multiplied by molar mass in gram. So that will be 3 to 6, 9.6. 1000 can be omitted to write kilogram. So 9.6 kilogram oxygen is required to complete combustion of 2.8 gram of ethylene. For complete combustion of 2.8 gram of ethylene. Right? Okay. Okay. It should be 9.6 gram. Just look at 3. Yes. Look at your balancing. You might have balanced incorrectly. It should be 9.6 gram. 9.6 gram. Okay. Moving to the next question. So, next chapter is now structure of atom. We are going to start structure of atom. Just close your eyes for 2 seconds and try to have this chapter revised up in your mind first. Okay. This chapter involves mainly, if I am to talk about the main thing, so main thing in this chapter is Bohr model and the formulas related to Bohr model, especially 3 formulas. The formula of radius of nth shell, the velocity of electron in the nth shell, and the total energy of electron in the nth shell. These are the 3 main formulas of Bohr model for single electron species. After that, in Bohr model, you also have a condition MVR is equal to NH by 2 pi. You also have that kinetic energy is equal to total energy, just sign is changed, and potential energy is twice of total energy without change in sign. These are 5 things that we have studied in Bohr model. After that, you have Heisenberg's uncertainty principle. Uncertainty in position and momentum is greater than or equal to h by 4 pi. For question, we can use approximately equal to h by 4 pi. Equal to h by 4 pi. De Broglie wavelength is h by momentum or h by under root 2 mk or h by under root 2 m charge multiplied by voltage. For electron, you can use 12.17 or 16 approximately by voltage angstrom. For electron, you can directly use this formula. Then you will have spectral lines. The number of emission spectral lines is given by delta n plus 1 by 2. And Lyman, Balmer, Paschen, Brackett and Pfund says Lyman, Parman, Paschen and okay. No worry, Bhuvan, you can put your question again. You can expect in NEET exam that from every chapter, NEET is like they consider all chapter almost equally and every chapter has equal weightage. They ask direct question based on every chapter almost. Okay. Let's see the first question of this chapter. Among the following grouping, which represent the collection of isoelectronic species? So, can you find me the isoelectronic species? What is the meaning of isoelectronic species? What is the meaning of isoelectronic species? The species which have equal number of electrons. Which have equal number of electrons. These are called as isoelectronic species, right? Yes. NO plus 7 plus 8, 15 minus 1, 14 electron. Carbon 2, 6 into 12 minus 2, 14 electron. 16 minus, that will have 17 electron. 8 plus 6, that will have 14 electron. CO, 8 plus 6, 14, we already found for CO. Cn minus 7 plus 6, 13 plus 1, 14. So obviously option C is having the grouping having isoelectronic series. Yes, equal number of total electrons. Option C is the answer for this question. Option C is the answer for this question. Okay. Let's move on to the next question. The compound in which cation is isoelectronic with anion. Cation is isoelectronic with anion. Na plus Cl minus, cesium plus F minus, Na plus I minus, K plus sulfide minus. Okay. Now you can solve this question in 2 ways. One is lengthy way, that you will find number of electron in all of the ions and then you will compare. Another smart way or easy way to solve this question is you just find which of the cation is in the next period and its anion should be the previous period. Meaning, if cation is in nth period, then its anion should be of n minus 1th period. Then they will have definitely the same number of electrons. So if cation and anion are from consecutive period, they will have same number of electrons. Because cation will lose electron to go to the previous noble gas, anion will gain electron to go to the next noble gas. And that's why they will have same number of electrons if this condition is met, as you can see in this case of potassium and sulfide. So if you knew this trick, the question could be solved in seconds. Otherwise, you have to find the number of electron in all of the ions. Number of electron in all of the ions. Okay. Moving to the next question. The frequency of light emitted for the transition of n is equal to 4 to 2 of the helium plus is equal to transition in hydrogen atom corresponding to which of the following? If frequency is equal, definitely lambda wavelength is going to equal or energy is going to equal. So we have 13.6 z square 1 by n1 square minus 1 by n2. So because if frequency is equal, then energy is also going to be equal. 13.6 Z square 1 by N1 square minus 1 by N2 square. One side I am going to apply for helium plus, another side I am going to apply for hydrogen atom. Check it here. For 13.6 will be cancelled. For helium, Z is 2, so 2 square will be 4. Transition is 4 to 2, so 1 by 2 square minus 1 by 4 square. For hydrogen, Z is 1. 1 by N1 square minus 1 by N2 square. So from here we will get 1 by N1 square minus 1 by N2 square is equal to 3 by 4. Is equal to 3 by 4. Now there is no way to find the value of N1, N2 directly. We can only do hit and trial or put the values from the option. If I put 1 and 2, I will get 1 minus 1 by 4, 3 by 4. This is the only option satisfying N1 and N2. Satisfying N1 and N2. Bhuvan Singh, in previous one, the concept was like that whenever ionic compound is formed, cation is made by losing electrons. So it will move towards the noble gas of the previous period. And anion is made by gaining electrons, so it will move to the noble gas of its same period. So if anion is above and cation is just below, cation will go previously to the noble gas and anion will go ahead to the noble gas. Both will come at the same noble gas and both will have then same electron. So for isoelectronic cation and anion should be of consecutive period. Cation and anion should be of consecutive period. Moving to the next question. In hydrogen atomic spectrum, we are talking about hydrogen atomic spectrum. A series limit is found at 12186.3 centimeter inverse, then it belongs to. You have to find which of the series does this belong to. As we know, Lyman lies in ultraviolet range, Balmer lies in visible range, Paschen and other series lies in infrared range. So either you can have these ranges in your mind, or you can use this value to find the wavelength. Use this wavelength to find wavelength. Wavelength will be 1 upon wave number. So 1 upon 12186.3 centimeter inverse will become centimeter. So that will be, we have to convert in this angstrom, right? So when we will convert into angstrom, 1 centimeter will have 10 to the power 8 angstrom. So you can solve this and find the wavelength, and I think you will find wavelength lying in the Lyman series. You will find wavelength lying in the Lyman series here. So you can just find the wavelength and see which of the light it is belonging to. Which of the light it is belonging to. Moving on to the next question. Now this is a question based on de Broglie equation. And de Broglie equation is more important in this chapter. If I am to say, this chapter involves de Broglie, quantum number. These are the two important topics from which question may come in your exam. Series limit means the first line of any series. The first line of any series, the wavelength or wave number first line of any series. Two fast moving particles X and Y are associated with de Broglie wavelengths of 1 and 4 nanometer. If mass of X is 9 times the mass of Y, the ratio of kinetic energies of X and Y. We have to find the ratio of kinetic energy of X and Y. See, de Broglie equation have three relations. One of momentum, one of kinetic energy, one of voltage. You have to use that formula for which you are going to find the relation. Here kinetic energy is talked about. So X and Y. De Broglie wavelength of X divided by de Broglie wavelength of Y. H divided by under root 2mx, mass of X, kinetic energy of X. H by under root mass of Y, kinetic energy of Y. Now we are given with values, you have to put the values, right? Wavelength of X is 1, wavelength of Y is 4, under root 2 will be cancelled out. Mass of Y, kinetic energy of Y. Now mass of X is 9 times Y. So mass of X will be 9 times of Y, kinetic energy of X. We have to find the ratio of kinetic energy. So just square it, this will become 1 by 16 is equal to ky by 9kx. So kx by ky will come as 16 by 9. The ratio of kinetic energy will be 16:9, that is given in option D. 16:9. Yes. Right? Okay. Moving to the next question. The ratio of magnetic moments of iron 3 and cobalt 2. We have to find the ratio of magnetic moment. Iron 3 plus. That means 4s0, 3d5. 3 electrons have been removed, 2 from outermost shell and the remaining from the d shell. So this has 3d5. 5 unpaired electron. Magnetic moment will be under root 5 plus 2, n plus 2 Bohr magnetron. Similarly for cobalt 2 plus 2 electrons from outermost fourth shell will be lost, 3d7. 1, 2, 3, 4, 5, 6. 4, 5, 6, 7. So this has 3 unpaired electron. Magnetic moment will be under root 3 into 3 plus 2. So we have to find the ratio, that will be under root 5 into 7. And for cobalt it will be under root 3 into 5. 5 will be cancelled out, the ratio will be under root 7 by under root 3. Option C is the ratio of magnetic moment of iron and cobalt. Is that clear to you all? Okay. Let's see the next question. The values of Planck constant and velocity of light is given. Which value is closest to wavelength in nanometers of a quantum of light with frequency? Frequency here is given as 8 into 10 to the power 50. Now frequency and wavelength has a relation of this. Wavelength into frequency is equal to c, speed of light. Yes. So wavelength will be speed of light 3 into 10 to the power 8 divided by frequency, which is 8 into 10 to the power 50. So that will come as 3 by 8 multiplied by 10 to the power minus 7 meter. If you want to convert it into nanometer, multiply by 10 to the power 9. So that will be 300 by 8 nanometer. 60. So that will be 7.5. The closest value of wavelength will be 37.5. These options are obviously not very good. I'm sorry, here the options are misprinted. The answer will be closest to 37.5, or we can mark this is the closest option, 40. Yes. Okay, this is the closest option. Option B, 40 is the closest value in the wavelength closer to nanometer. Okay. Which question is not clear? Tell me. Which question is not clear? Yes, B is the closest answer here. B is the closest answer here. Moving to the next question. Lithium and a proton are accelerated by the same potential. See here. The question is again of de Broglie wavelength. The question is again of de Broglie wavelength, but here potential is given as same. Potential is given here as same. So if potential is talked about, we are going to use the relation of potential. Wavelength is equal to h upon under root 2m q times voltage. I think here lithium plus will be given because we want to have charge. Okay. Yes. Let's see. So their de Broglie wavelength are Li and lambda p, that will have a ratio of h by under root 2mqv for lithium divided by h by under root 2mqv for proton. Both are accelerated by same voltage. Both are accelerated by same voltage, having same h, same 2. So wavelength ratio will come out as mass of proton, charge of proton is 1 divided by mass of lithium, which is 9 times, mass of proton, and charge on lithium is also 1. So that will come as 1 by 3. Ratio will be 1:3. Option D will be answer. 1:3. Yes. Okay. When voltage is same, we are going to use the formula of voltage of de Broglie wavelength. When kinetic energy is talked about, we are going to use the formula having kinetic energy. When velocity is talked about, we are going to use the formula having momentum. Very good. Okay. Moving to the next question. If uncertainty in position and momentum are equal, then uncertainty in velocity is. So the Heisenberg principle says delta x delta p is equal to h by 4 pi. Now both of these are given as equal. Both of them given are equal, right? So if both are equal, we can put delta x, we can put delta p instead of delta x. So delta p will be under root h by 4 pi or 1 by 2 under root h by pi. Now this is the uncertainty in position as well as momentum because both are equal. We have to find uncertainty in velocity. So momentum can be written as mass into velocity. So uncertainty in velocity will be 1 by m uncertainty in momentum. So 1 by 2m under root h by pi. Given an option A, that will become our answer. We don't use Boltzmann formula, Boltzmann constant. The Boltzmann constant is used sometimes in the states of matter chapter. Yes, we will talk about break soon. We will complete this chapter, then we will talk about the break. Ionization energy of helium plus is 19.6 multiplied by 10 to the power minus 18 joule per atom. We are given with the ionization energy. The energy of the first stationary state of lithium 2 plus. See, sometimes these values are given to use them, or you can, without using these values, you can directly use the Bohr equation if you are given with a single electron species. First energy state minus 2.18 multiplied by 10 to the power minus 18 Z square by N square joule per atom. If you directly know the value of constant in the given unit, you can directly use that and you don't need to use this value now. So energy of lithium first excited state 2.18 multiplied by 10 to the power minus 18. The atomic mass of lithium is 3 and the stationary state is 1. So that will be 2.18 multiplied by 9 multiplied by 10 to the power minus 18 joule per atom. The closest answer to 18 I think this should be our answer. Let's multiply it now. Yes, this will be our answer. 19.62 into 10 to the power minus 18. I think some options are misprinted here, but this will be our answer. 19.62 multiplied by 10 to the power minus 18. We could directly find the energy, right? Yes. This is for JEE as well. Yes. Okay. Some options are misprinted in the previous question. Moving to the next question. The kinetic energy. Now this question is basically a challenger question for JEE students. For NEET, they can also solve this question, but this question is specifically for JEE students, that you have to find the kinetic energy of an electron in the second Bohr orbit of a hydrogen atom is. A naught is the Bohr radius. Bohr radius means the radius of first state of hydrogen atom. The radius of first state of hydrogen atom. Okay. See what we are given and what we have to find. We are given with the Bohr radius and second Bohr orbit. Bohr radius is radius of first orbit of hydrogen. So you can write radius in terms of Bohr radius as well. A naught times n square by z, where A naught is the Bohr radius. So for hydrogen atom second orbit, radius will be n will be 4 times A naught. 4 times A naught. This will be the radius of second Bohr orbit. And the question is talking about kinetic energy. Now we know that this is our first thing. Using Bohr analysis, MVR should be equal to NH by 2 pi. So in the second orbit, the momentum MV will be N is 2 H by 2 pi, and radius of second orbit we have already calculated 4 A naught. So that will come as H by 4 pi A naught. Now we have to find kinetic energy. So kinetic energy will be momentum square divided by twice of mass. Momentum square will be H square. 16 into 2, that will be 32 pi square A naught square and M. So H square by 32 pi square A naught square M is the correct kinetic energy. We use 3 concepts here. First of radius, then Bohr quantization condition, and then we use the kinetic energy and momentum relation from physics. Correct. How many of JEE aspirant could solve this question before me? How many of JEE aspirant could solve this question before me? See what we did here. First of all, Bohr radius is first orbit, so we found the radius for the second orbit. For any single electron atom, you can use the Bohr condition of MVR is equal to NH by 2 pi. Whenever you want to find momentum and radius relation, this is the best formula. From here, we could find the momentum value, m into v is momentum. And then we find kinetic energy using momentum. Okay, moving to the next question. If the nitrogen atom had electronic configuration of 1s7, it would have energy lower than that of normal ground state configuration 1s2, 2s2, 2p3, because the electrons would be closer to the nucleus. Yet 1s7 is not observed, it violates. Which law is violated by 1s7 configuration? Today we are going to complete both to 11th and 12th. Yes. See, what happens? Any orbital can occupies only 2 electrons, and that is because of the Pauli's exclusion principle. According to Pauli's principle, no 2 electrons can have the exact same value of all the 4 quantum numbers. If any orbital has more than 2 electrons, then you will find electrons having same values of all the 4 quantum numbers. So whenever we are filling more than 2 electrons in a given orbital, we are violating Pauli's principle. So it violates Pauli's principle. Option C is the answer. Yes, option C is the answer. Moving to the next question. In a hydrogen atom, if energy of an electron in ground state is 13.6 electron volt, then in the second excited state. Now, second excitation means n is equal to 3. Because n is equal to 1 is ground state, n is equal to 2 is first excitation, n is equal to 3 is second excitation. Yes. Which question is street right? Which question? Now n is 3. So energy will be ground state energy, that is 13.6. Z square for hydrogen, Z is 1 divided by N square, that is 9. So that will come as 1.51 electron volt. 1.51 electron volt. Option A is the correct answer. Yes. Yes. 13.6 by 9. Correct. Very good. Now this is again a very good question. Try to solve this question again. If the radius of first orbit of hydrogen atom is A0, that is Bohr radius is A0, the de Broglie wavelength of an electron in third orbit is. The same concept of kinetic energy is going to be used here. The same concept of kinetic energy is going to be used here. Okay. Let's see here. Radius of first atom orbit is given A0 and we are talking about third orbit. So we will find radius of third orbit by A0 N square by Z. For hydrogen atom they are talking about, yes, 9A0. Now again de Broglie wavelength and momentum has a relation. De Broglie wavelength and momentum has a relation, right? So MVR, momentum we will find, is equal to NH by 2 pi. Momentum will be equal to, for third orbit, 3H by 2 pi, and radius of third orbit is 9A0. So that will be H by 6 pi A0. Now we will directly use de Broglie wavelength is equal to H by momentum. So that will be H by 6 pi A0. Wavelength will come as 6 pi A0. Wavelength will come as 6 pi A0. Right? Yes. Correct. Option C is our answer. Option C is going to be our answer. Correct. Very good. Very good. Those who are solving question genuinely are going to do something better. Even those who are finding answer incorrect are going to do better than those who are not solving question by themselves. Yes. Very well. Okay. So the next question is, which of the following radial distribution graphs correspond to L is equal to 2 for the helium atom? For the helium atom. Now, L is equal to 2 means d orbital. L is equal to 2 means d orbital. And in hydrogen atom, the first d orbital will be in the third shell. We can check for any graph just by finding the number of node. Radial nodes are n minus L minus 1. N is 3, L is 2, N is 1. So that will come as 0. So we have to choose that graph which has 0 radial node. 0 radial node. Anytime origin and infinite point are not considered as node. So this has 2 nodes here. 2 radial nodes are there. Nucleus and infinite are never considered as node. So this only has 1 node. This has a very high maxima and this also has 0 node. So both of them has 0 node, but this has very high maxima and that is not possible for D subshell. D subshell cannot have very high maxima. So this is the correct answer. Option C is the correct graph which is for D orbital. Which is for D orbital. Yes, third option is the correct option. Third option is the correct option. Okay, moving to the next question. If the kinetic energy of electron is increased 4 times, the wavelength of the de Broglie wave associated with it would become. This question you all have to give the answer. This is a direct formula based question. Can you give me a quick answer for this question? If the kinetic energy has become 4 times, wavelength will be. Kinetic energy has become 4 times, so wavelength will become half. Right? Option B is going to be our answer, right? Yes. Yes. Okay. Moving to the next question now. The correct set of 4 quantum numbers for the valence electron of rubidium. Now we don't need to do the electronic configuration of rubidium. Use the information of periodic table. Lithium, sodium, potassium, rubidium, cesium. Second period, third period, fourth, fifth, sixth. So rubidium will have an outermost configuration of 5s1 from the periodic table. 5s1, right? Yes, 5s1. So if it is 5s1, that means n will be 5. For sl will be 0, ml will be 0, and only one electron is present. So ms will be either, you can have any value of spin, plus half is also correct, minus half is also correct. 5, 0, 0, plus half or minus half, both are correct. In an empty orbital, first electron can be filled in upward direction or first electron can be filled in the downward direction. Both will be considered correct. Both will be considered correct. Yes, 5 is the outermost shell. 5s is the outermost shell for rubidium. Correct. Moving to the next question. If lambda naught and lambda be threshold wavelength and wavelength of incident light, velocity of photoelectron ejected from the metal surface. So this is a question of photoelectric effect. When we incident a light on a metal surface, some of its part is lost in work function and rest appear as kinetic energy. Right? The organic revision has already been completed. Lol, don't ask lol question. So kinetic energy will be E minus W. Now E is hc by wavelength of incident light, W is hc by threshold wavelength. So half mv square is equal to hc lambda naught minus lambda by lambda naught lambda. We just took lambda and lambda naught as the LCM. So velocity will come as under root twice of hc by m lambda naught minus lambda divided by lambda naught lambda. That will be the velocity of ejected photoelectron. And I think that is given in option C. So a fusion of question on photoelectric effect and de Broglie equation. Yes, option C is the correct answer. Option C is the correct answer. Okay, moving to the next question. If m and e are the mass and charge of revolving electron in the orbit of radius r for hydrogen atom, the total energy of the revolving electron will be. The total energy of revolving electron will be, and we are given with r. Again, if we are given r, we can find mvr is equal to nh by 2 pi. Is that correct? mvr is equal to nh by 2 pi. They are not talking about n, so we will assume n to be 1. We will assume n to be 1. So mv will be h by 2 pi r. mv will be h by 2 pi r. Okay. And another relation that we know, that centripetal force mv square by r is balanced by k q1 q2 by r. No need to use centripetal force here. Now kinetic energy will be p square by 2m, momentum by 2m. So that will become h square by 4 pi square r square 2m. That will be our kinetic energy of electron in terms of radius and mass. Radius and mass. Right? Okay. Now potential energy. If we talk about potential energy, potential energy will be k times of q1 q2 by r, where k is 1 by 4 pi epsilon naught. q1 is E, 1 proton, 1 electron divided by r, and minus sign because charge is negative. So it will be minus E square k E square by r. This is our potential energy. Similarly, potential energy is term of E square by r and kinetic energy is term of h square by r. So we can use that relation that kinetic energy is nothing but double of half of potential energy with opposite sign. So kinetic energy will be plus, let's call it K1, plus Ke square by 2R. So total energy of electron will be minus Ke square by R plus Ke square by 2R. So that will give us minus Ke square by 2R. Now the options are having missing value of K. The electrostatic constant K should be there, or we have to find the proportionality relation. So minus K square by 2R, option D is the answer. Option D is the answer here. Yes. Yes. Minus K Z square by 2R. Yes. Correct. Okay. Moving to the next question. Energy of an electron is given by this relation, okay, 2.178 into 10 to the power minus 18 joule J square Z square by N square. What is the wavelength of light required to excite an electron in a hydrogen atom from 1 to 2? We have to find the wavelength of electron. See, there are two methods. First of all, in any transition, you can find energy difference, and using that energy, you can find the wavelength. Or there is an alternative method. For any transition, wavelength can be directly found by this formula. What we do, we learn formulas in Bohr model. Why? Because it will save time in calculation. We can use this energy, no doubt. We can use this energy, use the formula energy Z square 1 by N1 square minus 1 by N2 square. Find the energy for the transition, then use Hc by lambda and use that energy to find lambda. This is one long method to solve this question. Another alternative is if you know the direct formula for wavelength of any transition. 912 by Z square 1 by N1 square minus 1 by N2 square angstrom. Okay. Now, we are talking about hydrogen atom. Z will be 1. 1 by N1 square, N1 is 1. 1 by N2 square, N2 is 2. So 2 square will be 4. That will become 3 by 4. So 912 divided by 3 multiplied by 4. So that will be 304 multiplied by 4. That will give you 1216 angstrom. See, that alternative approach saves so much of our calculation for this question. If we had solved using the first approach, we would have done so many calculations to find that answer, approximately 1216 angstrom. 1216 angstrom. Right? Yes. Moving to the next question. What is the de Broglie wavelength of an electron in the ground state of hydrogen atom? So in the ground state of hydrogen atom, we are given with velocity 2.18, or we can use the kinetic energy concept. Okay, we are given with kinetic energy. Kinetic energy is given as 13.6 electron volt. So the wavelength will come as h by under root 2 mk. H will be 6.6 multiplied by 10 to the power minus 34 divided by under root 2. Mass of electron will be 9 into 10 to the power minus 31. Kinetic energy is given as 13.6 and electron volt is given as 1.6 into 10 to the power minus 19. Now there is no alternative only to solve this wavelength equation to find lambda. You have to solve it and find lambda by yourself. You have to do this calculation. Sometimes question require some lengthy calculation. You cannot be saved from every question. I try to make your calculation easier, but sometimes you have to solve it by yourself. Okay? So now we are going to move on to the next chapter. But before that, we will have a break of, let's say, a break of 10 minutes. After that, we will resume our session. So go on till then, have some refueling, do some refuelings, eat something and come back again with more of energy. Okay? Okay, the break time is about to get over. I hope everyone has refueled. Yes? Okay. And this code is just for you. If you get tired, have some rest, have some energy gained back, and then be back, bounce back again with full force. Okay. We are going to start another chapter, which is states of matter, and also we are slowly going up in the ladder of importance of physical chemistry. Now the chapters that are going to come are going to be more important for your exam. Right? States of matter is a very basic chapter. It has two portions. One is all about ideal gas equation. If you know what is PV is equal to nRT, what is PV is equal to nRT, you can solve almost any numerical based on ideal gas equation. Why? Because every ideal gas follow PV is equal to nRT, and all gases are independent. If you get a mixture, also you can apply PV is equal to nRT. If you have 5 gases, you can apply this ideal gas equation on any individual gas, a group of gas, or all the gases combined. Right? Okay. In the last question, the answer was approximately 3 into 10 to the power minus 3. Yes. And the second thing is about real gas. Real gas has real gas equation given by Van der Waal, P plus n square A by V square, V minus NB is equal to nRT, where A is representing the intermolecular attraction and B is representing size of gaseous particle, volume of gaseous particle. And third thing about real gas is compressibility factor. Many students become confused in this compressibility factor. Just remember one thing, that compressibility factor is not directly compressibility. Compressibility factor is not representing directly the compressibility. You can think of this is inverse of compressibility. That means if the compressibility factor is higher, gas is going to be less compressible. And if gas cannot be compressed easily, that means it has more repulsion. So if Z is more than ideal value, that is 1, gas is having more repulsive forces. If Z is less than 1, compressibility is more, attraction force is more. Yes. Yes, very good, correct methods. At high temperature and low pressure, real gas behave approximately as ideal behavior. Z is representing compressibility factor. Let me take an example. Z is 1 for ideal gas, you all know that. Suppose Z is 1. That means PV of gas that we are talking about is greater than PV of ideal gas. Right? Because Z is PV upon PV ideal. If you are confused on Z, let me handle that confusion now. So PV of gas is greater than PV of ideal gas. That means volume of gas is greater than volume of ideal gas at same pressure. At same pressure. Now what is the meaning of that? You applied some pressure, the ideal gas compressed more because it has having less volume, and the real gas that we are talking about compressed less. More volume means that it has been compressed less. So that definitely means if Z is more, compressibility of gas is less than ideal gas. So Z and compressibility are reverse in relation. If compressibility factor is higher, compressibility of gas is going to be less. Compressibility of gas is going to be less because during compression we reduce the volume. During compression we reduce the volume. Yes, if Z is less than 1, attraction are dominating. If Z is more than 1, then repulsion force are more dominating. Okay, let me start now this session. Let's see the first question. The volume temperature graph of a given mass of an ideal gas at constant pressure shown below. What is the correct order of pressure? You can solve this question by using volume temperature, so Charles law. But we are not going to use any individual law independently. We are always going to use PV is equal to nRT. See, PV is equal to nRT. That means V is equal to nR by PT. Now volume temperature graph will be a straight line with the slope nR by P. Isn't that correct? Volume temperature graph will be a straight line with slope nR by P. So if P is more, slope is less. If P is more, slope is less. So when you increase pressure, volume temperature graph moves toward the temperature axis. When you increase temperature, volume temperature graph moves towards the temperature when you increase the pressure. So obviously we got the relation P1 should be more than P3, P3 should be more than P2. P1, P3, P2, that should be our order. P1, P3, P2. Option A will be our correct order. Right? Yes. Okay. Okay. Moving on to the next question. The inversion temperature of hydrogen is, we have to find the inversion temperature. Do you know what inversion temperature is? It has been mentioned in Joule-Thomson effect. Inversion temperature is the temperature above and below which real gas shows heating or cooling effect upon expansion. So inversion temperature formula is given by 2A by RB. We are given all the values in the respective unit. So Van der Waals constant A is 0.244 multiplied by 2 divided by B is 0.027, R is 0.0821 atm liter per mole Kelvin. Always be cautious about the value of R according to its unit. As all values are in atm liter, so we have put the value of R in the unit of atm liter. Yes, yes. Now can you solve this relation? Let's see. We are going to approximate. This will be 244 multiplied by 2 divided by 27 multiplied by, approximated to 0.08, so it will become 8 by 100. That will be 4. 4, 6 is 24. 1. So 6100 divided by 27. Let's approximate further. 6000 divided by 30. That will give you closest to 200 Kelvin. The answer should be close to 200 Kelvin. One option is given which is closer to 200. That will be our answer. That will be our answer. Yes, right. Okay. Okay, moving to the next question now. The temperature of the gas is raised from 27 to 927 degrees Celsius. The RMS velocity is, this is not 7. We have to find the RMS velocity. How much time it has been changed? How much time the RMS velocity is changed? No, this is not particularly for CUET, but in CUET you can also expect some of the similar type question. Okay, let's see. What is the formula for RMS velocity? RMS velocity is under root 3 RT by M. 3 RT by M. Now temperature is raised. So V1 by V2 will be under root T1 by T2. Rest all the things are same. Molar mass of gas is not going to change. Other things are not going to change. Initial temperature is 300. Final temperature is 927 plus 273, that is 1200. So V2 will be 2 times of V1. That is RMS velocity of gas is going to be doubled of the previous value. Just remember one thing, for temperature always put temperature in Kelvin whenever you are using ideal gas equation. Yes, under root 3 RT by M. Under root 3 RT by M, RMS velocity will be doubled than the previous value. You can find the answer as well. If temperature is increased all the time, whenever temperature is increased, particles are going to be moving with a faster speed. So speed is going to increase, that is definitely. This cannot happen. This cannot happen. 2 are left. This is also not correct because temperature is in degrees Celsius, not changed here. So only option D is the correct answer. Sometime you can do some smart work and find option quickly in your final exam. That will save time for other question. That will save time for other question. Okay, moving to the next question. Equal masses of methane and oxygen are mixed in an empty container at 25 degrees Celsius. The fraction of the total pressure exerted by oxygen. We can solve every question from PV is equal to nRT. I am telling you again. But sometimes other laws help in solving the question quicker. Dalton's law of partial pressure says partial pressure of any gas is mole fraction of that gas multiplied by total pressure. So for oxygen, the partial pressure will be mass is equal. So mole of oxygen divided by total mole, that is mole of methane plus mole of oxygen multiplied by total pressure. So that will give you 1 by 2 divided by 2 plus 1 by 2. Just a minute. We will multiply whole expression by 32. So that will become 1 divided by 2 plus 1 into total pressure. So the partial pressure of oxygen is one third of total pressure. 1/3 of total pressure. Yes. Okay. Moving to the next question now. Keep on solving the questions that will build your calculation, that will build your concept, that will build your formulas. And while solving the question, do not look at your notes to see formula. There is only one thing to memorize all the formulas by not looking at them all the time. Okay. The next question is the ratio between the root mean square speed of hydrogen at 50 Kelvin and that of oxygen at 800 Kelvin. Again, root mean square of hydrogen divided by root mean square of oxygen gas. They are talking about hydrogen and oxygen. Whenever they are talking about any gas, always take them in their molecular form. Hydrogen molecular form is H2. Under root 3R, temperature for hydrogen is 50, molar mass of hydrogen is 2, divided by 3R, temperature for oxygen is 800, molar mass of oxygen is 32. So we can say that the ratio is coming to be 1. The ratio of RMS velocity of both of them is coming to be 1. Yes. Option C is the answer here. Very good. Yes, you can surely expect same level of question. See, NEET and JEE differs only in two things. NEET is a game of time. Okay. The more quickly you solve the problem, the more chances are of your selection in JEE. JEE is a game of tricks and concept. Sometimes JEE option seems correct to you, but that are actually incorrect. So you have to be more clear on concept if you want to give JEE exam. Another thing is, in NEET questions, mainly single concept are applied in a single question. Multi-concept questions are not asked. In JEE, sometimes two concepts are merged in a given question. That is the only difference in NEET and JEE, in my opinion. Okay, moving to the next question now. Calculate the total pressure in 10-liter cylinder which contains this gram of helium, this gram of oxygen and this gram of nitrogen at 27 degrees Celsius. See, we are given with a container and we want to find the total pressure. So I am going to apply the ideal gas equation for total pressure. Total pressure will be total moles RT by volume. So total mole will be 0.4 of helium by 2, 1.6 of oxygen and 1.4 of nitrogen multiplied by 0.0821 because R is taken in ATM liter because pressure is to be found in ATM. Multiply by temperature in Kelvin, that is 300, divided by volume. Volume of the container is 10 liter. So that will come as 1 by 5 plus 1 by 20 plus 1 by 20. Multiply by 8 into 3 is 24. So 240. 2.4 will be there, right? 8 into 3 is 24 into 10, 2.4. So that will come 4 by 24 plus 1, 5 plus 1, 6. 6 by 20 multiplied by 2.4. 4, 3, 12, 3 to 7, 0.72. The closest answer to 0.72 is not here. Let me check the calculation once again. Okay, the molar mass of helium I have taken wrong. That will be 4. I took the molar mass of hydrogen. Right? Okay. No problem. This will be 1 by 10 plus 1 by 20 plus 1 by 20 multiplied by 2.4. So that will be 2 by 20. 2 plus 1, 3 plus 4. 4 by 20 multiplied by 2.4. So that will be 0.48. Answer close to 0.48. Option A is the correct answer for total pressure. Option A is the correct answer for total pressure. Right? Yes. Okay, moving to the next question. A bottle of dry ammonia and a bottle of dry hydrogen chloride connected through a long tube are opened simultaneously at both ends. Now, this is a question which I think every NEET and JEE aspirant has seen or done in their life. We have to find where the white ammonium chloride ring will be first formed, and this has been asked 2 or 3 times previously in JEE Mains, JEE Advanced and NEET all 3 exams in some different way. In some different way. Okay. Yes, there will be batch for JEE Advanced as well. Already we are doing JEE English crash course. From this end, ammonia bottle has been taken, and from this end, HCl bottle has been taken. The one way to solve this question is by understanding when ammonia and HCl will combine, they will form NH4Cl. Salt will be produced, and this ammonium chloride is the reason for white fume formation. This ammonium chloride is the reason for white fumes formation. Okay. Now, rate of diffusion is inversely proportional to molar mass. So, can I say that ammonia will move faster? Ammonia will go quick jumper. Ammonia will move faster because molar mass of ammonia is less. So, up to midpoint, ammonia is moving faster, so it will come first. Chlorine HCl will be behind because it is moving slowly. After that, ammonia will start moving ahead. It will not wait for chlorine HCl to come here. HCl will move ahead as well. And finally, at this point, they will come in contact first time. So as HCl is moving slowly, so the first contact will be near HCl end. You are going to meet your friend, you are moving faster, your friend is moving slowly. So obviously you will meet somewhere near to his house, right? So similar way, ammonia is going to move more because it can move faster. So the first contact will be near HCl, near the hydrogen chloride bottle. Option B will be our answer. Near the hydrogen chloride bottle, option B will be our answer. Okay? Yes. Moving to the next question now. A mixture of two gases A and B in the mole ratio 2:3 is kept in a 2-liter vessel. A second 3-liter vessel has the same two gases in the mole ratio 3:5. Both gases mixture have the same temperature and same total pressure. They are allowed to intermix and the final temperature and the total pressure are the same as the initial value, the final volume being 5 liter. Given that molar masses are Ma and Mb, what is the mean molar mass of the final mixture? Now this question is a little lengthy question. Let me have a blank slide here. What is happening for C? We are having A and B in the first mixture, and A and B are in the ratio of 2:3 in a 2-liter flask. In a 2-liter flask. Another 3-liter vessel has 3:5. Another 3-liter vessel has 3:5 of mole ratio of A and B. Right? Temperature is same, total pressure is same. So pressure can be assumed as P, total pressure, and total pressure here is also P. Now both are mixed. Now both containers are mixed and final temperature and total pressure are the same as the initial value. That is, final temperature and final pressure is not changing. And the final volume is 5 liter. So that clearly means when both are mixed together, let's say both are connected, the final pressure is P, the final volume is 5 liter. Finally, A and B both are present in both of the container and the temperature is not changing anyhow. The temperature is not changing anyhow. We have to find the molar mass of, average molar mass of the final mixture. Let's see. First of all, if I talk here, let's say the mole of A is 2x, mole of B is 3x. You can take x to be 1, then answer will be same. 3y and 5y. 3y and 5y. Is the mole going to change upon mixing? Is the mole, who have some focus in this question, this is a little bit tricky question, or you can say many concepts are involved here. So first of all, when they are mixed together, is the mole going to change? No. That means total mole of A will be 2x plus 3y and total mole of B will be 3x plus 5y, right? Now, as nothing is changing, pressure is not changing, volume is not changing, temperature is not changing. So I can assume that if 2:3 was here, so here also the ratio is 2:3 and 3:5. That means I can assume x and y to be 1. So total 5 moles of A are here and totals 8 moles of B are here. Because everything else is not changing, so we can assume that mole will be simply added. Mole will be simply added. Now, the average molar mass of any mixture is given by total mass of mixture, total moles of mixture. So total mass of mixture will be 5 times of molar mass of A plus 8 times of molar mass of B divided by total moles, that will be 5 plus 8. 5 plus 8. So we will get answer as 5 Ma plus 8 Mb divided by 13. 5 Ma plus 8 Mb divided by 13. Option A will be our answer. Option A will be our answer. We can directly add the mole as nothing other parameters were changing in the previous question. If pressure was changing or volume was changing or temperature was changing, then we have to think about something else. Okay, moving to the next question now. As the temperature is raised from 20 to 40 degrees Celsius, the average kinetic energy of neon atom changed by a factor of which of the following? Temperature is increased and we have to talk about average kinetic energy. What is the relation? What is the relation between average kinetic energy per molecule and temperature? 3 by 2 kBT. 3 by 2 kBT. So K2 by K1, final kinetic energy by initial will be T2 by T1. T2 by T1. So K2 will be, T2 is 40 degree, that means 313 Kelvin. T1 is 293 multiplied by K1. So direct formula based question. Direct formula based question involving nothing. Yes, correct. Correct. Option A will be our correct answer. Okay, moving to the next question. Equal masses of hydrogen, oxygen and methane have been taken. Whenever the question is saying equal mass, you can assume the mass to be 1 gram, 5 gram, 10 gram, anything, or W gram. Volume V, temperature 27 in identical condition, the ratio of the volume of gases. The ratio of volume of gases if all the conditions are identical. See, we know that volume is proportional to mole. So mole will be W by 2 for hydrogen, W by 32 for oxygen, W by 16 for methane. Mass is same. So the mole ratio is this and volume ratio will be this as well, because under identical condition volume and mole are proportional. Volume and mole are proportional. Multiply whole expression by 32 and divide by W, you will get your ratio, that will be 16 ratio 1 ratio 2. 16 ratio 1 ratio 2 is the volume ratio under identical condition for the given gas. Option C will be our correct answer. You can see that states of matter questions are much simpler because they involve a good crystal concept. Right? A single equation can solve states of matter completely. Okay, moving to the next question. Equal moles of hydrogen and oxygen gases are placed in a container. Again, moles are equal, let's say N and N, with a pinhole through which both can escape. What fraction of the oxygen escapes in the time required for 1/2 of the hydrogen to escape? Whenever we have a diffusion or effusion, we can directly use Graham's law. For hydrogen and oxygen, the rate of diffusion is inversely proportional to square root of molar mass. So molar mass of oxygen divided by molar mass of hydrogen. Now rate of diffusion of hydrogen will be mole diffused. So half of mole of hydrogen has been diffused in T times. We have to find the mole of oxygen diffused in the same time T, under root 32 by 2. That will be 16. So mole of oxygen diffused will be 1 by 8. 1 by 8. That means in the time when half of oxygen has been diffused, 1/8 of oxygen will be diffused. Half of hydrogen has been diffused. In the same time, 1/8 of oxygen will be diffused. Okay. Moving to the next question now. Which one of the following statement is not true about the effect of increasing temperature on the distribution of molecular speed in the gases? Any molecular speed is all the time directly proportional to square root of temperature because kinetic energy is directly proportional to T. Whether we talk about most probable, average or RMS, everything is directly proportional to under root T. Right? Okay. The area under the distribution curve remain the same as under the lower temperature. We will see about this. The distribution becomes broader. The fraction of the molecules with the most probable speed increases, or the most probable speed increases. This is correct, that we know. Now let's talk about the Maxwell distribution graph. Fraction of particles on the y-axis, velocity on the x-axis, and the graph is something like this: temperature. The good thing about this graph is that the area under the graph represents total particle. So if we increase the temperature, is total particle going to increase? No. So we can say that this is also true, that the area under the graph is not going to change whether we increase it or decrease temperature. Why? Because the total number of particles is not going to change, and that is represented by area under the graph. That is represented by area under the graph. Second thing is distribution becomes broader. See what happens. When you increase temperature, MP increases. So obviously this most probable point is going to move forward. So if this will move forward, the graph will come a little bit downward. The graph will be having a little bit compression from the above side. Let me make the graph in the second axis. It will become something like this. So the graph will lower in the height. That means the distribution will become broader. The fraction of the molecule with the most probable speed decreases, not increases, decreases. So this is only the incorrect option here. Most probable speed is going to increase, but the fraction of number of particles having most probable speed is going to decrease. Right? Okay. So C is the only statement which is not correct. For 1 mole of an ideal gas at a constant temperature T, the plot of log P versus log V. Let's see. PV is equal to nRT. So log P, taking log on the both side, log V, log of AB is equal to log A plus log B. is equal to log nRT. So that will give you log P minus log V plus log nRT. That means if we plot a graph between log P and log V, this is going to be a straight line, negative slope, and positive intercept. Negative slope and positive intercept. Let's see. A straight line parallel to x-axis? No. A straight line with a negative slope? Correct. Curve stalling at origin? No. Curve will not be obtained. A straight line passing through the origin? No. Intercept is positive, not origin. So only option B is correct regarding the graph. Option B is correct regarding the graph. Right? Yes. Okay. Moving to the next question. When CO2 is passed over red hot coke, it partially gets reduced to carbon monoxide. Upon passing 0.5 liter of CO2 over red hot coke, the total volume of the gas increased to 700 ml. The composition of the mixture. Okay. Gas analysis involved with mole analysis. First of all, let's see here. We are having CO2 is passed and we are having 500 ml of CO2. Okay, I think there is again a misprinting. 0.5 liter of CO2 and carbon monoxide mixture. A 500 mixture is passed over red hot coke. Why mixture? Because it will be mixture, then we will find the composition. No, it is the mixture. 500 ml mixture is passed over red hot coke and the volume of gases increased by 700 ml. See how we will solve it. Let's say in the mixture we have x ml CO2, then we will have 500 minus x ml carbon monoxide. And when the mixture is passed over carbon, this CO2 is being converted into carbon monoxide. 1 mole will give 2 mole and volume are proportional. So x ml will give 2x ml of CO2. So now the new volume of mixture will become 500 minus x, that's much CO is already present. And after change of this, we are having 2x ml of new CO that has been produced. So the total volume of the final mixture is 500 plus x and that is given as 700. That is given as 700. So x will be 200. We got the composition of the mixture 200 ml CO2 and remaining 300 ml. 200 and 300 ml. Okay. The composition of the original mixture is 200 ml and 300 ml. Total should be 500, right? Total should be 500. And the final composition will be 0 ml and 700 ml. That is your final composition. That is your initial composition, 200 and 300 ml. Moving to the next question. For gaseous state, if most probable speed is denoted by C star, this is most probable, average speed by C bar, and mean square speed by C, then for a large number of molecules, the ratio of these speed. Can you tell me the direct answer for this question? Many of you have learned this ratio. Or we can say the most probable, average, RMS. Most probable have under root 2. Average has under root 8 by pi. And this has under root 3. So if this is 1, this should be greater than 1. This should be more greater. So this should be in the increasing order. 1, 1.28, 1.225. Option C is the correct order. Option C is the correct order. Okay. Right? Yes. Let's see the next question now. Sulfur dioxide and oxygen were allowed to diffuse through a porous partition. Again a diffusion. 20 liter of SO2 diffuses through the porous partition in 60 seconds. The volume of O2 in liter which diffuses under the similar condition in 30 seconds will be. Let's see. the rate of diffusion of oxygen divided by rate of diffusion of SO2 will be in the inverse ratio of molar mass, that is 64 divided by 32. Now volume of oxygen that has been diffusing in 30 seconds divided by volume of SO2. So volume of SO2 is 20, that has been diffusing in 60 seconds, is equal to under root 2. So volume of oxygen that has been diffused will be 10 under root 2, that is 14.14 liter or decimeter cube. Option B will become our answer, right? Are all of you solving the question? See, you have to solve the question by yourself. You don't have to look at it like a movie, because then only my concept will become stronger, not yours. You have to solve these questions. Moving to the next question. If Z is now this is a good question. This type of question you can expect in your NEET and JEE exam. This is a good question. If Z is the compressibility factor, van der Waals equation at low pressure, you have to think what will happen at low pressure. At low pressure, the volume of gas particle will be very large. So at low pressure, we can approximately neglect B. At high pressure or high temperature, you can ignore the van der Waals constant A, and at low pressure, you can ignore B. And at low pressure, you can ignore B. Okay, yes. So if you have ignored B, the van der Waals equation will become P plus, we can assume mole to be, let's say mole is now N square A by V square, V minus NB, now B has been neglected, is equal to nRT. So PV is equal to nRT minus N square A by V. We have just opened the bracket on both sides. Divide both sides by nRT, so this will become Z PV by nRT. This will become 1 minus divide by NAVRT. When we divide by nRT, it will become 1 minus NA by VRT. There is one more thing you can see from here. If pressure is high, compressibility factor, if pressure is low, compressibility factor is less than 1, that is at low pressure, gases are going to be more compressible. Low pressure, Z is 1, compressibility is higher. Compressibility is higher. For 1 mole, the option B will be the correct answer. For 1 mole, the option B will be the correct answer. Z is equal to 1 minus A by VRT. And let me tell you, this is for gases at high pressure or high temperature. Under these conditions, Z comes as greater than 1 because you can ignore A, van der Waals interaction. Okay. Moving to the next question. 56 gram of nitrogen and 96 gram of oxygen are mixed isothermally. What is the meaning of isothermal? Temperature is going to be constant and at a total pressure of 10 atm. The partial pressure of oxygen and nitrogen are. So if we see, this is having 2 moles and this is having 3 moles. So we can directly use Dalton's law, partial pressure of oxygen, mole fraction of oxygen into total pressure, so that will be 6 atm. The nitrogen pressure can directly be found 10 minus 6, that is 4. So 6 and 4, first of all we have to find oxygen, then we have to write nitrogen. In the order of oxygen and nitrogen, 6 and 4 will be our answer. Yes, temperature is constant. 6 and 4 will be our answer. Not A or D. Not A or D. You have to choose one of the option, and that's why they give you the sequence. If they have given oxygen first, nitrogen second, you have to write the pressure of oxygen first, nitrogen later. Yes. Let's see another question. 2 vessels containing gases A and B are interconnected as shown in the figure. The stopper is open, the gases are allowed to mix homogeneously. The partial pressure of A and B in the mixture will be respectively. See, now this is a typical question to show you the versatility of PV is equal to nRT. The versatile nature of PV is equal to nRT. How? See, when we are talking about gas A, we can totally ignore gas B. I'm going to totally ignore gas B. What I'm going to do? Everything else is constant. So P1 V1 is equal to P2 V2. The partial pressure of A is 8. Volume is 12. The partial pressure of A final we have to find. And after opening this stopcock, the gases will diffuse thoroughly. That means A will be present here as well as here. So the total volume will be 12 plus 8, that is 20. So partial pressure of A will come as 24 by 5, 1.2 atm. The partial pressure of A after diffusion is 1.2 atm. Right? Let me just check it once again. 12. Yes, 1.2 atm. No, it should not come this less. 12 liter, 8 liter. That is correct. Okay, we will see. Partial pressure of B will be, B is 8 into 5, P1 V1 into total volume is 20. So partial pressure of B will be 2 atm. Partial pressure of B will be 2 atm. So that will be 2 atm. Yes. This is 24 by 5. So that will be 4.8. Option C is the correct answer. Option C is the correct answer. Right? So while solving for A, I totally ignore B. And while solving for B, I totally ignore A. That is the versatility of PV is equal to nRT. Let's move to the next question. Let the most probable velocity of hydrogen molecule at a temperature of T degrees Celsius be V0. When the temperature is raised to this, the new RMS velocity is supposed to all the molecule dissociate. Okay. Now this question involves 2-3 things. First of all, most probable RMS. Both of these velocities are involved, right? Then temperature is changed from T to 2T plus 273, and then molecules are also dissociating into atom. See, we are going to list the characters. V most probable for hydrogen molecule at T plus 273 Kelvin. First of all, they are talking about this case. Next, all the hydrogen molecules are dissociated into hydrogen atom. The temperature has been raised to 2T plus 273 plus 273. You can see that in Kelvin scale, the temperature has just doubled. The temperature has just doubled. And here we have to find RMS velocity. So most probable for hydrogen and RMS for hydrogen atom. RMS for hydrogen atom divided by most probable for hydrogen gas is equal to under root 3R. Let's call this temperature as T, so this is 2T. 3R, temperature has been doubled on Kelvin scale and molar mass will become 1. As atoms are molecules has been dissociated, so molar mass will become 1. Then divided by most probable, so 2RT divided by molar mass is 2. So this R and R is going to cancel. This 2 and 2, this T and T, everything is going to cancel. So under root 6 V0 will be there. The RMS velocity in the final condition will be under root 6 V0. Will be under root 6 V0. Could you understand the process? If you take some time in solving the question, that is all correct. You just have to mention all the conditions very clearly. Sometime in haste, you can took both velocity as same. You can have some error in putting the values and that will result in error. That will result in error. Let's see next of the question. Are you asking my name, Afrida? Okay. The temperature at which oxygen molecules have the same RMS speed as helium atom at 300 Kelvin. Again a question on RMS. Oxygen and helium should have same RMS velocity. Let's say oxygen 3R T by molar mass 32. Helium 3R, temperature is 300 and molar mass of helium is 4. Molar mass of helium is 4 and yes. So temperature by 8 is equal to 300. So temperature will be 2400 Kelvin. 2400 Kelvin will be the temperature at which oxygen will have same RMS speed as helium at 300 Kelvin. At 300 Kelvin. As they are talking about oxygen molecule, that's why I've taken molar mass as 32. Always remember when you have to take the molar mass of oxygen as 16 and as 32. Most of the NEET aspirant I have seen do this type of error. Yes. Okay. Moving to the next question. The initial volume of a gas cylinder is 750 ml. If the pressure of the gas cylinder is changed from 840 to 360, then calculate the final volume. A very simple question based on PV is equal to nRT. P1 V1 by P2 V2. Because mole and temperature are not going to change. Pressure of the gas is initially 840. Then the volume is 750. Final pressure we are given with 360. Final volume we have to find. So the final volume will be 84 divided by 36 multiplied by 750. So that will be 326. (28 into 250 by 3). We can find this answer by approximation or you can solve for the final result. We can do a little bit approximation. If this is assumed to be 30, that will be 250 into 10 by 250 into 30 by 3, 20. Yes. So the answer will be close to 240 ml. Answer will be close to 240 ml. No, 2400 ml. That will be the closest answer. If this is assumed to be 30, that will be around 2500. That will be around 2500. Next question says a neon dioxygen mixture contains this much gram oxygen, this much gram neon. If the pressure of the gases in cylinder is 25 bar, what is the partial pressure of oxygen in bar? Again, you can solve this question by simply using Dalton's law of partial pressure. Simply using Dalton's law of partial pressure. Okay. Partial pressure of oxygen will be, we again take oxygen as the oxygen gas. So mole of oxygen divided by mole of neon plus mole of oxygen multiplied by total pressure, which is 25 bar. Multiply by total pressure, which is 25 bar, and then you can solve for the partial pressure of oxygen. Solve for the partial pressure of oxygen. Okay. The next question is, by how many fold the temperature of a gas would increase when the RMS velocity of the gas molecule in a container of fixed is increased from, see here, velocity has been increased from this to this, that is velocity has been doubled. I can solve this question directly by just assuming that velocity is proportional to under root of temperature. So if velocity has become doubled, that means temperature should become 4 times. You can solve this by taking the ratio as we were doing earlier, V1 by V2 is equal to T1 by T2. You can solve this by that method as well. V1 by V2 is equal to under root T1 by T2. Because all type of velocities are inverse, directly proportional to under root of temperature. Okay? Yes. Let's move to the next question. 4 times will be the change here. For 1 mole of a van der Waals gas, when B is equal to 0 and T is equal to 300 Kelvin, the PV versus 1 by V plot is shown the value of the van der Waals constant A. From this graph, we have to calculate value of van der Waals constant A. Yes, able learning. Yes. Okay. See Abhinav and every student out there, everyone has doing some struggle, right? And sometimes situations are not according to us. If we are not able to perform, we are not able to excel in that situation, it is not good to blame the situation. It is more better to be prepared for the upcoming things. Don't go and think what happened in the past, that I couldn't study because of some reason, or I couldn't do good in the previous attempt of my exam. You are going to have the attempt in your near future, and for that attempt you are given as many days as you are given. Either you are given 2 days, 1 year, 2 years, doesn't matter. The time that you are given, you should give your 100% in that time. After that, a satisfaction should be there and nothing else. So sometimes it can happen that situations are not under our control. But how to react in those situations is our choice. Situations are our destiny. They are not under our control. But how to react in those situations is our choice. And you should choose wisely. Okay? So don't think about the past and get depressed by that. Think about the good future that you are going to have. So we are having B is equal to 0. So P plus, for 1 mole P plus A by V square, V will be equal to RT. So from here we will get PV is equal to minus A 1 by V plus RT. This is the modified van der Waals equation, right? This is the modified van der Waals equation. Yes, Ram Nehar, there will be a batch for JEE Advanced. And already there is a batch going in which JEE Advanced PYQs are discussed. You can check it on the PW app. So PV versus 1 by V. If we draw a graph versus PV versus 1 by V, then this intercept should be RT. And the slope will be minus A. Slope will be minus A. As you can see, the slope is negative. So if we take only the magnitude of the slope, that will give you A. So this difference is 1.5. Perpendicular divided by base. This difference is 1. So the value of van der Waals constant is 1.5 in the respective units. 1.5 in the respective unit that they are given in the graph. Yes. Okay. Let's move to the next question. Okay, the next chapter is Thermodynamics and Thermochemistry. Now this chapter is the only chapter where you have to think whether this has been asked in chemistry or this has been asked in physics. Because similar type of problems are there which can be asked in both subjects, and especially if work done question are asked, then both physics and chemistry have different sign convention. So a positive answer in chemistry can have a negative answer in physics section. Yes, Bharani, yes. Okay, so we are going to start this chapter. In this chapter, many of you might be confused in work done. So first of all, I am going to focus on work done. For work done, you have a formula for reversible isothermal, that is temperature constant, minus 2.303 RT log final volume by final initial volume. Second is work done for irreversible isothermal, work done for isobaric both, minus external pressure delta V. And third is isochoric. For that the work done is 0. For isochoric, that is volume constant, work done is 0. And for adiabatic, work done is equal to internal energy change, that is nothing but NCV delta T all the time, heat at constant volume, or NR by gamma minus 1 delta T. That is the formula of work done. Now, if you're confused from question that how you will find which is the type of process, first of all, a slow process is reversible. A slow process is reversible. And read the question. If the question is having open container, pressure is going to be constant. If the question says against a pressure in isothermal, again pressure is going to be constant. This type of thing is written against the pressure of this, against the pressure of that. Even if pressure is not mentioned as constant, it is going to be irreversible isothermal. And if the question says insulation, fast thermal insulation, then you can say that heat is zero and that going to be adiabatic process. That is going to be adiabatic process. So this is about work done, and there is no other formula for work done for your purpose. For JEE student, you can use the general standard form as well, PdV minus integral of PdV. If they are not your standard process, you can find work done by minus PdV. Second thing is, whenever you have anything coming inside the system, that will be positive. Going outside the system, which is lost, that will be negative. Whether work done on the system, heat given to the system, work done by the system, heat taken from the system. First two will be positive, another two will be negative. Third thing is, heat at constant pressure is always delta H, and heat at constant volume is always delta U, internal energy. Fourth thing, you can use the general expression delta H is equal to delta U plus delta PV, or for any chemical reaction, delta H and delta U are always, whenever the question is asking relation between delta H and delta U, you are going to use this formula. Delta H is equal to delta U plus delta NGRT. Okay. Fifth thing is that whenever you want to find entropy change, if it is at equilibrium, that is phase transition or any other such processes, that is given by delta H by T. Delta H by T. These are some formulas that students find confusing, so I am writing it once again. Most important is work done. Only 4 formulas are there for work done that you have to use. Okay. So first question of thermodynamics is, in a closed insulated container. So container is insulated, that means there is going to be no heat flow. There is no heat flow. I should ask you, if it is insulated, can I be assured that temperature is not going to change? Come on, tell me the answer in chat box right now. If the container is insulated, is it certain that temperature is not going to change? If the temperature is constant, if the container is insulated, is it certain that temperature is not going to change or not? Delta S universe is negative for non-spontaneous process. Delta S universe is going to be non-spontaneous for negative. Not the delta S system. Not the delta S system. Tell me the answer in chat box. Yes, very good. Very good. Heat and temperature are not that much. Reversible work done for isothermal is given by this formula. Here we use P instead of P, nRT by V, and get this result. So whenever a process is happening at constant temperature very slowly, slow means it is going to be an equilibrium reversible process. So to identify the reversible process, you should look for slowness of the process. If the process is happening at least at a very slow pace, it is going to be reversible process. Yes, if the container is insulated, temperature still can change by the work done. And here this is happening. A liquid is stirred with a paddle to increase the temperature. Liquid is stirred with a paddle to increase the temperature. An insulated container can have the change in temperature by work done, not by heat, but by work done. So here we can use the first law of thermodynamics, delta E is equal to Q plus W. This is the chemistry version. Physics is Q is equal to delta E plus W. This is the chemistry version that we are going to use all the time. In physics, you can see that Q is equal to delta E plus W is the form here. So delta E and W are going to be equal and non-zero. Q is going to be 0. Option A is the correct answer. Option A is our correct answer. Very good, sir. Yes, moving to the next question. The entropy change in the fusion of 1 mole of solid melting. See, whenever you have a phase transition at its conversion point, like melting point, boiling point, every time phase transition at conversion point is at equilibrium, and that means at equilibrium delta G is going to be 0, and then you can use delta S is equal to delta H by T. So whenever the question asks you to find the delta S for phase conversion, you can always use this relation. For phase conversion, you can always use this one relation. So see here, we are given with the fusion of 1 mole of solid melting at 27, we are given with latent heat in per mole. So delta S will be equal to 2930 divided by 27, that is 300. So if I as approximate to 3000 divided by issue. Okay, there was some network issue. Yes. I think it is okay now. Just give it a go that network issue is resolved. There was some network issue before. Okay. Is network issue resolved for everyone? Yes. The correct answer will be 9.77, as 3000 is slightly more than 2930. So the actual answer will be slightly less than 10. So 9.77 will be the actual answer. Okay. Moving to the next question. The enthalpy of vaporization of water from the following data. See, we are given with this process liquid and gas. The vaporization means liquid to gas conversion. Liquid to gas conversion. See, whenever you are solving reaction, just look for the position. H2O liquid is on the left side. So obviously this reaction should be reversed to bring this liquid on the left side. So this sign will be changed. That means minus will become positive now. Now H2O gas is on the right side. So this reaction will not be changed anyhow. So this sign will remain as such. So this will, you can multiply and solve that, or we can directly say that this will be close to this value. Option B will be our answer. Option B will be our answer. Yes, Priya, there will be a course. Okay. Okay. Moving to the next question now. The standard enthalpy of formation of ammonia is given if the enthalpy of formation of H from its atom is minus 433 and that of nitrogen is minus 712, it should be H2 and N2. The average bond enthalpy of NH bond in NH3 is. See, first of all, let's talk about the formation. Whenever we are writing formation reaction, it should always be from elements in their reference state. From elements in their reference state. So the reaction will be N2 plus H2 gives NH3. And now I'm going to tell you a very good trick. Whenever you are writing any equation, the one thing that is under focus will be taken as 1 mole. If I say formation of what? Formation of product. All the time whenever we're talking about formation, we are going to talk about product. So whenever you are writing formation reaction, balance it by taking 1 in front of product. There should be all the time 1. It is compulsory to have 1 here. So that will be 1 ammonia, 1/2 nitrogen and 3/2 hydrogen. Now H2 from its atom will be formed by bond enthalpy. So this is nothing but negative of bond enthalpy. Nitrogen from atom will be formed through bond enthalpy. So this is nothing but bond enthalpy. Whenever you are talking about bond enthalpy, on the reactant side, you will break bond, break all the bonds, and on the product side, you will form bond. So breaking of bonds require energy, so that will be taken as positive all the time. Formation evolves energy, so that will be taken negative all the time. Okay? Yes. So see here, N2 bond enthalpy is 702, delta H is minus 46. That will be minus 712 will become positive 712 divided by 2. Why 2? Because this is half mole. Plus 436, that will become 3 by 2. Because again this is 3 by 2 mole. Minus, we have 3 NH bond here, for which we have to calculate bond enthalpy. We have to calculate bond enthalpy. So 3 NH will become equal to 712. Let's divide it. 2, 3, 6, 2, 5, 10, 356. Divide it as well. 3 into 2, 1, 8. And multiply it also. 654. Minus will become plus 46. Now see here. Whenever you are solving question of any thermochemistry, you can see that options are very far away, right? So you can all the time approximate. You can all the time approximate to nearest 10. 356 will become 360. 654 will become 650. 46 will become 50, approximately. 650 plus 50, 700 plus 3, 1060. So NH bond will be 1060 divided by 3. 300 order should be there, so 352 will be the correct answer. This approximation is going to help you in calculation. What you have to do, you have to all the time approximate towards the nearest 10 of all the values. Towards the nearest 10 to all the values. And that will give you easier answer in thermochemistry. That will solve your calculation, because every time they are giving you calculation involving experimental data. Experimental data. Let's see the next question. Calculate enthalpy change for the reaction 8S to S8. We are given these reactions. Now you can see here. Okay. This question is having many mistyped information, so we are going to skip it because there is no S8, there is not. Okay, we will skip this question because this is having mistyped information. See this question. On the basis of the following thermochemical data, we have to find delta H formation for OH minus. For OH minus. Delta H formation for OH minus. Okay. Focus on this reaction, students. For any reaction, you can write delta H of reaction is equal to delta H formation of product minus delta H formation of reactant. So using this relation, delta H is given as 57.32 is equal to delta H formation of product, that will be delta H formation of H plus, that is 0. Delta H formation of OH minus, that we have to find, minus delta H formation of H2O liquid, that is given here. So minus 2286. So that will become delta H formation of OH minus 2286 plus 57.32. So that will be around 2100. That will be around 2100. 2100 will be the correct answer. Moving to the next question. Okay. Moving to the next question. Consider the following spontaneous reaction. 2C8H18 plus 25O2 gives 16CO2 plus 18H2. the sign of delta H, delta S, delta G would be respectively. First of all, this is a hydrocarbons. Hydrocarbons are fuel, so mostly when you burn a fuel, you get energy. When you burn a fuel, you get energy. That means delta H is going to be negative. Delta H is going to be negative. For entropy change, we will look for the moles of gas. Here we have 25 plus 2, 27 gas mole. Here we have 16 plus 18, 34 gas mole. So as you can see that during the reaction, the number of gas mole is increasing. So definitely delta S is going to be positive. As the number of gas particles are increasing and gases are more random, so number of gas molecule will increase, result in increase in entropy. So negative, positive. Now delta G is equal to delta H minus T delta S. As this is negative, this is positive. So we are getting a whole result, negative minus negative. That will give you all the time negative value. So negative, positive, negative, option B will be the correct answer. Negative, positive, negative. And only one option is having negative, positive. So if you have found sign of delta H and delta S, you can write the answer. Every time for sign of delta S, you are going to look for gaseous molecule. You are going to look for gaseous molecule. Let's see the next question. Now this question is similar to the previous one. You have to find the bond energy of OH bond. Can you find the bond energy of OH bond from here? Can you find the bond energy of OH bond? Let's see if you can find it. You have to do the same thing that we did in the previous case. See, for this delta H we can write half H2H2, so HH bond energy is 435.89 divided by 2. Half O2, so for O bond enthalpy is 495. 495 divided by 2 minus a single OH bond is there, so OH bond enthalpy. Now what I am going to do, approximate 440 by 2, 220. 500 by 2, 250. Minus 42 will become plus 42 will be 40 approximate. So 224, 470 minus 40, that will be 430. The answer should be close to 430. Option B is the correct answer. The answer should be close to 430. Okay, let's move on to the next question. The heat of combustion of carbon to CO2 is minus 393.5 kilojoule per mole. Able learner, a student should focus on its own. Yes, that's the correct answer, Desi Gamers. Okay, so the question is the heat of combustion of carbon to CO2 is minus 393.5 kilojoule per mole. The heat released upon formation of 35.2 gram of CO2 from carbon and oxygen gas. First of all, I know the answer should be 350. How do I know the answer? I haven't seen this question before, but I still know the answer, that the answer should be 350. Now see how you can find it. Carbon is combusted to give you CO2. Whenever we are talking about combustion, combustion happens of the reactant. So reactant is under focus. Reactant is under focus. So we are going to take 1 mole of reactant for which we are doing combustion. Now this reaction involves 1 mole of carbon, 1 mole of oxygen and 1 mole of CO2. That means 44 gram CO2 production will have burning of carbon, so that minus 393.5 kilojoule energy will be produced. Right? This much amount of energy will be produced. Right? Now we are asked for 35.2 gram. So we can directly apply the unitary method. And obviously, as this is less than 1, you can see here, this is less than 1, so the answer should be less than 393. Answer should be less than 393. On solving this, we will get answer less than 393. This cannot be the answer. This is too much less. This cannot be the answer. Only these two are left as energy is evolved, so minus sign, that's why A answer. That's how I could find the answer just by looking at the question without solving, that I knew from this line 44 gram is producing this much energy, so less than 44 will produce little bit less than energy. Little bit less than energy. See, this is the importance of this marathon session. Sometime you get to know some of the tricks or some of the quicker way to solve some problem. Okay. Let's see the next question. Using the data provided, calculate the multiple bond energy of carbon double bond carbon in C2H2. See, in thermochemistry, many students do this, that they start solving completely. Thermochemistry is a major chapter where approximation is so much required. See, this is given as, okay. So this is carbon solid to carbon gas, we are already given 1410. Hydrogen to hydrogen gas, we are already given 330. Minus carbon hydrogen bond enthalpy is given as 350. Two carbon hydrogen bond are present, so 2 into 350 minus carbon double bond carbon, and that should be equal to enthalpy of the reaction, that is 225. What I did here, delta H of the reaction can be written as bond enthalpy of the reactant side in positive. So I converted all of the reactant side to gaseous atom using the energy, and all of the product side bond will be formed, so negative sign. Bond on the product side with negative sign, bond on the reactant side with positive sign. Now approximation time, 225, 230, 1410, 330, minus 700, minus C double bond C. So C double bond C will be 14 plus 3, 17, 1740 minus 7040 minus 230. So the answer will be close to 810. Close to 810, which is the answer? 815. Because we haven't approximated much, so answer should be closest to 810. What is the enthalpy of the reaction in hydrogen? In which question you are talking about? Okay, moving to the next question. For a given reaction, delta H is 35.5 kilojoule per mole, delta S is 83.6 joule per Kelvin per mole. The reaction is spontaneous. Now this question is about spontaneity. So if we talk about spontaneity, delta G should be less than 0, right? Delta G should be less than 0 for spontaneous. Yes. Okay. So delta G is delta H minus T delta S should be less than 0. That will give you T should be greater than delta H by delta S. Now delta H is given as 35.5 kilojoules. So we will convert it into joule. Remember, every time you are given delta H and delta S, focus on their unit, because delta H is mostly given in kilojoule and delta S is mostly given in joule. So that will give you 35,500 divided by delta S, that is 83.6. Let's approximate again 36,000 divided by 90. So the temperature should be greater than 400. Temperature should be greater than 400. Closest answer is option A. Closest answer is option A. Right? Yes. Okay. Moving to the next question. if an endothermic reaction is non-spontaneous at freezing point of water and become feasible at its boiling point, then now try to solve this question, then I will tell you a quick way to solve this type of question of delta G and sign convention. Of delta G and sign convention. Solve this question as you are supposed to solve, as the only any method that you know. There are 2-3 methods to solve this question. Then I will tell you a one-liner method for solving such question. See, delta G is equal to delta H minus T delta S. Whenever the question is about the sign of delta H, delta S and delta G, either you can remember all the 4 cases, that is very good. Plus, spontaneous, non-spontaneous, low temperature, high temperature. You can remember all these points, that is good. Another method is if you talk about the graph, delta G versus temperature graph. First of all, the graph will have intercept at delta H. That means this will be the intercept of the graph. And slope of the graph will be minus delta S. Now look here. First of all, the reaction is already saying that the question is saying that reaction is endothermic. So delta H is going to be positive. So delta G is positive right now. This is the delta H on some positive. Now either from this point the graph can go up or the graph can go down. If the graph will go up, it will never become spontaneous. Delta G will always be positive. It will never become spontaneous. That means if the question has said that the process is always non-spontaneous, you would have made a graph upward direction. But the question is saying the process is becoming spontaneous at higher temperature. Boiling point will be higher than freezing point, right? So if the process is becoming spontaneous at higher temperature, that means the graph will be going in the negative region at the higher temperature. So for that, starting from this point, it should come down. It should come down. That after boiling point, it is becoming negative and spontaneous. So this line from the point of view of graph tells us that the slope is negative. Now if slope is negative, delta S should be positive. If slope is negative, delta S is positive. If slope is negative, delta S is positive. So we got the answer that both delta H and delta S are positive. Without any confusion, we can directly find all the sign conditions for delta H and delta S using this graph. Okay? Moving to the next question now. Option B will be the answer here. The question already says endothermic. So if endothermic, then delta H should be positive. Delta H cannot be negative. Delta H cannot be negative. Okay, the next question says the standard enthalpy of formation of CO2, H2O and glucose at minus 400, minus 300, minus 1300 kilojoule per mole. The standard enthalpy of combustion per gram of glucose. Let's solve this. First of all, glucose, C6H12O6. The combustion of glucose will give you CO2 and H2O. Now for combustion, we are going to take 1 mole of glucose. Then we will have 6 mole of CO2, 6 mole of H2O, and because of 12 plus 6, 18 minus 6, 12, 6 mole of oxygen. So delta H of the reaction will be, in terms of formation, 6 times of delta H formation of CO2. Now delta H formation of CO2 is minus 400. Plus 6 times of formation of water. Formation of water is minus 300. Minus 1 time of formation of glucose. So formation of glucose is minus 1300. Minus formation of oxygen. So formation of any element in their stable state is 0. So formation enthalpy of oxygen will be 0. Formation enthalpy of oxygen will be 0. Okay, let's see here. Now this will be minus 2400 minus 1800 plus 1300. So that will be minus 2900. But if you mark minus 2900 as the correct answer, you are going to get wrong. Why? Because this is per mole. This minus 2900 is per mole. We have to find per gram. That means for 180 gram, for 1 mole 180 gram, we have minus 2900. So for 1 gram, we will have minus 2900 divided by 180. And obviously that is only one option is remaining in minus. That will be our correct answer. That will be our correct answer. Okay. Option C is the correct answer. Moving to the next question now. Let's see the next question. If at 298 Kelvin, the bond energy of CH, CC, C double bond C, H single bond H are this, the value of enthalpy change for the reaction. Another question based on bond enthalpy, and every time bond enthalpy is having only one pattern, break all bonds on reactant side and form all bonds on product side. So delta H will be, let's see, CH, 4 CH bond, 4 CH bond, 414. C double bond C, 1 C double bond C, C double bond C is this, so this 615. All the enthalpies on the product's reactant side positive. H2, H single bond H, S single bond H is 435. Minus, product side on minus, 6 CH bond, 6414. 1 CC single bond. CC single bond is second number, so 347. So this will be 615 plus 435 minus 2 into 414. Now can you solve this by taking the approximation yourself? I know you can directly add or minus it, but it will take time. Can you solve this by taking approximation? Let's see if we can find it. 620 plus 430. We are approximating to closest 10. 410 multiplied by 2, that will be 820 minus 350. Okay, we will approximate it to nearest 10. Now 620 minus 820, that will be minus 200, minus 550, or minus 200 plus 430 will be 230. 350 minus 230, that will be near about 80, right? So solve it and find the answer. Solve it and find the answer. Can you find it by approximation? Let's see if you can find the answer here. The answer should come around minus 1100. Yes, minus 100 something. Minus 100 something should be the correct answer. Okay. Moving to the next question now. Standard entropy of X2, Y2 and XY3 are 60, 40 and 50 respectively. For this reaction, delta H is given. We want to find the temperature at which it will be equilibrium. Now, what is the condition for equilibrium? What is the condition for equilibrium? Delta G should be 0. Delta G should be 0. Now see, delta S, entropy is also a state function, so we can use the same relation, product minus reactants. X, Y3 50 minus half of X2, half of 60 minus 3 by 2 of Y2, 3 by 2 of Y2, 3 by 2 of 40. So that will be 50 minus 30 minus 60. Minus 40 is the entropy change. Minus 40 is the entropy change. Now, for at equilibrium, delta G should be 0. So T will be delta H by delta S. What is delta H? 30 kilojoule. So minus 30,000 joule divided by minus 40. This will be cancelled out. 4728, 750 Kelvin. So at 750 Kelvin, the reaction will be at equilibrium. At 750 Kelvin, the reaction will be at equilibrium. right? Okay. Moving to the next question now. Bond enthalpies of H2, X2 and HX are in the ratio of 2, 1, 2. If enthalpy of formation of HX is minus 50, the bond enthalpy of X2 is. See, formation of HX. So HX will be formed all the time whenever you are writing formation reaction. Write it from the product side. That will be H2 plus X2. For 1 mole of product, half H2, half X2. Right? For 1 mole of product, half H2, half X2. So delta H for this reaction will be, which is given as minus 50, is equal to half of H2 bond enthalpy. We can assume that to be 2A, A and 2A. Because ratio is 2, ratio 1, ratio 2. So 2A divided by 2, half of X2, that is A divided by 2, minus HX will be 2A. So that will give you minus 50 is equal to 2A plus A, 3A minus 4A, that will be minus A by 2. So A will be 100. A will be 100. That means this is 200, this is 100, this is 200. The question is asking you the bond enthalpy of X2. Bond enthalpy of X2 is 100 kilojoule per mole. Option A is the correct answer. So the bond enthalpies question are very easy. Are you guys able to understand this question? Okay. Dream Center, this is not the time for this. Just think of your parents who are giving you everything for preparation. Okay, moving on to the next chapter. It may be the case some of you find some chapter to be boring, as Itachi Uchiha is saying, but all the chapter carries almost equal weightage. Okay, the S naught of the following substances are given. We are given with the entropy, and we have to find the entropy change for this reaction. Similar to enthalpy, entropy is also a state function. Similar to enthalpy, entropy is also a state function, and for every state function you can write final minus initial. So delta S is going to be product side CO2. CO2 is 213.6. I am approximating 210 plus twice of H2O. H2O is 70, so twice will be 140, minus methane. Methane is 186, so approximately 190, minus twice of O2, so 205 is 200, so minus 400. So that will be 210 minus 90, that will be 20, 160, 160 minus 400, so that will be 300 minus 60 minus 240. The answer will be close to minus 240. See how quickly we could find the answer. How quickly we could find the answer. Yes. Okay. Now moving to the next question. In your dreams, Dream Center, in your dreams, the thing that you are wanting is not obtained like this in this method. Given that bond energy of HHCl are given and enthalpy of formation of HCl is given, we have to find the bond enthalpy of HCl bond. We have to find the bond enthalpy of HCl bond. Yes, Raja, it is very easy to calculate. Thermochemistry is very easy to calculate, and thermodynamics, thermochemistry chapter have more weightage of thermochemistry. More weightage of thermochemistry. Okay, so we are talking about formation of HCl. 1 mole of product will be formed from its respective reactant. From its respective reactant. Now, delta H formation of HCl is given minus 90. That is equal to half of HH bond enthalpy, half of 430. half of Cl bond enthalpy, half of 240 minus HCl bond enthalpy that we need to find. Reactant side positive, product side negative. Yes. So HCl will be 440, assume it to be 440 divided by 2, 220 plus 120 plus 90. So 220 plus 120, 340, 340 plus 90, that will be closest to 430. Any answer which is closest to 430 is option B. You will see that as this chapter proceeds, the level of approximation is going to increase. Yes, some of the questions that I have taken today are PYQs, because PYQs is the true reflection of your exam. If you are able to solve PYQs, you need not to go above or below that level. Only PYQs is sufficient, because that is the truest reflection of any exam. Okay, moving to the next question. Temperature of 5 mole of a gas is decreased by 2 Kelvin at constant pressure. Indicate the correct statement. Now this is thermodynamics. See, temperature is decreased at constant pressure. Temperature is decreased at constant pressure. So work done will be minus P delta V. And using PV is equal to nRT, you can write work done as minus nR delta T, because here instead of volume, they are talking in terms of temperature. Instead of volume, they are talking in terms of temperature. So mole is given as 5. Temperature change is given as 2. So the work done will be minus 10R. Work done will be minus 10R. This is not correct. This is not correct. Minus mean work is coming outside the system. So work done is by the gas. Work done is by the gas. So work done by the gas is 10R. Work done by the gas is 10R. Very good. CR7C. Correct answer. Yes. Chirag Malhan, which question you want to repeat? This one or previous one? This one, nothing. We have done so many questions in today's session about bond enthalpies. So only we are talking about the formation reaction of HCl. So I write the formation reaction. And in terms of bond, we always take reactant side as positive and product side as negative. Yes. Option C is the correct answer, not option B. Raja, PK Raja. Option C is the correct answer. This reminds me of a song, Your Name. Okay. For complete combustion of ethanol, the amount of heat produced as measured in bomb calorimeter is this. Assuming ideality, the enthalpy of combustion for the reaction will be C. First of all, whenever we are doing a reaction in bomb calorimeter, when I am doing a reaction in bomb calorimeter, that is always giving you heat at constant volume. Bomb is a device which has constant volume. So whatever energy change is given is always heat at constant volume. That represent delta U. That represent delta U. This is your first thing. So delta U is given as heat produced. So it will be negative because heat is evolved. 1364.4. Now another trick for you. Another trick for you is that whenever you are finding relation between delta H and delta U, answer is not going to be vary so much. Only 2 to 5 kilojoules will be different. That means this is definitely not going to be the answer. And I can say this is also not going to be the answer. So whatever you are having delta U and delta H, they are not having much difference in terms of kilojoule. Okay. So this is a good trick. You can find option quickly. Another thing, we know only one relation is there for such type of question. Let's find delta NGRT. All I am telling you how to calculate questions quickly. Because these questions are very simple. You know how to apply the formula. I am just telling you how to solve the question. Delta U is minus 1364.4. correct? Delta Ng, 2 moles here, 3 moles here, product minus reactant. So 2 minus 3, that will give you minus 1. 2 minus 3, that will give you minus 1. So minus 1, R is 8.31 in joule. Temperature is 25, that is 298. We will divide it by 1000 to convert it into kilojoule. So minus 1364.4 plus approximate to 300. 300 into 8, 2400 divided by 1000. So that will be minus 2.4. See, that's why I was telling the answer will not deviate much from the actual value. Now you only need to see this. When you got this minus sign, you need not to solve further. Minus sign means this answer will be more than magnitude of 1364. Due to this minus sign, this cannot be the answer, so only this is the remaining answer. Could you understand that? First of all, we know that delta H and delta U value are not going to deviate more. Second thing, if delta Ng is negative, those values are going to be added, so answer will be having magnitude more than 1364. If that came to be positive, I could have find this answer. So we could solve these questions without even solving. Moving to the next question. Assuming that water vapor is an ideal gas, calculate the internal energy change when 1 mole of water is vaporized at 1 bar pressure and 100 degrees Celsius. So 1 mole of water, liquid water, is vaporized at 373 Kelvin, and we are already given with the enthalpy of vaporization. So again a question of enthalpy and internal energy relation. We just have to find delta Ng. Now delta U will be delta H. Delta H is 41 kilojoule per mole minus delta Ng, this is gas. This is gas. So delta Ng is 1. R is 8.31 in joule. Temperature is 373 divided by 1000. You can solve this or assume that to be 400, this to be approximately 8. So 408, 3200, that means 41 minus 3.2. So the answer will be 37.8 kilojoule. That is the approximate value of internal energy change. Okay, there is no confirmed story about the NEET postponement, so don't focus on that. See, if you are doing preparation very well, it doesn't matter when the exam is going to happen. If you are not preparing, you will every time pray that the exam is get postponed. When you will reach in the college, you will all the time think that something happens, some fight occurs, some mishappening occurs, so that your end semester exams are postponed. And even if they are postponed, you are given, suppose you are given 20-25 days extra. Those who are not preparing will not start preparing in those 20-25 days extra. That will just only delay the session. Nothing else is going to happen. So if you are given even more time for your preparation, that doesn't change much. The one who is preparing is already prepared. The one who is not preparing will not be starting preparation right now. So let's move to the next question now. When 5 liters of a gas mixture of methane and propane is perfectly combusted at 0 and 1 atmospheric pressure, 16 liters of oxygen at the same temperature and pressure is consumed. Calculate the amount of heat released from this combustion. Now this question is fusion of mole concept as well as thermodynamics. Mole concept as well as thermodynamics. Let's see here. Mixture of methane and propane. So CH4 and C3H8 plus oxygen, that will give you CO2 and H2O, and that will give you CO2 and H2. Now balance it. So 2H2O, 2O2, 3CO2, 4H2O, 5O2. This is having a total volume of 5 liters. So if x liter of methane are there, 5 minus x liter of propane will be there, right? If x liter of methane are there, 5 minus x liter of propane will be there. X liter of methane will require 2x liter of oxygen, and this will require 5 minus 5 times of 5 minus x liter of oxygen. So the total volume of oxygen required is 2x plus 25 minus 5x, and that is given as 16 liters. So first of all, we are finding the composition. We are finding the composition of mixture, then we will think about the enthalpy. So now we are having 25 minus 16, that is 9, is equal to 3x. So x is equal to 3 liter. X is equal to 3 liter. Now the second part, the amount of heat produced per mole. That means mole of methane we have to find. That will be PV by RT. So P is, pressure is 1, volume is 3 divided by RT. Similarly, mole of propane will be PV, volume of propane is 2 divided by RT. What we did here, we converted the volume into mole. So the total heat produced will be this much mole of propane, of methane will produce mole multiplied by methane, that is 890, plus this much mole of propane will produce 2 by RT, mole multiplied by enthalpy for propane 1 mole, 2220. So that will become 0, 9, 3, 27, 8, 3, 24, 26. 2670 plus 4440 by RT. So that will be 0, 7, 4, 13, 6, 4, 10 plus 1, 11, 4, 2, 6 plus 1, 7130 by 8.31. And temperature is how much? Temperature is 273. Again, we will take this as 300, this as 8. So that will become 7130 divided by 2400 approximately. You can take this to be 7200 divided by 2400. So the amount of heat will be approximately 3 kilojoule. You can solve it for complete, accurate, exact answer, but the correct answer should come around 3 kilojoule. Correct answer should come around 3 kilojoule. Yes. Is that clear to you? Chirag Milan 317, which is 317. Okay, I think that is something else. Moving to this next question. This one. What the question is saying? From the following bond energy, we have to again calculate the enthalpy of this reaction. I think bond energy calculation is now very much clear to you all. You can find the answer. So this question you have to do yourself. Some is saying NEET will happen at 17 December. At least it is not happening at 29 February. Sometime it will happen that NEET is happening on 29 February. Students are not giving the NEET exam. They are directly getting the degree of MBBS. This is the new rule. That now, from now onwards, degree of MBBS will be directly given to anyone who wants it. Okay? And then those doctors will be treating us, instead of fever, they will be treating us for cold. Instead of cold, they will be treating us for something else. Do this question very quickly. Those who are studying, do this question very quickly. I read some another news that government is picking some notorious student from their house. Okay. Could you solve this? Let's see. You are taking too much time. From this side. 1, 2, 3, 4. 4 times of CH bond. 4 times of CH bond, 410. I think we have already solved this question in the previous case as well. Positive. 1 time double bond, 606. 1 time HH bond, 431. Minus 6 times of CH bond, 410. Minus 1 time of C single bond C, 336. Just approximate and solve this. We have already previously solved it. We have already previously solved it. The values were slightly different, but the question was similar. Okay, moving to the next question now. Now, this is a very good question. Why? Because this involves the resonance energy. What is resonance energy? Resonance energy means the hybrid form and canonical form. The difference in energy between hybrid and canonical form is called as resonance energy. Whenever we are calculating something, we always draw canonical resonating structure. See here, if they are talking about the formation of N2O, N2 plus O2 will give you N double bond N double bond O. Let's see, this is the resonating structure of N2O that I am choosing. You can choose any resonating structure. Okay, so in order to balance the equation N2O, there will be half O2. Now, we are going to calculate the enthalpy of formation of N2O. See, in case of resonance energy question, you will be given lots of values. You can assume any one of the value to be unknown. I am assuming this value is not given to me. I am assuming this value is not given to me. You can assume this to be unknown, any value to be unknown. Then what will happen? Delta H formation we will calculate using thermodynamics. N triple bond N 946 plus half O2, O double bond O 607 minus N double bond N 418 minus N double bond O is 607. Okay, O double bond O is 498. N double bond O is 607. Now approximation time 940, 950, 500 by 2, 250, 418, 420, 610. 950 plus 250, that will become 1200. 1200 minus 408, that will become 800 minus 20, 780 minus 600, that will become 180 minus 10, 170. 170. That is the delta H formation that is coming first. Now, this is the value that we have calculated. This is the value that we have calculated. This is the value that is given in our question. Any value which is given in question is experimental. Experimental values are always representing hybrid form. Experimental values are always representing hybrid form. And the value that we have calculated is one of the theoretical structure. So what you have to do, for any time you want to find the resonance energy, just have the difference in theoretical value minus experimental value. Sign you can avoid. So just have the difference between theoretical and experimental value. The value that you are assuming to be not given, you are calculating it. Calculated minus experimental. Calculated minus experimental. So calculated value is 170. Experimental is 82. So that will be 80, 80, 160. So 170 minus 80 will be, I think, 90. 88. Approximately 88 kilojoule is the resonance energy. So that's how we can find the resonance energy, right? Okay. Hello, Harsh. Moving to the next question now. Under isothermal condition, see, isothermal condition for 1 mole of ideal gas, what is the ratio of work done under reversible to irreversible process initially held at 20 atm undergoes from 1 liter to 2 liter at 298 Kelvin under external pressure of 10 atm. First of all, we are going to find the irreversible work. Now, irreversible work is minus P external delta V, right? Irreversible work is minus P external delta V. So the minus P external pressure is 10 atm. Remember, in work done, you are always going to use external pressure. So minus 10 multiplied by change in volume. Volume change is 1 liter. So the work done is minus 10 atm liter. Minus 10 atm liter. Okay, right. Then reversible work done. Minus 2.303 nRT. Moles of gas is 1. R will be put as 0.0821 in atm liter we are going to use. Temperature is given as 298 log final volume by initial volume. Final volume is 2, initial volume is 1. So the ratio of, we have to find the ratio of reversible to irreversible, reversible to irreversible. That will come, minus will be cancelled out, 2.3, 0.08 into 300 will be 24, right? 0.08 into 300 will be 24, into 0.3 divided by 10, that will be 6.9 into 24 by 10. So that will be approximated to 7, 7 4 28, 7 to 14 plus 2 16. So the ratio will be approximately 16.8. The answer should be close to 16.8 approximately. Okay? The ratio will be approximately 16.8. 0.08 to 1 is taken as 0.08. Temperature has approximated to 300. Okay, moving to the next question now. Okay, now this is the another chapter that we are going to start after a short break. This time break will be shorter. After a short break, we are going to resume it. Okay, till then have some refueling, eat some snacks, have some food. Don't eat too much, otherwise you will feel sleepy. So eat something and come back again. We will meet after 10 minutes. Hello, 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 hello. So have you refueled? Hello, hello, hello. By the way, I'm seeing the dedication of this Praveen V. It is harder for students to attain the complete session, but he is still from the beginning and doing one thing only. Hello. Yeah, in the previous question, I took that 0.3 as 3. There's a slight problem here. So this will be 0.69, not 6.9 into 24 by 10. So that will be 7 into 24, 0.7 into 24 by 10. So instead of 1.68, it will come as 16.8, it will come as 1.6. That will be the correct answer. Okay, in the previous question. Yes, yes. Instead of 0.3, I took that 3. That's why there was decimal error. Yes, Chirag, there is 1.7. Okay. So now we are going to start one of the very important. This chapter is this and electrochemistry. These are two chapters which are newer for 11th student, and that's why sometime during 11th portion, when students are studying this chapter, this is not that much clear, and that's why students find it difficult. Yes, Royal Army girl. Shivam, you can score more than that. You can score more than that. So chemical equilibrium chapter is, I would say, whole of chemical equilibrium can be solved by two things. First of all, you should understand how to write the equilibrium law. That is, equilibrium constant is greater than, equal to, or less than reaction quotient, which is RHS divided by LHS values. Okay, many of us only use the equality sign because equality sign is valid at equilibrium and most of the problems are at equilibrium. But sometimes this reaction quotient is less than equilibrium constant. That means the reaction is right now proceeding in the forward direction. Sometimes this reaction quotient become more than equilibrium constant. That means at this time the reaction is proceeding in the backward direction. The equality sign means we are having equilibrium condition. The equality sign means we are having equilibrium condition. That's correct. Second thing in this chapter is can be solved if you know how to write two conditions. One is at T is equal to 0. What are you having in the reaction mixture? What are the conditions given to you at T is equal to 0? And what are the conditions given to you as T is equal to equilibrium? And then at equilibrium, you can apply this equilibrium law and solve for the unknown value. Solve for the unknown value. Right? Yes. The third thing is about Le-Chatelier principle. Le-Chatelier principle tells you the effect on equilibrium condition. The effect on equilibrium conditions when some of the external factor affect it. So equilibrium constant can be affected only by temperature, and reaction quotient can be affected by mole of reactants, products, and volume only. So any factor which is not changing either of these three is not going to have any effect on equilibrium constant. Is not going to have any effect on equilibrium conditions. Then we will have ionic equilibrium. Ionic equilibrium is all about ions, and here we have two sections. One is of pH, another is solubility. For JEE mains and NEET, solubility section is more important. Okay? Okay. So let's start with the first section of this chapter, first question of this chapter. Kc for the reaction is given. Kp for the above reaction we have to find. Similar to delta H and delta U, we have a relation for Kp and Kc, right? What is the relation? Kp is equal to Kc multiplied by RT to the whole power delta Ng. Kp is equal to Kc multiplied by RT to the whole power delta Ng. So Kc is given as 4 into 10 to the power minus 6. R is always taken here is at atmospheric liter, and temperature is given as, okay, R is given in calorie, but we will take in the atmospheric per liter. Temperature is given as, we are not given temperature, given 300 to the whole power 2 minus 2, that is 0. 2 minus 2 delta Ng is 0, so Kp will be directly equal to Kc. 4 into 10 to the power minus 6, option B will be correct answer. So there is always one relation for Kp and Kc that we can find. Yes. I am good, Ayush. Having a little cold, but I am good. Okay, moving to the next question. The dissociation constant of a weak acid is given. In order to prepare a buffer solution of pH 5, the salt acid ratio should be. See, if you have buffer, every time buffer has a pH or pOH is equal to pK plus log concentration of salt divided by concentration of acid or base. For acidic buffer, you are always going to have pH. For basic buffer, you are going to get pOH. For acidic buffer, we will use pKa, and for acidic buffer, we will have acid here. For basic, respective basic things will come here. Right? Yes. So we are given pH 5. pK is minus log K, that will be 4 plus log salt by acid. So log salt by acid, this will come as 5 minus 4, that is 1. So the ratio of salt and acid should be 10:1. Log will go there and become 10 to the power something. Right? So 10:1 is the correct answer. Option C is the correct answer. Okay. Yes. I hope in equilibrium everyone will give the answer, because this is one of the very important chapter of physical chemistry. You can be very sure that from this chapter at least 2 questions are going to come. Moving to the next question. The exothermic formation of ClF3 is represented by the equation. We are given with the equation. Which of the following will increase the quantity of ClF3 in an equilibrium mixture of this and this? Now, for exothermic reaction, what happens? Let's see. Adding F2. If we will add F2, it will be more, and according to Lee-Chatelier, every change in equilibrium opposes the change. So F2 is increased, equilibrium will try to decrease. That means reaction will go in the backward direction. Reaction will go in the forward direction to decrease this F2 concentration. So that will increase the ClF3. That will be the answer. Increasing the volume of container. Whenever you increase the volume, reaction move towards the more gaseous mole side. More gaseous mole side. That means if you increase the volume of container, here the gaseous mole is more, so the reaction will go in the backward direction. Volume, temperature and mole only have direct effect on equilibrium condition. For this, option A is the correct answer. Removing Cl2, if you remove Cl2, equilibrium will try to increase it. Again, for increasing Cl2, the equilibrium will move in the backward direction. If you increase the temperature for exothermic reaction, temperature opposes the reaction. Because already heat is evolved, we don't need another heat to increase the reaction. So increasing the temperature will oppose the reaction. That means again the reaction will move in the backward direction. So only one thing is that option A, which is increasing the concentration of ClF3. So option A will be the correct answer. Option A will be the correct answer here. Yes. Moving to the next question. The KSP of silver, chromate silver, chloride silver, iodide are respectively given as this. Which one of the following salt will precipitate last if AgNO3 solution is added to the solution containing equal moles of Cl, Br and chromate? Now this is a condition for precipitation. This is a condition for precipitation. Let's see what happens in precipitation. For precipitation, KSP should be less than QSP. That is, ionic product should be more than solubility product. If the salt are, see here, if the salts are of the same type, you can directly compare their KSP. That means silver chloride is more soluble. Silver chloride, there are 3 salt, why 4 values are given. Okay, there is one more salt, AgBr. There is one more salt, AgBr. Silver chloride, silver bromide and silver iodide. Chloride, bromide and iodide. Out of these 3, chloride is more soluble because it is having more KSP, and iodide is the least soluble. So that means out of AgCl, AgBr and AgI, solubilities is of this order. That means this is least soluble, so this is going to precipitate first. After that AgBr, and this is the last one to precipitate among these 3. This is the last one to precipitate among the given 3. But we have to compare with silver chromate, and that is a 2:1 salt. If the nature of salt is different, you have to compare the concentration required for precipitation. Let's see. This is not the correct option. This is not the correct option. Now we are going to compare only these 2. For silver chloride, the silver ion multiplied by chloride ion should be greater than KSP, that is 1.8 multiplied by 10 to the power minus 10. For silver chromate, Ag plus square, chromate ion should be greater than 1.1 into 10 to the power minus 12. So we can see from here, for this, Ag plus will be greater than 1.8 by Cl minus multiplied by 10 to the power minus 10, and for this Ag plus will be greater than under root 1.1 by chromate ion multiplied by 10 to the power minus 12 will become 10 to the power minus 10. We can directly compare without the value that mole of Cl and chromate are equal. So just compare the power values. This is requiring more silver to precipitate. That means this is going to precipitate after AgCl. So Ag2CrO4 is the one that is going to precipitate at the last. Ag2CrO4 is the one that is going to precipitate at the last. Okay. Moving to the next question now. The following reaction is performed at 298 Kelvin. Whenever you see a person sign, this is reversible arrow. There is some font error. The standard free energy of formation is this. The standard free energy of formation of NO2 we want. Kp is given. Now, this is thermodynamics plus equilibrium. Delta G and equilibrium constant are related. Delta G is equal to, in terms of ln, minus RT ln K. And delta G of reaction will be 2 times of delta G of NO2 minus 2 times of delta G of NO minus delta G of O2, which will be 0. Any element in a free state having formation gives energy change as 0. Formation gives energy change is 0. So here we will have minus RT ln K. Instead of K, you can write Kc as well as Kp, no need to worry. So we need to find the formation of NO2. So delta G NO2 will be delta G NO. What is the value of delta G NO? 86.6 minus RT R 298 ln 1.6 multiplied by 10 to the power 12 divided by 2. Divided by 2. That will be our answer, or you can write it in this format as well. Taking divide by 2 common, it will become this. So this is our correct answer, because you have to multiply it by 1000 to convert it into joule. If you are not putting the value of R in kilojoule, you have to convert one of the delta G into joule. So that is our correct expression. Option B is the answer. Right? Yes, option B. Okay, moving to the next question now. The equilibrium constant of the following are, we are given equilibrium constant of these reactions and we have to find equilibrium constant of this reaction. See how we are going to do this quickly. This is first reaction, this is second, this is third. We want twice of ammonia, that is in first reaction but on the reverse side, so we have to convert the sign. We want O2 that is in more than 2 reaction, so we are going to ignore O2 because this is in more than one reaction. Anything which is in more than one reaction, you have to ignore it. Twice of NO in again in the second reaction on the same side that we want, we are not going to change its sign. And 3 times H2O, it is in the third reaction but we have to multiply this by 3. The multiplication becomes power in equilibrium, the plus becomes multiplication and the minus becomes division. Every mathematical operator go one step forward. So this will be 1 by K1 multiply K2 multiply K3 to the power 3. So this is the equilibrium constant, K2 K3 cube divided by K1. Option A will be our answer. Option A will be our correct answer. Yes. Rohan, option A will be the answer, not C. This is having K2 cube. Moving to the next question now. So any question on reaction analysis can be done easily just by analyzing which reaction should be added, which reaction should be subtracted, and which number to be multiplied to the reaction. And that can be known by seeing the required reaction. Yes. Now this is an interesting question. Let's see how many of you can do this question. The percentage yield of ammonia as a function of time in the reaction of N2H2 twice NH3 delta H less than 0 is given. This is given as T1. Okay. Now what is going to happen? Now what is going to happen here? Here we are going to have the temperature increased. Now if temperature is increased, what is going to happen? We have to find the graph for percentage yield of ammonia. Okay. So take this as a challenge and solve this question. Okay, so if we see here, first of all, this reaction is exothermic, right? This reaction is exothermic, and exothermic reaction goes in the backward direction on increasing the temperature. That means the percentage yield of ammonia is going to decrease at temperature T1 than as it was at temperature T1, right? First of all, so percentage yield is going to get down, but increase in temperature always increase the rate of any reaction, whether it's exo or endo. So that means at higher temperature, we are going to attain equilibrium quickly. So percentage yield is going to get down, but the rate of reaction in the beginning is going to increase. And that's why option B will be our answer. Option B will be our answer. Very good, Chirag. Yes, option B is the answer. Moving to the next question now. Concentration of Ag plus ion in a saturated solution of silver chromate oxalate is 2.2 into 10 to the power minus 4. We have to find the solubility product of Ag2C2O4. Now concentration of silver in the silver oxalate. So it will ionize into twice of silver and oxalate ion. If the solubility is S, this is going to be 2S, this is going to be S, right? Simply, if S mole of this has dissolved, so 2 and 1 ratio will be produced. Now, 2S is given to us. Concentration of silver ion is given to us as 2.2 multiplied by 10 to the power minus 4. That means S will be 1.1 multiplied by 10 to the power minus 4. So we found the solubility of silver oxalate. The solubility of silver oxalate. Okay, yes. Now Ksp will be equal to 4s cube. So 4 multiplied by 1.1 cube multiplied by 10 to the power minus 12. 2s square and s to the power 1. So the answer will be 5.3 multiplied by 10 to the power minus 12. Option C is going to be the correct answer. Option C is going to be the correct answer. Yes, option C will be the correct answer. Not A, not D, option C. Okay. See, I don't think any of you are designing the JEE or NEET paper, right? And you don't know who is the person in NTA who is designing those papers. Anyways, the next question is the degree of dissociation of PCl5 alpha obeying the equilibrium is related to the equilibrium pressure by. Now for any reaction which is A gives B plus C, the degree of dissociation can be directly calculated by P alpha square upon 1 plus alpha 1 minus alpha square, or alpha can be written as under root Kp by Kp plus P. This is a direct expression for any A gives B plus C type equilibrium. You can find the relation between alpha and equilibrium pressure directly. If Kp is small, alpha will be under root Kp by P. Like you have the expression for weak electrolyte ionization. Now, on this equation, many times questions have been directly asked in match the following type and as well as single choice correct. So, alpha will be proportional to under root P, 1 by under root P. Option B will be the correct answer. Option B will be the correct answer here. Okay? Yes. Moving to the next question. A 20-liter container at 400 Kelvin contains CO2 at pressure 0.4 atm and an excess of SRO. Neglect the volume of solid SRO. The volume of the container is now decreased by moving the movable piston fitted in the container. The maximum volume of the container when pressure of CO2 attains its maximum value will be. See, we are given SrCO3, SRO plus CO2. Kp is given as 1.68. Kp is given as 1.6 atm. Is that correct? Now, this is solid. This is solid. So, Kp will be directly equal to partial pressure of CO2 at equilibrium. And that means the maximum pressure can be attained only at equilibrium. So the maximum pressure of CO2 that is possible is only 1.6 liter, right? Maximum pressure of CO2 that is possible is 1.6 atmospheric. We are decreasing the volume of the container. So pressure into volume will be equal to P2V2. As temperature is not changed, mole is not changed. So P1 is 0.4. In a 20-liter container, P2 is 1.6, volume we have to find. So V2 will be 5 liter. V2 will be how much? 5 liter. Yes. So option D is going to be the correct answer here. Option D is going to be the correct answer here. Moving on to the next question now. Yes, 5 liter is the correct answer. Yes, 5 liter is the correct answer. Okay, the first and second dissociation constant of an acid H2O are 1 into 10 to the power minus 5 and 5 into 10 to the power minus 10. The overall, okay, this question is directly formula based. For any acid dissociation constant, the overall constant is a multiplication because we have to add all the reaction. For multiple dissociation, we have to add all the reaction. So the overall constant is always the multiplication of all the single step dissociation. All the single step dissociation, that means overall constant will be 10 to the power minus 5 multiplied by 5 into 10 to the power minus 10. That will give you 5 into 10 to the power minus 15 value of overall constant. 5 into 10 to the power minus 15. Option D will be the answer. Option D will be the correct answer. Okay. Moving to the next question now. In a saturated solution of the sparingly soluble strong electrolyte AgIO3, the equilibrium which set is this. This equilibrium has been set. If the solubility product is this, what is the mass of AgIO3 contained in 100 ml of its saturated solution? If you read this question, you will find we have to indirectly find the solubility of silver iodate. So KSP will be, if solubility is S, KSP will be equal to S square, that is 10 to the power minus 8. So S will come as 10 to the power minus 4 mole per liter, right? S will be 10 to the power minus 4. Now S is in mole per liter, we have to find the mass. So mass will be mole divided by volume. Mole will be 10 to the power minus 4 multiplied by 100 ml divided by 1000. So that will be 10 to the power minus 5 moles. And the molar mass of iodate is given 283. So mass will be molar mass multiplied by mole. That will give you 2.83 multiplied by 10 to the power minus 3. 2.83 multiplied by 10 to the power minus 3 gram is the mass of silver iodate in 100 ml of the solution. Right? Option C is the answer, not D. Option C is the answer, yes. Let's move to the next question now. Species acting as both Bronsted acid and base. What are these species called? Which are both acid and base? These are amphoteric species. These are what? These are amphoteric species. So it is clear, any polybasic base, any polybasic acid can give you amphoteric species, because in the sequence of its ionization, the intermediate form will have the capacity to absorb H plus as well as donate H plus. So they can act as both acid and base. Both acid and base. Yes, amphoteric. Correct. Moving to the next question. Which equilibrium can be described as an acid-base relation using Lewis theory? Now this is a good question, but not using the Bronsted-Lowry definition. Because if you see, all of the reaction are acid-base neutralization. But you have to find which of the acid-base neutralization is not fit for Bronsted-Lowry definition. Right? Yes. Bronsted-Lowry definition use H plus ion as acid-base definition, that H plus donor is acid and H plus acceptor is base. While in Lewis definition, we use the concept of electron. Electron donor are bases and electron acceptor are acids. If you look here, here is exchange of H plus ion. Whenever there is exchange of H plus ion, you can use this definition. Here is also exchange of H plus ion. Here is also exchange of H plus ion. Here in the complex formation, only electrons are involved. There is no exchange of H plus ion. So the fourth reaction is the one for which you can use Lewis theory and you cannot use Bronsted theory for acid-base definition. Yes, D is the correct option. Good, Chirag. D is the correct option. Yes, D is the option. Moving to the next question, which of the following statement is not true? pH plus pOH is equal to 14 for all aqueous solution. Is that true? Although you can find the incorrect statement that pH of this is 8. This is not true. Why? This is an acid. And for any acid, the pH at room temperature cannot exceed beyond 7. It should be always less than 7. In this, we have to consider water as well, and the pH comes to be around 6.95. pH comes to around, yes, 6.95. Rest all the options are correct. Only this B is the not correct statement. That will be our answer. Yes. Okay. Moving to the next question now. How many liters of water must be added to 1 liter aqueous solution of HCl with a pH 1 to create an aqueous solution of pH 2? Now, see here. I'm going to give you a trick at this point. Whenever you are diluting, first of all, the solution always moves towards 7 but never crosses 7. Because any acid solution upon dilution cannot become basic, or any basic solution upon dilution cannot become acidic. So whenever you dilute, the solution always goes towards the neutral point, that is 7. Another thing, if you dilute 10 to the power x time, the pH is going to change by plus or minus x. For acid, you can see that pH is going to increase. So for acid, the dilution pH will have positive sign. For base, the pH is going to decrease. So for base, the dilution pH is going to have negative sign. That means if we want to change the pH by 1, x should be 1. See, the difference in pH is how much? 1. So there should be 10 times dilution. There should be 10 to the power 1 times dilution. We could directly find the answer. If this is 1 liter, final volume will be 10 liter. So 9 liter of water will be added. 9 liter of water will be added. So this is very good if you want to find the pH after before dilution in a quicker way. After or before dilution in a quicker way. Okay. Is this clear? So try to remember this. Moving to the next question now. For the reaction, we are given with the reaction. Kc is given and we have to compare Kp and Kc. We have to compare Kp and Kc. Kp is equal to Kc into RT to the power delta Ng. Now if delta Ng is positive, as in this case, 2 plus 1, 3 minus 2. So if delta Ng is positive, Kc is going to have this multiply. So Kp will be greater than Kc. Kp will be greater than Kc. There is no dependence of pressure here, only the dependence of delta Ng. Only the dependence of delta Ng. Yes. Okay. Moving to the next question now. Zirconium phosphate dissociate in, okay, this is molar solubility. Okay, I think you can find directly Ksp is equal to x to the power x, y to the power y, s to the power x plus y for any ax by salt. This is our general expression for Ksp and solubility. Now zirconium phosphate is 3:4. So Ksp will be 3 to the power 3, 4 to the power 4, s to the power 7. So the correct answer will be this one. Option A will become our correct answer. In pH problem, what we have to do, that's why I tell you to keep your eyes and ears open. In pH problem, we can anytime find the dilution before or after dilution pH just by adding plus minus x. Listen again, for pH, if you are diluting 10 to the power x time, the new pH is going to be either plus or minus x. For acid, it is going to be plus. For base, it is going to be minus. Because base pH will decrease upon dilution, acidic pH will increase upon dilution. Let's move to the next question now. Which one of the following arrangement represents the correct order of solubilities of sparingly soluble salt Hg2Cl2, chromium sulfate, barium sulfate, CrCl3 respectively? This is 1:2 type salt. This is 2:3 type salt. This is 1:1 and this is 1:3. So S will be, for this, under root S will be proportional to Ksp to the power 1 plus 2, that is 1/3. For second one, S will be proportional to Ksp to the power 1/5, 2 plus 3. For third, S will be proportional to Ksp to the power 1/2, 1 plus 1. And for fourth, the S will be proportional to Ksp to the power 1/4. What we did, we used that general expression again, and we know that the power of x is always x plus y. 1 plus 2, 3, 2 plus 3, 5, 1 plus 1, 2, 1 plus 3, 4. Now, as Ksp is not given here, Ksp in this question is not given, so we will assume Ksp to be 1. In this type of question, you can assume any value. Let's say, if you cannot understand directly in this format, let's say Ksp is under root 10 to the power minus 20. So that will come as not minus 20, minus 30. Let assume Ksp to be 10 to the power minus 30. Any 10 to the power negative value you can assume. So this will come as 10 to the power minus 10. This will come as 10 to the power minus 6. This will come as 10 to the power minus 15, and this will come as 10 to the power minus 7 point something. Now you can very easily say that this is having the highest solubility, chromium sulfate. After that we have this one, chromium chloride. After that we have mercurous chloride, and after that we have barium sulfate. So barium sulfate is the least soluble. Okay, these are incorrect match. So barium sulfate is the least soluble among them. B will be our answer. B will be our answer. So you can all the time compare the solubility just by taking the Ksp and using the appropriate power. Okay, moving to the next question now. Calculate the pH of a solution obtained by, again a question on dilution. 1 ml of 0.1 molar weak monoacetic base to 100 ml at constant temperature if Kb of the base is 10 to the power minus 5. So pKb is 5 minus log Kb. For any weak base, POH is half pKb minus log C. We can do this question in two things. First of all, find the pH of this one. See how I am going to do this. POH is equal to half 5 minus log 0.1. So POH will be 5 plus 1, 6 by 2, that is 3. pH will be 11. 14 minus POH. What I did, I find the pH of the old solution. Now I am going to use a dilution concept. 1 ml to 100, that is 10 to the power 2 dilution. That is 10 to the power 2 dilution. So the new pH will be 11 minus 2, pH minus x, that will be 9. So the new pH will be 9. Okay. Or you could directly dilute the solution and then find the final pH. That is another way to solve this question. That is another way to solve the question. Let's move to the next question, shall we? For the reaction carbon plus CO2 gives 2CO, Kp is given. If at equilibrium these are equal, then calculate the total pressure. Okay. Kp is equal to 63. That will be equal to partial pressure of CO to the power 2 divided by partial pressure of CO2. So let's say partial pressure of CO is X. Partial pressure of CO2 is X, so partial pressure of CO will be 10x whole square. So that will give you X as 63 divided by 100, 0.63. 0.63 atmospheric. What we did, we are given condition of partial pressure at equilibrium and we use that condition. Now the total pressure at equilibrium will be partial pressure of CO2, that is 0.63. We assume this to be X, and partial pressure of CO, that is 10 times of 6.3, 10 times of 0.63. So that will be 6.3 plus 0.63, 6.93. That is the total pressure at equilibrium. Total pressure at equilibrium, right? Okay. Let's move to the next question. At 100 degrees Celsius, the Kw of water is 5 times its value at 25 degrees Celsius. What will be the pH of neutral solution? See, whenever we are dissociating water, H plus and OH minus are being produced. In pure water, because only water is the source, so in pure water, H plus and OH minus are going to be equal. So the concentration of either of them will be given by under root Kw. Because both are equal, so H plus is under root Kw. Now this Kw is given, which is 55 times of value at 25 degrees Celsius. At 25 degrees Celsius, Kw is what? 10 to the power minus 40. 10 to the power minus 40. Yes. So H plus will be, we found H plus. So pH will be minus log under root 55 plus 7. So 7 minus log 55 is given 1.74. So that will come as 5.26. 5.26 is the new pH at the given condition. 5.26. Yes, Rashmi, very good. Okay. Okay. Moving to the next question now. The pKa of a weak acid HA is given 4.80. The pKb of weak base is given 4.78. The pH of an aqueous solution of corresponding salt Ba. So this is a salt of weak acid, weak base. Can you solve this question? Can you solve this question? For any salt of weak acid, weak base, pH is half pKw plus pKa minus pKb. And the fun fact about that is pH does not depend on concentration for such type of salt. This only depends on the relative strength of the salt. So we just have to put the value. pKw is 14, 14 by 2 7, plus pKa 4.8 minus OH pKb 4.78 divided by 2. So that will be 7 plus 0.02 divided by 2, that will be 7.01. 7.01 is the salt pH, approximately neutral. Otherwise it will be 7.01, no? 7.01, not 7.1. Yes, good. The next question is calculate the pH of 0.5 molar aqueous solution of NaCN. This is a salt and this is having anionic hydrolysis. So this will be a basic salt. Now the trick to learn the formulas for any salt, the P is half pK minus pK minus log C. Almost all the question of pH you can do directly by the formula, learning only 4 formula. One for strong electrolyte, another for weak electrolyte, another for salt hydrolysis, and last one for buffer. For salt, what you have to do, if the salt is basic, this is going to be POH. Because this is hydrolysis, so first constant is for water. As basic salt has weak acid component, so this is going to be pKa minus log C. Minus log C. And pKb is nothing but pKw minus pKa. This is already given to us. So that will be half. This whole value is already given 4.7 minus log concentration is 0.5. Or you can write 1 by 2. So 1 by 2, that will become 1 by 2 log 2 plus 5. So the pOH will be 2.5. pH will be 11.5. So the pH of given basic salt is 11.5. 11.5. Okay. Moving to the next question. Okay, the next chapter is now redox reaction. So we are almost over with the 11th physical chemistry, and then we will start the important chapter of 12th physical chemistry. Yes, Ashmi, at the end we will write it. Okay. So this chapter is basic of electrochemistry first. Second, this chapter helps you in learning the inorganic concepts because many things are based on oxidation number. So oxidation number is a concept which is used in organic, inorganic as well as here as well. Okay. First question is a basic question. Which of the following is a redox reaction? Now what is a redox reaction? A reaction that involves both reduction and oxidation, right? Okay. So if we see here, this is having zinc 0, zinc plus 2, silver plus 1, silver 0. This is the only reaction where both reduction and oxidation is occurring. So obviously option D is the redox reaction. I think you all could find this. You all could find this. Okay. Moving to the next question now. Several blocks of magnesium are fixed to the bottom of ship. Several blocks of magnesium are fixed to the bottom of ship. What does the magnesium do this? See, ships are made of, the base of ships are made of iron. So magnesium block is attached through a conducting wire to this base. What this does, magnesium is more reactive. So this is similar to galvanization. We do galvanization to protect corrosion. So the more reactive metal always corrode first. So if magnesium is attached to iron, magnesium is going to corrode, and unless magnesium is completely consumed, iron is saved. So why do we do this? To make the ship lighter, prevent action of water and salt, prevent the corrosion. Prevent the corrosion. The fourth option is very good. How many of you think the fourth option should be the correct answer? Yes, prevent corrosion. Prevent corrosion. How many of you think that fourth should be the answer? Keep away the sharks. Okay. Which of the following chemical reaction depict the oxidizing behavior of H2SO4? Now, if H2SO4 is oxidizing, it should get reduced, and usually it gets reduced into SO2. Usually it gets reduced into SO2. Yes. So just we have to find plus 6, no change, plus 6, no change, plus 6, no change. Only here the oxidation is decreasing. H2SO4 is undergoing reduction, and that's why it is acting as oxidizing agent. This is an important reaction that whenever you have two acid Hi and H2SO4 together, although they both are acid, still they react together because of redoxation. Right? Yes. Moving to the next question now. Oxidation state of sulfur in anions SO3 2 minus, H2O4 2 minus, and H2O2 2 minus. We have to find oxidation state, and I think you all can find it. Let's see. In the first one, X minus 2, that is minus 6 is equal to minus 2. So first one is having plus 4. In the second one, twice of X, minus 2 into 4 minus 8 is equal to minus 2. So X is going to be plus 3. In the third one, twice of x minus 4 is equal to minus 2. So x is going to be plus 1. S2O2, yes. So the oxidation state of sulfur in the respective ion is in the decreasing order. We should have SO3 2 minus, then S2O4. Okay, this is S2O6. This is H2O6 in the options. So 2x minus 12 is equal to minus 2, x is equal to plus 5. So now the correct decreasing order is H2O6. Then we have SO3 2 minus, then we have H2O4 2 minus. Option C is the answer. Option C is the correct decreasing order. Yes. Right. In this question, sometimes they ask you which is having sulfur-sulfur bond or which is having peroxide linkage and all these. Now the next question is, among the following, identify the species with an atom in +6 oxidation state. Permanganate is having +7, -2, -8 plus 1, that will be +7. Chromium here is having -6, that will go there, so +3. Chromium here is having +3 and here chromium is +6. So option D is our answer. Chromium is in the +6 state. Right? Okay, let's move to the next question. Which one of the following cannot function as an oxidizing agent? Oxidizing agent undergoes reduction. So there is clear concept. If any atom is in its lowest oxidation state, it cannot undergo further reduction. So if any atom is in lowest oxidation state or oxidation number, it can never be an oxidizing agent because it can never undergo further reduction. It is already in the minimum state, right? So for this question, if we see, I minus is already in the lowest oxidation state of -1. Whereas sulfur can be oxidized up to +6, reduced up to -2. Nitrate can be reduced. Chromium can also be reduced to 0 or minus states. So only I minus is which cannot function as an oxidizing agent. Option A is the answer. Moving to the next question now. In the standardization of sodium hyposulfate using K2Cr2O7 by iodometry, the equivalent weight of K2Cr2O7. Always remember, if you are given K2Cr2O7 in any of its redox reaction, if the reaction is not given, in any of its redox reaction, it always converts into +3. And the n factor of this will be 6. By using the same formula, atomicity into change in oxidation number. Atomicity into change in oxidation number. So the equivalent weight will be molecular weight by n factor. Molecular weight by n factor. Right? Yes. Let's see the next question. Consider this reaction. Which of the following statement is correct? Sn plus 4 is the oxidizing Sn plus 4. Sn plus 4 is getting reduced. So this is oxidizing agent. So Sn plus 4 is the oxidizing agent because it is undergoing oxidation. Incorrect. It is undergoing reduction. SN4 is reducing agent. That is also incorrect. H2SO3 plus 4 plus 6. It is undergoing oxidation and that's why it is a reducing agent. So H2SO3 is a reducing agent because it undergoing oxidation. That is correct. Option C is the correct statement. Just a simple concept of oxidation number. Okay, let's move to the further question. The species that undergo disproportionation in alkaline medium are. This is again important thing for halogen. All halogen except fluorine undergo disproportionation reaction into halide and hypohalite ion. This is an important reaction of P block chemistry. Similarly, MnO4 2- undergoes disproportionation and NO2 also undergoes disproportionation into nitric and nitrous acid. MnO4 minus undergo disproportion into permanganate ion and manganese dioxide. So all of these species undergo disproportionation in alkaline medium. Now some of the question of redox reaction seems like they are from inorganic chemistry. Why? Because they are conceptually based question. Okay. Moving to the next question. H2S act only as a reducing agent while SO2 can act both as reducing and oxidizing because the reason is simple. H2S is already having sulfur in the lowest oxidation state. So if sulfur is already in the lowest oxidation state, it cannot be further reduced. Clearly. So that is our answer. Option D. Right? Yes, that is true. That is true. Jayashree, which order and priority? Moving to the next question. Here we have to find which substance serve as a reducing agent, the one which is undergoing oxidation. Let's find out. +6, 0, +3, +2. Nickel is undergoing oxidation, so this is a reducing agent. Chromium here is the oxidizing agent. So nickel is here the reducing agent. Okay, moving to the next question. Which one of the following reaction involves disproportionation? What is disproportionation? Reaction in which same element undergoes reduction as well as oxidation. Those reactions in which same element is reduced as well as oxidized are disproportionation reaction. Let's see here. H2SO4, there is no oxide. 0, +2, +6, +4. So this is a simple redox, not disproportionation. +3, -2, +3, -2. This is no redox, this is simple double decomposition. Right? KOH 0, -1, +1. Chlorine is getting reduced, chlorine is getting oxidized, so that is our disproportionation reaction. Option C is our, and third reaction is also not any redox reaction, last one. So option C is our correct answer, as this is the only disproportionation reaction involved here. We have already discussed mole in the first chapter. You can go back and see the beginning of the lecture. Point out the correct statement of the following about Na2S4O6. This is a very important compound. This is called as sodium tetrathionate, in which we have this structure. Many times questions have been asked on the structure of sodium tetrathionate. Here you can say that sulfur is bonded to 5 bonds, so it is in +5. It is in 0, 0 and +5. So the average oxidation number of sulfur atom is +2. No, 5 + 0, that will be 2.5, not 2. Oxidation number of 2 sulfur atom is 0, that is correct. And that of other 2 is +5 each, that is also correct. So option B is correct, rest of the options are not correct. Right? Bond order you can calculate by anti-bonding bonding electron. Bonding electron minus anti-bonding electron divided by 2. Okay, we'll move to the next question. Thiosulfate reacts differently with iodine and bromine in the reaction given below. Which of the following statement justify the above reaction of thiosulfate? See, just read the statement. Bromine and iodine we have to compare. First of all, we see here thiosulfate is +2 to +2.5, +2 to +6. Both bromine and iodine are oxidizing thiosulfate. Both are oxidizing. But bromine is giving more change in oxidation number as compared to iodine. Iodine is oxidizing but less, bromine is oxidizing but more. That means bromine is more oxidizing in power. Bromine is stronger oxidizing than iodine. That is correct. Thiosulfate undergoes oxidation by bromine and reduction by iodine. No, it is going oxidation by both. Bromine undergoes oxidation and iodine undergoes reduction. No, both are going under reduction. So only option A is the correct answer. That as bromine is bringing more change in oxidation number, so bromine is going to be better oxidant. Bromine is going to be better oxidant. Yes. We are given with the standard reduction potential and we have to compare the strongest and oxidizing and reducing agent. Now, reduction potential tells you the tendency to reduce. So, oxidizing power is tendency to reduce is directly proportional to SRP, and reducing power tendency to oxidize is inversely proportional to SRP. So the one which is having more SRP, that is fluorine, is the strongest oxidizing agent, and the one which is the lowest SRP, that is iodine, is going to be the strongest reducing agent. So we can anytime compare the oxidizing, reducing power, anode, cathode using electrochemical series. Using electrochemical series. Yes. Okay. Moving now to the next question. A mixture of potassium chlorate, oxalic acid and sulfuric acid is heated. Now, potassium chlorate, oxalic acid and sulfuric acid is heated. Now, oxalic acid whenever reacts with an oxidizing agent, so this will undergo reduction and this will undergo oxidation. Sulfuric acid is just a medium, acidic medium. Sulfuric acid is just a medium, acidic medium. So here we have Cl in +5, carbon in +3, sulfur in +6, sulfur in +6, carbon in +4 and Cl in -1. Obviously, chlorine is the atom which is undergoing maximum change in oxidation number. Chlorine is the atom which is undergoing maximum change in oxidation number. Yes. Let's move to the next question now. Zinc gives hydrogen gas with H2SO4 and HCl but not with HNO3 because sulfuric acid, HCl and HNO3. Not for zinc, any metal when react with acid produce hydrogen gas. More of the metal which are more reactive than hydrogen when react with acid produce hydrogen gas. But if those metals react with nitric acid, it produces oxide of nitrogen like nitrous oxide, nitric oxide or nitrogen dioxide. That is, in case of acid, H plus is getting reduced. But here, nitrogen is getting reduced. Instead of H plus, nitrogen is getting reduced. So what happens here? Can we say that nitrate is having more reducing tendency than H plus? Because metal is same in the both case. Metal is same in both case, but still they are giving different product. Why? In case of other acid, H plus is getting reduced. But in case of nitric acid, both H and NO3 are present. But here NO3 ion is getting reduced. Definitely NO3 minus ion is having more reducing tendency, more better oxidizing agent than H plus ion. So let's find the answer. NO3 minus is reduced in preference to hydronium ion. Can anyone in chat box comment and tell me which of the two metals are there? There are only two metals which can produce hydrogen gas with nitric acid. Hydrogen gas with nitric acid. Can anyone tell me which are these two metals which can produce hydrogen gas with dilute nitric acid. There are only two metals as such. Okay. Think of it and tell me. Now we are going to do the balancing of reaction. How we will balance? This is another trick. We will use the n factor method for balancing, not oxidation number, not half cell reaction. No, Mang, it is not copper. It is not copper. Yogesh, one is correct, another is wrong. Not copper, not tin. Yogesh, one is correct, another is wrong. Plus 7, plus 2, plus 3, plus 4. So definitely here, the n factor of oxalate will be atomicity multiplied by change in oxidation number. The n factor of permanganate will be atomicity multiplied by change in oxidation number. Whenever you want to balance from n factor, just cross the n factor. Whenever you want to balance the n factor, then you just have to cross it. How to cross it? 3 will go in front of MnO4 minus. 5 will go in front of oxalate ion. Rest, we can balance them using analysis. Three Mn, so 3 here. So we have to cross the n factor. N factor of this will go here and n factor of this will go here. 3 Mn here, so 3 should be here. 5 C2O4, so here should be 10 CO2. Now if for oxygen we check, or let's first balance the oxygen, 20 here. And here we have 5 into 4, 20 plus 12, 32. 5 into 4, 20 plus 12, 32. So we need 12 oxygen more. We need 12 oxygen more to make 32. Yes. So we will add 12 water here. And in order to balance H plus, we will add 24 H plus. Now X plus Y plus Z we need to find, right? X is 3, Y is 5, Z is 24. So that will come as 32. The question, the summation that was asked in the question is 32. Yes. It actually is not necessary that you always balance oxygen first. You could balance hydrogen first as well. We just have to cross the n factor and after that we can balance everything. Okay. Moving to the next question, how many electrons are involved in the following redox reaction? You can balance this reaction, and anytime whenever you want to, you have an urge to balance a redox reaction, try to think that there will be some method which will require less effort all the time. And that could be an oxidation number method. This is plus 6, this is plus 3, this is plus 2, this is plus 3. This is plus 4. Again, if we see the change, it is having an n factor of 6. N factor of 6. This is having an n factor of 3. Right? We have already calculated the n factor of ferrous oxalate earlier. So, definitely, the difference in n factor is 3. So, total 3 electrons will be removed. Now, you can try to balance this reaction and you will find that you will add 3 electrons on this side. 3 electrons on this side if you will balance this reaction. So what we did, we took the difference of n factor, and that difference of n factor will give you the extra number of electrons. Will give you the extra number of electrons. Moving to the next question now. In this reaction, we have to calculate the ratio of, obviously we have to balance it. This is a simple reaction, so we can balance it directly. No need to find n factor. For simple reaction, no need to make it complicated. Let's see. 2 carbon, 6 hydrogen, 2 to 4 plus 3, 7. So 7 by 2 oxygen. 7 by 2 oxygen. So the ratio of coefficient is 2:3. Ratio of coefficient is 2:3. Yes, that's correct. 2:3. Okay. Now in this question, the number of molecules having nitrogen in negative oxidation state. We just have to find in which of the molecule nitrogen is in negative oxidation state. Although we could solve this directly as well, only 2 atoms are more electronegative than nitrogen. Only 2 atoms are there which are more electronegative than nitrogen, and only these two have ability to take nitrogen in the positive state. So if the question is asking nitrogen in negative, the compound in which oxygen or fluorine are not present, in all the other compound nitrogen is in negative state. Without finding the oxidation number, we could also solve this question. I am just telling you every alternative method, every smart method to solve any question that will save your time. Right? If you want to balance a reaction in basic medium, balance first it in acidic medium, then add equal number of OH minus as they are H plus on both sides. Add as many OH minus as they are H plus on both sides, and the reaction will become basic. And the reaction will become in basic medium. So we are having 1, 2, 3. There are 3 molecules which are having nitrogen in the negative oxidation state. Nitrogen in the negative oxidation state. Okay. Now we are moving to the next chapter, which is of 12th. Now we are going to start the physical chemistry of 12th, and we will start with the solid state. The solid state which we talk about cubic system, crystalline system and all that. Okay. Let's see the first question here. The cubic unit cell of a metal has an edge length of 362 picometer. Density is given. This type of unit cell is. We have to find this type of unit cell. The type of unit cell can be defined as density is equal to Z multiplied by molar mass divided by Avogadro number multiplied by AQ. From here you can find Z. If effective number of atom is 1, the unit cell is simple, primitive. If it is 2, this is body centered. If it is 4, this is face centered. So by finding Z through density, we can have the type of unit cell. Let's see what is density, 8.92. What is Avogadro number? This is 6 multiplied by 10 to the power 23. What is A cube? Density is in centimeter, so we are going to put A in centimeter as well. 362 picometer, 3.62 cube multiplied by 10 to the power minus 10. Minus 8 will become, so minus 8 cube will be minus 24 divided by molar mass. Molar mass is 63.55. From here we can calculate Z. From here we can calculate Z. Can you tell me what will be the Z? Let's take this to be 9 into 6, 3.62 cube, 10 to the power minus 1 divided by 63.55. Solve this for Z and you will find Z. What is Z here? Nine into 6 into 3.62 cube divided by 63.55. After solving this, Z will come approximately to be 4. That means the given unit cell is face-centered unit cell. For face-centered unit cell, we have effectively 4 number of atoms in a unit cell. 4 number of atoms in a unit cell. It achieves what theory? We are discussing theory along with the question, right? In this question, the theory portion is mainly of defect. Last 2-3 pages of NCERT are very important for this chapter. Okay. Moving to the next question now. The coordination number of each ion in KBr is changed to. Now this is an interesting thing. Why? Some of the students find it confusing to remember what happens when temperature increases And what happens when pressure increases? What is the effect on coordination number and how NaCl changes to CaCl, CaCl changes to NaCl? The concept is very easy. Think of it like that. If you increase the temperature, molecules are going far away, and as a result, neighbor will become less. So whenever you increase the temperature, the coordination number decreases. Whenever you increase the temperature, the coordination number decreases. And whenever you increase the pressure, as upon increasing the pressure, the molecules are coming closer, and as a result, coordination number will increase. So NaCl is 6:6 type, coordination number wise. CaCl is 8:8 type. So if any of you have a confusion, when you increase the temperature, cesium chloride will change into NaCl type. Coordination number will decrease. When you increase the pressure, NaCl will change into CaCl type because coordination number will increase. In this chapter, there is no theory. This is all about cube and mass. This chapter is all about cube. We have to just analyze the cube here. Okay? So if we increase the temperature, coordination number is going to decrease. That is incorrect. If we increase the pressure, coordination number is going to increase. If we increase the pressure, coordination number is going to increase. So option C is the correct answer. Option C here is the correct answer. Moving on to the next question now. The radius of lithium plus ion is 60 and that of fluoride ion is 136 picometer. Structure of LIF and coordination numbers. So this type of question are done by the radius ratio. If radius ratio is less than 0.414 and more than 0.225, the cation occupy tetrahedral void. Because the cation is very small, so it will occupy tetrahedral void. Okay? Yes. And if the radius ratio is in the range of 0.414 to 0.225, 0.732, then it will occupy octahedral void. And if the radius ratio is more than 0.732, less than 1, then it will occupy cubic void. We are having sodium oxide, calcium fluoride and zinc sulfide. These are the solids which are having this type of tetrahedral void occupancy. We are having NaCl, KCl, these are the solids which are of this type, and we have cesium chloride which is of body center type or occupy cubic void. So let's find the radius ratio here. Radius of a smaller one divided by radius of bigger. Always smaller one in the numerator, bigger one in the denominator. So the smaller one is 60 divided by bigger one which is 136. So that will come, if this was 120, that will come 0.5. So 136 will be approximately 0.44. So it is in this range. That means coordination number is going to be 6 and it will be like NaCl. In NaCl it happens that Cl minus forms FCC and Na plus occupies all the octahedral voids which are at edge center and body center. Moving on to the next question now. The number of carbon atoms per unit cell of diamond. Diamond is like ZnS type. The only difference is instead of sulfide and zinc, all the places are at of carbon atom. So here sulfide forms FCC and this occupies alternate 50% tetrahedral void. Alternate of 50% tetrahedral void. So if we look here in the diamond, carbon is going to be in FCC, so 4 carbon atoms for FCC. Alternate tetrahedral voids, so total of 8 voids are there. So effectively we have 8 carbon atoms in a unit cell of diamond. 8 carbon atom in a unit cell of diamond. So option A is going to be the correct answer. Option A is going to be the correct answer. Right? Yes. Let's see the next question. We have done almost 150 plus question up to now. That is an achievement. The piconometric density of sodium chloride is 2.165 into 10 to the power 3. Its X-ray density is 2.178 into 10 to the power 3. The fraction of unoccupied site. We have to find fraction of unoccupied site. This is 1 minus piconometric density divided by X-ray density. If you haven't seen this formula anyhow up to this point, memorize this formula. This is going to be useful. Okay? The percent of or the fraction of unoccupied site. So here now we just have to put the value 1 minus X-ray density, so 2.178 minus 2.165 divided by 2.178. The 10 to the power 3 will be cancelled because it is in both. So that will be 0.013 divided by 2.178. So that will be 13 divided by 2.178 multiplied by 10 to the power minus 3. It will come approximately 5.9 multiplied by 10 to the power minus 3. So that is the fraction of sites that are unoccupied. Fraction of sites that are unoccupied. Yes, दोनों का dense. We have to find the density ratio of both and then we have to subtract it. Yes. Okay. Now moving to the next question. Which of the following metal oxide is anti-ferromagnetic in nature? This is given in your NCERT, where many compounds are given in the example of your paramagnetic, diamagnetic, ferromagnetic and anti-ferromagnetic. And all these examples have been sometime asked and sometime will be asked. So this is the most common asked example, anti-ferromagnetic. For this you have to read all the lines in the last 3 to 4 pages of this chapter. All lines are very, very important, whether it's of defect example, magnetic properties example, electrical properties example. So here we have MnO2. This is anti-ferromagnetic here. MnO2 given in the example. MnO and MnO2 both. Okay? So you have to learn and revise every example in NCERT for this chapter. Which of the following solid is not an electrical conductor? See, iodine here is a molecular solid. Iodine here is a molecular solid. Molecular solid do not have any free electron, any polarity in this case. So this is not going to conduct electricity anyhow. Water solid can conduct because it has some polarity. So it is a weak conductor, but it can conduct. This is metallic solid. It will have free electron. This is ionic solid. It will have free electron. So only iodine, which is a non-polar metallic solid, is not going to conduct electricity at all. It's not going to conduct electricity at all. Let's see the next question. This is a very halwa question, right? Cubic lattice. All edge length are equal, alpha, beta, gamma are equal. No need to waste time on this. We will just mark the answer and move ahead. Right? We all know what the cubic unit cell is. All edge length are equal and all angles are 90 degrees. Okay. The pure crystalline substance on being heated gradually first form a turbid liquid at constant temperature, and at higher temperature turbidity disappears. The behavior is off. So allotropic crystals are those crystals which have similar kind of formula and similar kind of lattice. Liquid crystal is the crystal which is showing this behavior. This is a property. You will read these properties in the behavior of liquid crystal. That on heating first they become turbid and after further heating the turbidity disappears. So this is a characteristic of liquid crystal. Isomeric means same molecular formula. Isomorphous means similar structure. So for this, option B, liquid crystal, is the correct answer. Okay. Turbidity means the solution will become cloudy, like you dissolve chalk or let's say calcium hydroxide in water and the solution becomes cloudy. That is your turbidity. And when you dissolve sugar in the solution looks very clear, it is transparent, that is losing the turbidity. So the meaning of turbidity is cloudiness in the solution. The solution will become opaque, not transparent. Okay, the next question is about the radii. We have Na plus Cl minus, zinc 2 plus sulfide, titanium and oxide cesium, and we have to choose the correct option following the radius ratio. See, we already know for Na and Cl, they are going to be in octahedral holes. So this is correct. Zinc 2 plus iron are packed in tetrahedral holes, so this is also correct. Cesium plus iron are packed in body-centered holes, so this is also correct. So we could solve this question by using the radius ratio that we saw earlier, the range of radius ratio, by defining the crystal. Have a look at this once again. If the radius ratio is in between this, the solid is going to be zinc sulfide type. If this, the solid is going to be octahedral void, and if this, the solid is going to be a simple unit cell with cubic void. Simple unit cell with cubic void. Or we can learn the example because these three are very known example in our syllabus. So I think we should have known these. That NaCl has sodium ion in octahedral, Cl minus in FCC. Zinc sulfide has sulfide ion in FCC, zinc in alternate tetrahedral hole. Cesium chloride has one of the ion in PCC. It could be cesium, it could be Cl minus. Any one ion in simple cell and another ion at the body center. And another ion at the body center. Okay? Yeah, there will be many questions. Moving to the next question now. For a cubic geometry, cubic means PCC plus body void or cubic void. And for that, the limiting radius ratio that we see is in between 0.732 to 1. So it should be, if we want to know the limiting radius, so it should be 0.731. The limiting value will be equal to, this is the equal to value, 0.732. Yes. Yes. Okay. You should have a fire inside you to keep on going, to keep on studying, to secure a good rank in your final exam. That fire should be inside you. And that fire should not be extinguished by any factor, any societal, surrounding, neighboring, any factor. PCC means primitive cubic close packing. Primitive cubic close packing. Now moving to this question. For zinc sulfide, we have already seen that this is FCC plus 50% tetrahedral void. So we are going to have here 4 to 4 ratio. 4 zinc sulfide will be there and 4 sulfide atom will be there in the half tetrahedral, right? Then its structure is similar to diamond, that is correct. Sulfur minus is larger, 6 rather than 8. This is also possible in wurtzite. Wurtzite is also zinc sulfide, but this has hexagonal close packing. This is true for zinc blend. Both zinc blend and wurtzite have zinc sulfide, but one is of cubic system, another is of hexagonal packing. In hexagonal packing, we have 6 atoms surrounding 6 atoms, that is ratio of 6:6. In cubic, we have a ratio of 4:4. So both of these statements are true with respect to one another lattice. Only this is the incorrect statement, that zinc sulfide is a covalent. This is an ionic compound. We are talking about ions all the way here. We are talking about ions all the way here. Right? Okay. Moving on to the next question. AB crystallizes in a body-centered cubic lattice with edge length A, which is equal to 387, the distance between two oppositely charged ions. What happens in body-centered cube? In body-centered cube, one of the atoms are at the corner. This is the meaning of body center. One of the atoms are at corner and the another atom is at the body center. So the separation between ions, separation between oppositely charged ion is half of body diagonal under root 3a by 2. So the separation will be under root 387 divided by 2. So that will be under root 3 multiplied by 2, 9, 3.5, that is 1.7 into 193.5. 1.7 into 193.5, that should be around 300, right? That should be around 300. Just check it and tell me. Yes, 328. This is around 328 picometer. That means option A is going to be the closest answer. Option A is going to be the closest answer, right? Okay. Moving to the next question now. How many unit cells are present in a cube-shaped ideal crystal of NaCl of mass 1 gram? Now, if you look at NaCl, NaCl has Cl in FCC, so 4 Cl ions are present, and Na plus in octahedral void, so 4 Na plus ion is also present. That means one unit cell of NaCl has 4 NaCl entities. We can have 4 NaCl molecule in one unit cell of sodium chloride. So if we have 1 gram NaCl, 1 gram NaCl will have 1 by 58.5 into Avogadro number of molecules. Now 4 molecules are forming one unit cell. One molecule will form only 1/4 of the part of unit cell. So this much molecule will form this much divided by 4 number of unit cell. So this much unit cell will be present. This much unit cell will be present. Now there is a time to approximate. Assume that to be 60. So 60 into 10 to the 10 into 10 to the power 21 divided by 60 into 4. So that will be approximately 2.5 multiplied by 10 to the power 21. That much unit cell is approximately present. Option D is going to be the answer. Option D is going to be our correct answer. Right? Yes. Okay. Okay. Moving on to the next question now. The interionic distance for cesium chloride, we have already calculated. This is a body-centered type. We already saw in the body-centered type, one of the ion is at the corner, let's say chlorine, and one of the ion is at the body center. And the separation between these two ions is nothing but 1/2 of the body diagonal. Under root 3a by 2 is the separation between oppositely charged ion in a body-centered unit cell. Oppositely charged ion in a body-centered unit cell. Okay. Moving on to the next question now. For FCC, if AB is just like the rock salt, then A and B. In rock salt, anion forms FCC. You have to remember these information for all the examples that are in your syllabus. And all other information like radius relation, number of molecules in a unit cell, coordination number, that can be calculated. Just you have to remember the positions of all the example of rock salt, zinc blende and cesium chloride, mainly these three. Cesium chloride is body center type. This is its specialty. So A plus will be in octahedral void, and B minus will be in the corner and the face center. This is not comma. This is not comma. This is not going to come anywhere. This is corner. Corner and faces center. Yes. Okay, moving on to the next question now. Which of the following exists as covalent crystal in the solid state? So this is a well-known example. Silicon, when crystallizes, silicon atoms are attached to a covalent bond. So this is a covalent. This is a covalent or network solid. Covalent or network solid. So silicon exists as a covalent crystal in the solid state. Rest, iodine is a molecular solid. Sulfur phosphorus is also a molecular solid. Okay, moving on to the next question now. The packing fraction for body centered. This is a just factual question. For body centered, the packing efficiency is 68%, right? For simple cell, it is 52.4%. For body center, it is 68%, and for face center, it is 74%. So you should remember these data, only that. A metal crystallizes in two cubic phases, FCC and BCC, whose unit cell length are 3.5 angstrom and 3 angstrom respectively. The ratio of their density. See, the formula for density is dZm by NaAq. Right? Now we have to find the ratio of density of FCC divided by density of BCC. What are the things that are going to change? M, molar mass of metal, is not going to change. Avogadro number is not going to change. So Z by A cube for FCC divided by Z by A cube for BCC. So for FCC, Z is 4 and FCC A is 3.5, that is 7 by 2 cube, divided by, for BCC, Z is 2, effectively 2 atoms, and divided by 3 cube. So it will come 2 multiplied by 2 cube divided by 7 cube, and this 3 cube will go above, so multiply by 3 cube. This is the ratio of their density. This is the ratio of their density, which can be easily calculated, right? Yes. Okay. Let's see next question. To get a N-type, what is the meaning of N-type? N-type means the charge carrier, the majority charge carrier are here negatively charged. That is, electrons are here charge carrier. P-type means positively charged carrier. That means holes are there positively charged carrier. Right? Yes. So for N-type, what you have to do, you dope with, if you have silicon, you dope with an element which is of having more valence electron. Then only some of its valence electron will be free, and those free valence electron will make it a negatively charged charge carrier semiconductor. So we have to dope a substance with valency of 5, because silicon is having a valence electron 4. So we will have an atom with valence electron 5. So valency will be 3 or 5. But we will write here valence electron, not valency. We should dope with an atom with valency 5. Pentavalent, yes. Pentavalent atom. Not SnCl2. From where you are getting SnCl2 here? What is the concept of SnCl2 here? Okay, moving on to the next question. Aluminum crystallizes in the cubic system with a cell edge of this. Density is given 2.7. We have to calculate radius of aluminum. Okay. Here cubic system is also not given, and radius. Okay, this is having some incomplete. This question is actually incomplete. Here cubic system is not given. Which type of system is there? Otherwise, we will use density is equal to Zm by NaAq. If we are given with Z, we can find A, and from A we can find radius. How? For PCC, radius relation is 2r is equal to a. For BCC, radius relation is 4r is equal to body diagonal. And for FCC, radius relation is 4r is equal to face diagonal. So if Z was given, that is system of Q was given, we could find A, that is edge length from formula, and using edge length we could find the radius of the atom. See, we don't have to find edge length here, we have to find radius. So for radius and density both, we need the type of cubic system. That is not given here. That is not given here. Yes, Rahul, this is applicable. Moving to the next question now. What is the coordination number of sodium and sodium oxide? Sodium oxide is called as anti-fluorite structure. Here oxide ion forms FCC and Na plus ion occupies all tetrahedral void. So obviously, if Na plus ion is in tetrahedral void, and tetrahedral void are formed by 4 atoms, right? So if Na plus is in tetrahedral void, so its coordination number is going to be 4. One more thing. If you have stoichiometry of 2:1, coordination number will be 1:2. So if you know the coordination number of atom in void, you can also find the coordination number of the neighboring atom. Because the coordination number is 1:2. The coordination number of oxide here will be 8. Coordination number of oxide here will be 8 and coordination number of sodium here is 4. Coordination number of sodium here is 4. Yes. Okay, correct. Moving on to the next question. Okay, I think this is next chapter. So now this is a time for another break. We will have another little break of 10 to 12 minutes. After this, we will meet again. Now only 4 chapters are left, and surface chemistry is a very small chapter, so this is not much left in physical chemistry. We will meet after the break. Those who are doing question, those who are studying, have some energy drink, have some energy back, and we will meet again. And then we will start solving the chapter's solution. Okay? So we will meet after this short break. What Na2O3 type? Na2O3 is nothing, Na2O. Okay, we will meet after the break, then we will discuss some doubt as well. Hello, hello, hello. So it's time to be back again with the important chapter solution. Okay, it's time to be back again. You can download the PDF from the PW app. It is available on Safalta batch, on Victory batch in English. Yes. Okay, so we'll move forward with our solution chapter. Now only major chapter of 12 chemistry, 12 physical chemistry has been left. PDF is available in the PW app section in the batch of Victory. There's a free Victory batch. Okay. So moving ahead, solution chapter is about three things: Raoult's law, Henry law, and colligative property. Raoult's law is all about vapor pressure, and remember, this point is very important, that vapor pressure is something which is of equilibrium state. That is, vapor pressure follows all the law of equilibrium, and sometimes you will feel that it is not following states of matter condition. Okay. Roshni, try finding Victory batch named Victory. You can subscribe that Victory batch directly. It is free batch, and in that batch you will have a Maha revision session or marathon session. From there you can download the PDF or all the marathon session. Okay. So in this question, the solubility of a solid in liquid is significantly affected by the temperature. Again, if we are talking about solubility, solubility is also a concentration of solute, maximum concentration of solute, and that is obtained at equilibrium only. That means if we have delta H negative, so on increasing temperature, reaction will move backward and less solute will be dissolved. So solubility will decrease. If we have delta H as positive, endothermic, on increasing temperature, equilibrium will move forward, more solute will dissolve. So solubility for such solids increases. So for solids, solubility change is dependent on enthalpy. For exothermic, higher the temperature, less is the solubility. For endothermic, higher the temperature, more is the solubility. So if we see here, delta H positive, temperature and solubility are directly related, so this is not correct. Delta H negative, temperature and solubility are inversely related, so this is correct. Delta H positive, again temperature and solubility are directly related, this is not correct. Delta H negative, temperature and solubility are inversely related, so this is also not correct. So option B is the correct option. Option B here is the correct option. Moving on to the next question now. A solution containing component A and B follows Raoult's law. Now, what is the condition to follow Raoult's law? What is the condition for a solution to become ideal? When solution becomes there new interaction between solute and solvent particle. If this interaction is similar to the previous one, the solution is having not less, not more vapor pressure as expected. That means at this condition, the solution is going to behave ideally and follow the Raoult's law. If this force is getting stronger, then the solution will behave negative deviation, because there will be less evaporation because of more attraction. And if this interaction has become weaker, the solution will have positive deviation, because then there will be more evaporation, more vapor pressure because of the less interaction. So we should have that AB attraction force remains same. Option C will be right. And in case of option D, for ideal solution, delta V mixing and delta H mixing both are 0. That is, volume of solution is not different from summation of volume of solute and solvent. C is the correct answer. Yes, that's correct. C is the correct answer. Okay, moving on to the next question now. For a solution of two liquid A and B, it was proved that PS is equal to XA PA naught minus PB naught plus PB naught. So the solution is, now this is another form of Raoult's law, right? This is another form of Raoult's law. So if this is the Raoult's law equation, the solution will behave ideally. Any solution which is following Raoult's law will behave ideally. correct. Okay, moving on to the next question. All form ideal solution. Now, how to identify the ideal solution? The more similarity you can find between solute and solvent, the more solubility you can find between solute and solvent, the more close the solution will be to ideal situation. That is, homologous series, member of same homologous series are behaving like ideally. So if we talk about here, benzene and toluene belong to same homologous series, they will behave ideally. Ethane and ethyl iodide, we will think about this. Ethyl chloride and ethyl bromide, they are also belonging to same functional group series, ideally. Iodide and alcohol. So B and D both could be correct answer. Both will show some of the deviation. Although, as iodine is very less polar, this is also non-polar. So they are quite similar in polarity. Here the difference in polarity is very much higher. So the dissimilarity is higher in this. This will deviate most among the given option. So option D is the most deviating solution from ideal behavior. That is, all form ideal solution except this option D. Option D will be the correct answer here. Okay. Now the next question is, a binary liquid solution is prepared by mixing N-heptane and ethanol. Which one of the following statement is correct regarding the behavior of the solution? See what happens whenever you have to find positive or negative deviation. Students again find this confusing or they have to memorize the example. You can use a trick here that if new H bonding are formed, the solution is going to show negative deviation. If new H bonding are formed, solution is going to show negative deviation. And if old H bonding are getting distorted, broken, solution is going to behave positive. Ethanol can form H bond. Heptane is non-polar, so it cannot form H bond. So obviously when we will mix heptane and ethanol, some of the previous bond of ethanol will be broken down because of the new interaction. So if some of the bonds are being broken down, that means this is showing positive deviation. This is showing positive deviation. Solution is non-ideal, that is correct. Negative deviation, no. Solution is non-ideal, showing positive deviation, that is correct. That is correct. It cannot happen that both solute and solvent show different type of deviation, and solution is obviously not ideal. Solution is obviously not ideal. Yes, B is the correct answer. B is the correct answer here. Moving to the next question now. During depression of freezing point in a solution, the following are in equilibrium. See, whenever we are talking about colligative property, non-volatile solute neither freezes nor evaporates. So equilibrium can be maintained in those substances which are showing the phase change. So only solvent is freezing even if solute is dissolved. Only solvent is freezing, but the freezing point has been depressed. So still we are going to have the equilibrium between liquid and solid form of solvent. Liquid and solid form of solvent. Option A is going to be our answer here. Option A is going to be our correct answer here. Moving to the next question now. Which of the following modes of expressing concentration is independent of temperature? Now, we have three things: mass, mole, and volume. Out of these three things, these two are temperature independent. And volume is something which changes upon changing the temperature, because the space between the particles may change. So any concentration terms which involve volume, percentage mass by volume, or molarity, or formality, normality, any term which is involving volume will become temperature dependent. Only molality is here, which involve mole and mass of solvent, mole of solute and mass of solvent. So this is only going to be temperature independent here. This is only going to be temperature independent here. Option B will be the correct answer. Option B will be correct answer here. Moving to the next question now. Which among the following will show maximum osmotic pressure? See, osmotic pressure is equal to pi is equal to ICRT, right? Where I is Van 't Hoff factor. So if we look here, Van 't Hoff factor for NaCl 2 ions. For dissociation, Van 't Hoff factor is 1 plus n minus 1 alpha. If alpha is 1, then Van 't Hoff factor is equal to number of ions. Number of ions. So number of ions here is 2, number of ion here is 3, number of ion here is 4, and number of ion here is 3. So this is going to be having maximum Van 't Hoff factor. So this is going to show maximum osmotic pressure. You should only be clear about which one is showing maximum and which one is showing minimum. Right? Option C is the correct answer here. Option C is the correct answer here. Moving on to the next question. Which of the following 0.1 molar aqueous solution will have the lowest freezing point? Now, freezing point is something in which you can make mistake, and many students do make mistake. Why? Because we are talking about depression. That is, freezing point of pure solvent minus freezing point of solution is equal to I Kf molality. First of all, let's find I. This is giving you 5 ions, so I will be 5. This is non-electrolyte, so I will be 1. For those solute which does not dissociate, Van 't Hoff factor remains 1 for them. For this, Van 't Hoff factor will be 2. For this, Van 't Hoff factor will be 1. Now, if Van 't Hoff factor is more, depression is going to be more. If this is more, depression is going to be more. But if depression is more, because of the minus sign, freezing point is going to be less. Freezing point of actual solution is going to be lesser. So the one having highest Van 't Hoff factor, because the molality is same, will have highest freezing point. Depression will have lowest freezing point. Will have lowest freezing point. Yes, that's correct. Option A will be answer here. The next question says, if sodium sulfate is considered to be completely dissociated. Sodium sulfate is Na2SO4. If it is completely dissociated, Van 't Hoff factor will be 3. Okay, moving ahead. Into cation and anion in aqueous solution, the change in freezing point. Delta TF is equal to I, that is 3. Kf, that is 1.86. And the molality is mole divided by mole mass of solvent in kilogram. So this will give you 3 into 6, 18. 8 into 3, 24 plus 1, 5. 5.58 into 0.01. So that will be 0.0558. This will be the change in freezing point. And in temperature difference, you can write in Kelvin as well as in degree Celsius, because temperature change is same in both unit Kelvin and degree Celsius. Kelvin and degree Celsius as well. So here we are going to find option B as the correct answer. The next question says, which one of the following salts will have the same value of Van 't Hoff factor as that of K4FeCN6? Now this is giving you 4 plus 1. This complex ion is not going to dissociate. So Van 't Hoff factor will be 5 here. Van 't Hoff factor will be 5 here. Let's find who is having Van 't Hoff factor 5. 2 plus 3 ion 5. 1 plus 1 2. 1 plus 3 4. 2 plus 1 3. So only this is the solute which is having the same Van 't Hoff factor as K4FeCN6. Van 't Hoff factor calculation is very easier if you are taking salt, because for them you only have to find number of ions. For them you only have to find number of ions. Right? Yes. The next question is 25.3 gram of sodium carbonate, okay, is dissolved in enough water to make 250 ml of solution. If sodium carbonate dissociates completely, molar concentration of sodium ion and carbonate ion respectively is. See, you can solve this question in two ways. First of all, we know that sodium carbonate will give sodium and carbonate in 2:1. So the molar concentration should be in 2:1. sodium should be double of carbonate. This is not correct. This could be correct. This is not correct. This is not correct. Directly option B is our correct answer. Directly option B is our correct answer. Or alternatively, what could you do? First of all, find the molarity of sodium carbonate. Mass divided by molar mass and volume of solution. Whatever the concentration is coming, sodium will be twice of X, carbonate will be X, but we could find it without even solving, just by realizing that sodium carbonate is having cation anion ratio as 2:1. Cation anion ratio as 2:1. So only one option is correct here. Now this is called a smart solution. Okay. Moving to the next question. Azeotropic mixture of HCl and H2L. Now this is a factual question. Azeotropic mixture are constant boiling mixture. They cannot be separated any further. So they boil together, they condense together, and azeotropic mixture is formed by HCl when this is 20.2% in concentration. For nitric acid, it is approximately 68%. For ethanol, it is approximately 95%. Okay. So these information you have to memorize, that for HCl, this is 20.2%. For nitric acid, this is approximately 68%. For ethanol, it is approximately 95%. At these percentage of concentration, they form azeotropic mixture. Every non-ideal solution makes an azeotropic mixture. Okay, mole fraction can never be more than 1. A very simple question. Mole fraction is part of 1. Fraction is part of 1. That's why any mole fraction, mass fraction, volume fraction can never be more than 1. And it is a concentration, so it could never be negative as well. It actually some things you are going to remember by every time using it. See, whenever you are given with a nitric acid concentration question, even in NCERT chapter 1, every time they give you the concentration of 68%. Why this number is constantly hammered in your mind? So that it is memorized. Whenever you will see rectified spirit, you remember rectified spirit in organic chemistry, it is also 95% ethanol. Why every time for ethanol 95% is mentioned many times in NCERT? 68% for nitric acid is mentioned many times in NCERT. That is only because if they think some of the data is important, they are continuously providing you that data in the various sections. Okay? Okay, moving to the next question. Coolant used in car radiator is aqueous solution of ethylene glycol. No problem. In order to prevent the solution from freezing at minus 0.3 degrees Celsius, how much ethylene glycol must be added to 5 kg of water? So we can say that if we want to prevent the freezing at 0.3 minus, so this should be the freezing point. So the depression in freezing point will be 0.3. Ethylene glycol is non-electrolyte, so IKF molality. 0.3 is equal to Van't Hoff factor is 1, 1.86. Molality will be mass of ethylene glycol divided by molar mass. Ethylene glycol is CH2OH, CH2OH. Ethane 1,2-diol. So the molar mass will be 24 plus 2 to 4 to 6, 30 plus 32. So that will be 62. And the mass of solvent is 5. So mass will come as 0.3 into 62 into 5 divided by 1.86, let's say 1.8. That will give you 6. That will be 10. So the molar mass will be up to slightly more than 50. The answer will be between 50 to 55 gram. 50 to 55 gram. Yes. Okay. Let's see the next question. What is the degree of dissociation of sodium chloride if the molar mass determined by a cryoscopic method was found to be 31.80 gram per mole? Let's see. We know that Van't Hoff factor is equal to observed colligative properties divided by calculated colligative properties. Now observed colligative properties is inversely proportional to molar mass. So we have abnormal molar mass here and normal molar mass is for colligative properties. And colligative properties are inversely proportional to molar mass. So we mainly use two formulas of want of factor, one in terms of colligative property, another in terms of molar mass, SS champion, some question I have taken as a numerical type question. These type of question can come in MCQ type as well as numerical type. Numerical type question helps some of the JEE aspirant to know how to find answer accurately. For NEET, you can find the approximated answer and then you can select the given option. That's why in some of the question we are not providing options. Okay. Okay. Moving on to the next. Moving on to the further part. So the normal molar mass of NaCl is 58.5 and the abnormal mass is given as 31.8. Normal molar mass is 58.5 and the abnormal molar mass is given as 31.8. So that would give me 1.83. 1.83 as the Van 't Hoff factor. Now, we know that for weak, if we consider NaCl to be weak, I will be 1 plus n minus 1 alpha. Now n is 2, so I will be 1 plus alpha. I has been calculated 1.83. So the alpha will be 0.83, or in percentage we will have 83%. The observed degree of dissociation will be 83%. Correct? Yes. Moving to the next question, next part. A 0.002 molar aqueous solution of ionic compound freezes at this temperature. Number of moles of ions which 1 mole of ionic compound produce on being dissolving in water. See, this question have a little bit connection to chapter coordination compound, because we have to derive the formula for this. How we will derive it? See, we are given delta TF is equal to I multiplied by KF multiplied by molality. Now delta TF is 0.00732. Van 't Hoff factor we don't know, because we don't know the formula of complex salt, which part is ionized, which part is not ionized. KF is given as 1.86 and molality is given as 0.002. Right? Yes. So I will be 7.32 divided by 1.86 multiplied by 0.002 will become 2. I will move 3 decimal point here, and that's why this becomes 7.32. Now this is 4 times approximately, right? So I will be approximately 2. And I is what? I is equal to number of ions. Isn't that correct? If we want to make the formula now, we can make the formula. If it is producing 2 ions, that means it is having 1 complex ion and the remaining counter ion is outside the complex sphere. The formula of complex is such that it is producing only 2 ions. So the number of ions are produced is 2. It will produce a total of 2 ions upon dissolution in water. A total of 2 ions upon dissolution in water. Right. Moving on to the next question. A solution of urea boils at 100.18 and Kf and Kb are given. We have to calculate the temperature at which above solution will freeze. Okay. So we have delta Tb as 0.18 is equal to I Kb molality. Delta Tf we don't know. That will be equal to I Kf molality. Right? Divide both of them. Molality is not going to change because the solution is same. I is not going to change, and also for urea Van 't Hoff factor is 1. For urea Van 't Hoff factor is 1. So delta TF will be 0.18 multiplied by 1.86 divided by 0.512. That will be the delta TF. So delta TF will come out as 0.18, 1.86 divided by 0.512. So that will come approximately 0.19. So the freezing point of solution, considering water to be 0 degrees Celsius minus 0.19 degrees Celsius. That will be the freezing point of the given solution, minus 0.19 degrees Celsius. Moving on to the next question. Freezing point of an aqueous solution is this, minus 0.186. Kb, Kf values are given. We have to find the elevation of boiling point. Similar problem, just that the problem has been reversed. Earlier we had to find freezing point, now here we have to find boiling point. Yes. Okay. So similar type of, again we are going to divide both of them, boiling point divided by freezing point change. If solution is same, I and molality again will be same. So we will have Kb divided by Kf. Now delta Tb will be 0.52 multiplied by Kb, delta Tf that is 0.186 divided by Kf that is 1.86. So that will give you elevation in boiling point as 0.052 degrees Celsius or Kelvin. Degree Celsius or Kelvin. Temperature change is going to remain same whether we talk about Kelvin or degree Celsius. Okay. Moving ahead. Now we have another chapter of electrochemistry. This chapter is based on redox reaction. First of all, this is based on redox reaction. Here we have two sections. One is galvanic cell, which is the production of electrical energy from chemical energy, and another is electrolytic cell. The galvanic cell portion is completely based on Nernst equation. If you know the Nernst equation, you can apply it for half cell as well as for complete cell. By putting the value we get here is minus 0.0591, right? Log Q. RHS by LHS. Electrolytic cell is mainly based on Faraday laws. N factor multiplied by mole is equal to Q by F. This is the combined form of both Faraday law. First law and second law both can be derived from this equation. Yes. Okay, Itachi. Anode negative, cathode positive. It is true for galvanic cell. But if you want to know about anode, remember anode is the one where oxidation occurs. Whether it's galvanic cell, whether it's electrolytic cell, anode is the one where oxidation occurs and cathode is the one where reduction occurs all the time. Yes, we can take 0.06, no problem. We will take, while solving, you know how much approximation I do, right? During my JEE exam, I used to approximate a lot. Sometimes instead of 220, I used to take 100 to find the answer and make the calculation easier. So we will do some approximation, no worry about that. Yes. Okay. So mainly these are the sections that are going to be covered in electrochemistry. So we have first question, molar ionic conductivity of two bivalent electrolyte. If both are bivalent, that means both are having two positive, two negative charge. X and Y are 57 and 73 respectively. The molar conductivity formed by them will be. Now, whenever we talk about the molar conductivity of an electrolyte at infinite dilution, this is not mentioned, but we will use it, then it is equal to the summation of molar conductivity of their ions only. If there is some stoichiometry in molar conductivity, we always use stoichiometry. So we are directly given with the conductivity 57 and 73. So direct answer will be 130. 130 will be the molar conductivity of given solution. Molar conductivity of given electrolyte. Simple use of Colroche law. Colroche law is similar to Dalton's law of partial pressure, that when ions becomes infinitely diluted, they don't have any effect on each other, so we can directly add their conductivity. We can directly add their conductivity. Yes, Colroche law, but you have written the spelling wrong. It starts with K, as with my name. Okay. If the E naught cell for a given reaction has a negative value, which of the following gives the correct relationship for the values of delta G naught and equilibrium constant? Now we have E naught and delta G both related as delta G naught is equal to minus NF E naught cell. Basically, delta G naught is the maximum work that you can obtain from a cell. And equilibrium constant is E naught cell 0.0591 divided by N log K. You can relate equilibrium constant to delta G as well as you can relate equilibrium constant to E naught cell directly. Okay. Now, if E naught is negative, delta G is going to be positive. That's why remember all the time, positive potential means spontaneity, negative potential means the process requires some extra effort. Okay, nice. So delta G is going to be positive. Now, if E naught is negative, log K should be negative, and log K is negative when the inside of log is less than 1. Log K is negative when the inside of log is less than 1. So K is going to be less than 1. Option D is the correct answer. Some of you were writing option A, option B. Option D is the correct answer here. Right? Yes. Non-spontaneous, correct. So these are three conditions for non-spontaneity. E negative, delta G positive, as well as equilibrium constant less than 1. If equilibrium constant less than 1, then also you can say that process is non-spontaneous. Yes. Moving on to the next question. Standard electrode potential are this, this and this. If these blocks are put together, what is going to happen? First of all, understand how we are going to make reaction here. We are having iron plus 3 plus 2 and iron neutral both in the solution. From there you can see that iron plus 2 is common in both. So I will write an equation of iron 2 plus. Iron 2 plus getting converted into iron, okay, and iron 3 plus. Why I took iron 2 plus? Because it was common in both. Whenever you are wanting to make a reaction given from two given half cell, then take the one which is common in both of them. So this is oxidation, so this will be anode. This is reduction, so this will be cathode. So the E cell of this reaction will be E cathode minus E anode. Remembering this formula only is not enough. You always remember that every time you are going to put values in cathode minus anode, it should be reducing power. It should be reducing potential. So E naught cathode, iron 2 plus 2 iron in reduction format is minus 0.44. E naught anode, iron 3 2 reduction format is 0.77. So you can say that this is giving you a negative value. And now if negative, that means this reaction is going to be non-spontaneous. So if this reaction is non-spontaneous, reverse reaction is spontaneous. Reverse reaction will be spontaneous. In one direction, if there is non-spontaneity, opposite direction will be spontaneous. So now what is going to happen? Iron is going to consume, iron 3 plus is going to decrease, and iron 2 plus is going to increase. So option B is going to be the correct answer when all of them are kept together. Boogerman, whenever you have oxidation, anode is the one where oxidation is occurring all the time. In galvanic cell, in electrolytic cell, in any type of cell, oxidation point is called as anode, and cathode is the one where reduction is occurring. Cathode is the one where reduction is occurring. Moving on to the next question. Is this question clear to you all? Option B will be the correct answer. We will now move to the next question. Now this question is talking about an electrolytic cell which contains silver sulfate and has platinum electrode. A current is passed until 1.6 gram of oxygen has been liberated at anode. At anode means from oxidation. Oxygen will be liberated by oxidation of OH minus. The amount of silver deposit, they are already telling you in the question, almost all information are given which you think you have to memorize. Which you think you have to memorize, almost all information are given in a question. Silver is deposited, that means we are going to write the equation for silver. Now in a solution, current is going to be same, charge is going to be same. So I can directly say that N factor into mole, Faraday law, which is equal to Q by F. So Q by F is same, so N factor into mole will be same. That is, even during electrolysis, you can apply the law of equivalence. For oxygen, we are given with the amount of oxygen. The change in oxidation number is 2 and the atomicity is 2 also. Just focus whether you want to find the N factor of OH minus or O2. Both will have different N factor. For oxygen, both will have different N factor because atomicity is different. For silver, the N factor will be change in oxidation number of 1 and atomicity 1. So N factor of silver is 1. Mole of silver will be mass of silver divided by molar mass. N factor of oxygen is 4. N factor of oxygen is 4. You don't need to know first law, second law of Faraday. You can use the merge format of first law and second law. N factor into mole is all the time equal to Q by F. If you want to know the statement, first law says mass is directly proportional to charge, and second law says if charge is same, mass upon equivalent mass ratio remains same. Mass upon equivalent mass ratio remain same. No, there is no chance of postponement. Okay, so 4 into mole of oxygen. Oxygen is 1.6 divided by 32. So that will be 60 into 64, 0.2, right? So that will come as 21.6 gram. 21.6 gram of silver will be deposited. 21.6 gram of silver will be deposited. Yes, gram equivalent. Yes, the gram equivalent one is second law. The mass proportional to charge is first law, and the gram equivalent ratio are always equal if charge is same, that is second law. W by E is a constant. Moving to the next question. For the cell reaction, we are given with a cell reaction and we have to calculate delta G. See, we have Nernst equation in the terms of electrode potential. Also, you can use that equation as well. First find E cell. After E cell, you can find delta G. Or you can have Nernst equation in the form of delta G as well. From this, you find the equation of electrode potential by putting delta G is equal to minus NFE. So here we were talking about delta G is equal to delta G naught plus RT ln. On the right hand side, we will not use solid, only the ions, so C2 divided by, again on left hand side, no solid, only C1. So what is happening here, if you use the delta G version of Nernst equation, the question is solving in fewer steps. Less steps are required to solve the question. Now you can see that delta G is a function of ln C2 by C1. ln C2 by C1. Yes. Yes, we can take the concentration of ions only. The next question is gas X at 1 atmospheric is bubbled through a solution containing a mixture of 1 molar X, Y and Z ion. 1 molar, some data are misprinting. 1 molar X, Y and Z ions. X minus, Y minus, Z minus. If the reduction potential of Z, Y and X is this, let's see. We make a table in the increasing order of reduction potential. That means X will be on the top, Y and then Z. The increasing order of reduction potential is X, Y, Z. The below one, the one which is below forms cathode, has a tendency to reduce in electrochemical series. The one which is above has a tendency of oxidation, that is anode. Oxidation, that is anode. Okay. Now if X is passed through Y, X will oxidize, Y will reduce. X will oxidize. Okay, Y is passed. If Y is passed through X, Y will be reduced. So Y will oxidize X. That is correct. Y will oxidize S. But with Z, Y will be oxidized, Z will be reduced. So that is our correct answer. That in pair of Y and X, Y will be reduced and X will be oxidized. So I can say Y will oxidize X. But in pair of Y and Z, as Z is below, so Z is going to get reduced, not oxidized. So Y will oxidize X, not Z. Option A is the correct answer from electrochemical series. Right? Yes. The above one oxidation, the below one reduction. Very good. Correct. Correct. So the next question here is, for the electrochemical cell, we are given with the cell. In the cell representation, this double line represents salt bridge. The left side is anode and the right side is cathode. Right? The left side is anode and the right side is cathode. You no need to learn the electrochemical series. If you haven't learned the electrochemical series up to now, you don't need to learn it. Or you can find the mnemonics. But it's not required. Yes, Prashant. Yes, that is correct. Now we are going to have a cell reaction. Let's see. We are going to talk about this reaction only. M to M plus anode, X to X minus cathode. The cell reaction is, so we can find the cell potential. Cathode. Cathode means X pair. So X pair in the reduction format is 0.33. Minus anode 0.44 in the reduction pair. So that will be minus 0.11. So first of all, this is the reaction, but this is not spontaneous. If this is not spontaneous, reverse reaction will be spontaneous. So the given cell is non-spontaneous, but the reverse cell will be spontaneous. But the reverse cell will be spontaneous. Yes. And this is not correct because we could see that E cell is minus 0.11 volt, not 0.77. Correct? Every time you want to write anode, write oxidation. For cathode, write reduction. Okay. Now moving on to the next question. On the basis of following E0 values, the strongest oxidizing agent. See, the oxidizing agent is the one which is having tendency to reduce. It want to get reduced. And we have already established that if potential is positive, potential is more, it will be more spontaneous. So if it is wanting to reduce, it should have more SRP. It should have more standard reduction potential. More standard reduction potential. Now see here. This is oxidation. This is oxidation. How we found what is oxidation? If electron is on the product side, that means loss of electrons, so it is going to be oxidation. We will see minus 0.3. Instead of minus 0.3, we will consider 0.35 to be SRP. This is oxidation potential. Focus some here, have some focus here. This sign will make your answer incorrect because this is oxidizing potential. and this is your oxidizing, so the reduction potential will be 0.77. Now I can say that this Fe pair is the stronger oxidizing agent. The Fe pair is the stronger oxidizing agent, not FeCN6. Out of these pair, there are many points at which you can do mistake in this question. First of all, the given value is oxidizing, not reducing. We establish all the fact on reducing potential. We memorize all the point on reducing potential. So first we converted the potential into reducing one. Second thing, if in this pair, we found that this pair is having more oxidizing power, right? But out of this pair, Fe is not the answer. Fe is oxidizing, so Fe2 plus will be the reducing agent. Fe3 plus will be the oxidizing agent which is getting reduced. So as the option has both, we cannot mark Fe2 plus as the answer because this is not going to act as oxidizing agent. This is going to oxidize, so it will act as a reducing agent. Fe3 plus, this will be our answer. This is the second point in this question where you could make a mistake. It achieves, look here, electron, the position of electron, look for the position of electron. If electron is on the right side, that means loss of electron. So for loss of electron, the process will be oxidation. For loss of electron, the potential will be oxidation. Thanks, Prashant. I'm just doing what I like to do. Still, yes, okay. The variation of molar conductance of a strong electrolyte with concentration to the power half. Many of you have seen this graph in NCERT, and you can remember, for a strong electrolyte we have an equation of molar conductance which is called as Debye-Huckel on-Sager equation. Debye-Huckel on-Sager equation, which is del M is equal to limiting molar conductivity minus A under root C. So the graph of del M versus under root of concentration is a straight line having the intercept as limiting molar conductivity, and this constant depend on the nature of salt. Option A is the correct graph, and this is the equation for that graph. Yes. Moving on to the next question now. A device that converts energy of combustion of fuel like hydrogen, methane directly into electrical energy. This is a definition of fuel cell. This is the definition of fuel cell. In fuel cell, you have a direct conversion of combustion of fuel into electrical energy. Even in the rockets or spacecraft, they use hydrogen fuel cell. It serves two purposes. First of all, it provides electrical energy. Second, it also provides water as the product which can be used for drinking. Which could be used for drinking. Yes, Rituraj. For weak electrolyte, we don't have a proper graph. In this scenario, for weak electrolyte, we don't have a proper graph. Because for weak electrolyte, we have alpha varying with equilibrium. Alpha is varying with equilibrium and concentration. So for weak electrolyte, we have a curved graph here. For weak electrolyte, we have a curved graph here, not a proper shaped graph. That's why for weak electrolyte, we have to use Collo's law. Because for weak electrolyte, we cannot predict where it will cut the y-axis. Where it will cut the y-axis. Okay. Moving to the next question. In a hydrogen-oxygen fuel cell, combustion of hydrogen occurs to. This is the main purpose of fuel cell. It is a side reaction that water will be produced, but it will not be highly pure. So this is the main purpose of a fuel cell combustion, that it will produce electrical energy or electrical potential. Option B is going to be our correct answer. Option B is going to be our correct answer. Okay. Now moving to the next question. A hydrogen gas electrode is made by dipping platinum wire in a solution of pH 10. We have to find the oxidizing potential. You all must have known that standard hydrogen electrode is a reference electrode. Standard hydrogen electrode is a reference electrode, and if pressure of hydrogen is not mentioned or given as 1, either it is not mentioned in the question, not asked in the question, or given as 1. Here you can say that pressure is given as 1. You can directly use the formula oxidizing potential, that will save your time. 0.0591 multiplied by pH of solution. The reducing potential will be same but with negative sign. Reducing potential will be same but with negative sign. So here oxidizing potential will be 0.0591 into 10, that is 0.59 volt. 0.59 volt, option A will be the correct answer. Here option A will be the correct answer. Okay. Moving ahead. Aqueous solution of which of the following compound is the best conductor of electric current? Acetic acid, hydrochloric, ammonia, fructose. First of all, conductivity depends on many factors like concentration, number of ions, because more ions will have more conductivity. Mobility of those ions. Smaller ion will move faster, bigger ion will move slower. So the conductivity depends on both of the factor, but if all of other electrolyte are weak electrolyte, we can directly say a strong electrolyte will produce more ion, so that will definitely have more conductivity. If we had more than one strong electrolyte, then you have to check for mobility. The bigger the size of the hydrated ion, smaller is the mobility. Smaller is the mobility. Yes. Now this question, standard free energy of formation of H2O, CO2 and pentane is given. The value of E naught cell for pentane oxygen cell. Fusion of thermodynamics and electrochemistry. Pentane is C5H12 plus oxygen gives 5 CO2 plus 6 H2. 5 to 10 plus 6, 18. That means 9 O2. So now the delta G will be 5 times of delta G of CO2 formation. CO2 formation is 8.2 minus 8.2 plus 6 times of delta G formation of H2O. For H2O it is minus 394.4 minus 1 times of pentane. For pentane it is minus 273.2 and for oxygen it will be 0. For oxygen it will be 0. Now it is your work to solve this and tell me the value of delta G naught. Till then I am going to tell you another concept. Okay? Till then I am going to tell you another concept. The another concept is students find it difficult to find the number of electrons. Why? Because once we have calculated delta G naught, we are going to get minus NFE cell. In order to find E naught cell, this is the main obstacle. How to find this number of electron? How to find this number of electron? So in order to find the number of electron, what we do? You take any of them. Like this, 0, minus 2. Any redox change, reduction, oxidation, any change, which you find simpler to calculate. So for oxygen, we are going to have 2 electrons or 2 change in oxidation number. How many oxygen atoms are here? 18. So total electrons involved will be 18 into 2, that is 36. A easier way to find number of electron, look for change in oxidation number of any one that you can find easy, and then you can use total number of atoms multiplied by oxidation number change. So the number of electron here will be the delta G that you have calculated divided by number of electron will be 36 and Faraday constant. And the Faraday constant. So you are going to solve this question because we have already done many questions like this in thermodynamics. Yes, electron exchange. But sometimes like in this question, students find it hard to calculate total number of electrons involved in the reaction. Because this is a hydrocarbon, some will find it's difficult to calculate oxidation number here. Okay, right. Moving on to the next question now. When electric current is passed through acidified water, 112 ml of hydrogen gas at STP is collected in 965 seconds. Find the current passed in ampere. So we can say that acidified water, hydrogen gas. Acidified water, hydrogen gas. If your battery is going to be dead, charge it, recharge it. Actually, the dedication, the passion to have something is very rare in students. I should not say that, but this is the sad reality of today's time, that dedication is something, patience is something that we don't find in newer generation. Every new generation seems to have lacking the dedication, the passion, the fire inside them. So they try to find some easy way out. Okay, now see, if we are talking about hydrogen gas, we are going to find n factor for hydrogen, not for H plus ion. I am telling you again and again this, that look for that molecule for or ion for which you are going to calculate. Here we are going to calculate for hydrogen gas, so we are going to find the n factor of hydrogen gas, not H plus ion. Atomicity is 2 and change in oxidation number is 1. Now Faraday law, n factor into mole. Instead of mole we will use volume of gas divided by STP volume, that is 22.4 liter or 22,400 milliliter, right? Right, yes. Is equal to I, current we have to find. Time is 965 seconds divided by 96500. So that will be 200. Everything will be cancelled out. Current will come as 1 ampere. 1 ampere of current has been passed. Yes. 1 ampere is the correct answer here. Okay, right. Moving on to the next question. Consider the following cell reaction. Okay, we are given with a cell reaction. Everything is given to us and we have to calculate cell potential. Just apply the next equation. See, reaction given, E naught cell given, concentration, pressure, pH given, everything is given. Just apply the next equation. Yes, Bhuvan? Okay, so E cell is E naught cell 1.67 minus 0.06 divided by N. Number of electrons, again the same method for number of electrons. See, for iron 0 to plus 2, N should be 4. Could you find it? N should be 4. Log concentration of iron, that is given to us as 10 to the power minus 3 square 10 to the power minus 6 after squaring. H2O will not be here. Divided by pressure of oxygen, that is 0.1. Multiplied by concentration of H plus, so pH is 3. H plus will be 10 to the power minus 3 and the square will give you 10 to the power minus 12. So E cell will be 1.67 minus 0.06 by 4 multiplied by 10 to the power minus 13, right? Minus 1, minus 12, minus 13. Cell notation. Yes, I will tell you. 10 to the power minus 13 will go above, 10 to the power plus 13 minus 6, 10 to the power 7, and 10 will be there and 7 will come outside. So that will be 1.67 minus 0.42 divided by 4. So that will be approximately 0.1. The cell potential will be approximately 1.57. The cell potential will be approximately 1.57. Yes. Cell notation. What do you want to know about the cell notation? In the cell notation, we have anode. And the only thing compulsory for anode is that you write electrode first and then you can write anything. Then you can write anything in any order, increasing order of oxidation number, decreasing order of, everything is correct for anodic representation if you have electrode on the first. And if you have electrode on the first, you are going to write the oxidation reaction. You are going to write the oxidation reaction no matter what the sequence is given. Yes. And for cathode, you can write it any order, but the electrode should come in the last. The solid electrode should come in the last, and the cell reaction, anode is written on the left side and cathode is written on the right side. See, I am going to mention 3 chapters for Pranav. One is biomolecules, polymer, chemistry in everyday life, and one more chapter, environmental chemistry. These are the 4 chapters from which you can be sure to get a question. Because everyone knows students avoid this chapter. Even some teacher avoid this chapter. So examiner make sure that questions come from this chapter. No, Bhuvan, it is not necessary. I am not that good. Okay. See, my duty, responsibility here is to give you a best content or best information that I can give you. Your responsibility is to at least think of your parents and at least do what you are telling them to do. If you are telling them that you are going to crack IIT, you are going to crack NEET, you are going to become a doctor, at least think of their dream. Their dream is more important than your, mine, or anyone else. Right? Because they have done so many hard work. Everyone has some parent or grandparent who have gone through lots of struggle to put you where you are right now. To put you where you are right now. So at least all the time, it should be in the back of your mind that how much struggle your parents have done to give you all the facility that you required. Yes. Let's see the next question. Okay, now we are moving to the next chapter, chemical kinetics. Good. Only that is required. You should put your full effort. Only that much is required. After that, result doesn't matter. If you are satisfied with your effort, then result doesn't matter. Okay, now I'm going to move forward with the chemical kinetics chapter. Are you guys ready? This is the second last chapter. After that, we will have surface chemistry and all of them. Okay. In chemical kinetics, if I am to talk about, we have 3 types of rate law. First of all, suppose we have an equation where A and B are reacting to give you C and D. Where A and B are reacting to give you C and D, right? Yes, Itachi, tell me your doubt. So we can relate their individual rate. Rate of reaction is equal to rate of disappearance of A divided by coefficient of A, rate of disappearance of B divided by coefficient of B, rate of appearance of C divided by coefficient of C, and rate of appearance of D divided by coefficient of D. So you can relate individual rate with rate of reaction. We call it the differential rate law. We call this law as differential rate law. Okay? And rate of any appearance or disappearance can be written as minus or plus d by dt of concentration. For reactant, we will always use the minus sign. For product, we will always use the plus sign. For plus, we will always use the plus sign for product, minus sign for reactant. This is your first rate law, differential rate law. The second rate law is called as normal rate law, which is k times of a to the power x, b to the power y, and here x and y are not equal to p and q unless you know this is elementary reaction. Which ones? For equilibrium, minimum concentration before reverse flow of electron. Just make at equilibrium delta G and E cell as 0 and you will get the value. That is the minimum concentration that you get at equilibrium. Because after that, equilibrium condition will be exceeded and the reaction will start going in the backward direction. So for equilibrium, always the condition is E naught cell or delta G, E cell or delta G is 0. Okay. Now this second rate law is normal rate law which use the order X and Y and they are determined experimentally. The third rate law is called as integrated rate law. And this is derived for all the order of reactions separately. For zero order, A naught minus AT is equal to KT, where A is the reactant. For first order, KT is equal to 2.303 log A naught by AT. And for second order, you don't need it much, but these are much required. Now, while doing the question, you can know from the question language itself that which rate law is to be used. If the question want you to relate the individual rates, use differential rate law. Rate versus concentration relation, this rate law. Concentration versus time relation, this one. So according to the requirement of the question, you are going to use the rate law. Okay? Yes, you have to just equate E cell to 0. So according to the requirement of question, you have to use the rate law. Let's see the question of this chapter. The rate constant for the reaction is given, concentration is given, and the concentration of B after 20 minutes is. First of all, look for the unit of rate constant. Mole per liter to the power 1 minus n, second to the power minus 1. This is the common unit, general unit of rate constant. If you compare this unit, you can see that order of reaction is 0. We can find the order of reaction by finding the unit of rate constant. By finding the unit of rate constant. Okay? Yes. Now we are given with rate constant, we are given with the concentration of B. So we can find the concentration of product, that is equal to KT. So K is 0.6 into 10 to the power minus 3. T is 20 minutes. So that will be this 0, this 0. This will become 10 to the power minus 6 to 12. 12 into 6, 72 into 10 to the power minus 2. That will be 0.72 moles per liter. 0.72 moles per liter. Now I guess many of you haven't seen this relation. For zero order, we have all the time seen the relation for concentration of reactant, but we also have the relation for concentration of product as well. Bt is equal to Kt. At any time, the concentration of product is equal to K times of T. What you can do in the other method, first of all, you find the concentration of A. A naught is given. You find this AT from the rate law. When you will find the AT, using this AT you can find X, and using this X you can find this X. That means you can find the concentration of product even from the reactant side. Even from the reactant side. Okay? But this is simpler way and the quicker way to find the concentration of product in a zero order reaction at any time T is equal to KT. Moving to the next question. Are radioactive elements get expelled? Radioactivity is always first order reaction. So a radioactive element get spilled over the floor of a room. Its half-life period is 30 days. If the initial amount is 10 times the permissible value, after how many days it will be safe to enter the room? It will be safe to enter the room. See, for first order they are talking about, so we are going to use first order law. Kt is equal to 2.3 log. Initial value is 10 times the permissible value and the final value should be permissible value. Only then we can enter the room, right? Let's say the permissible value is X. Now, whenever you have half-life, instead of finding K, this is another alternative. Instead of finding K, write the same expression for half-life. That means if you have taken 100, 50 has been consumed, 50 has been left out, and divide both of them. So T will be, half-life is 30 days, log 10 will be 1 divided by 0.3, so that will be 100 days. After 100 days, it will be permissible or it will be good to enter that room. Option A is the correct answer, not option B. Option A is the correct answer here. A simple question, still you could make mistake here. Now this is a very basic question, but still we will find it. Let's see. We are given with the reaction, a rate with the concentration, and have to find the order. First of all, what you do, find set where only one thing is changing, another is constant. Let's see. This one, this. Okay? And another set. Okay, this two, and this. From here you can see that when concentration of A is doubled, the rate of reaction has become 4 times. So if concentration of A is having the power x, the rate should become 2 to the power x. So order with respect to A is 2. This is our answer. Now, in this case, this can be written as 10 into 10 to the power minus 3. 10 into 10 to the power minus 3 can be written as. Now, in this case, A is constant, B is constant. I think this is misprinted because for C it should be 0, right? For C it should be 0, so it is misprinted. For C it is 0. Now, take these two values. When B has been doubled, the rate is unaffected, so order with respect to B is 0. So I think there is some misprinting, but the order with respect to A is 2, order with respect to B is 0, and order with respect to C is also 0. Okay? We will solve this type of question further. In the previous question, there was some misprinting in the data, so we'll solve this question further. In a reversible reaction, the energy of activation for the forward reaction is 50 kilojoule. The energy of reaction for the reverse reaction will be. See, we are not given with the type of reaction. So if we look for two type of reaction, one in which reactant is at the higher energy level than product, and the another is which reactant is at the lower energy level than the product. Product is higher, that means endothermic. Reactant is higher, that means exothermic. Now this is activation energy of forward direction from reactant to product. This is activation energy of backward direction from product to reactant. Right? Similarly, here this is the reaction of activation of forward from reactant to product, and this is of backward from product to reactant. As you can see that if energy type is not mentioned, it is not mentioned whether it's exo or endo. For exo, we can say that backward activation is more than forward. For endo, forward activation is more than backward. But if the type of energy, type of reaction is not given, we cannot predict. It could be either greater than or less than 50 kilocalorie. Right? It is not mentioned here. Whether the reaction is exo or endo, so both could be correct. Let's see our next question. Half-life period of a first order reaction is 1386. The specific rate constant, just you have to solve using the formula. Rate constant of first order reaction is 0.693 divided by half-life. Right? No, Kittu, right now I'm not in Noida. So 0.693 divided by 1386. So that will be 1 by 2 multiplied by 10 to the power minus 3 or 5 into 10 to the power minus 4 second inverse. 5 into 10 to the power minus 4 or 0.5 into 10 to the power minus 3. Option B is the correct answer for rate constant. Option B is the correct answer for rate constant. Okay, right. Moving on to the next question. T 1 by 4 can be taken as the time taken for the concentration of reactant to drop to 3/4 of its initial value. And rate constant for first order reaction is K, then T 1 by 4 can be. T 1 by 4 can be. Now, either you can use this equation, K into T 1 by 4 is equal to 2.3 log. Drop to 3 by 4 means if we have taken 100 as initial, it will be left as 75. 3/4 will be remaining, 1/4 will be consumed. That is 25% life is being talked about, right? We can solve this and find the value of 25% life. This is nothing but 25% life. Or you can use another trick here. In first order reaction, the reaction becomes slower as the reaction proceeds. Why? Because the concentration is decreasing and rate is directly proportional to concentration. So the reaction will become slower as the reaction proceeds. That means for a first order reaction, we know that half-life is 0.693 by K. So if this is the 25% life, so in the first part, the reaction will be faster. And the second part, the reaction will be slower. That is, if this is half-life, so in the first part, the value will be more than half of half-life because the reaction is faster, so time will be less. And the second part, the time will be more than half of half-life. Time will be more than half of half-life. So in the second part, the time will be more than 0.3, and the first part, the time will be less than 0.3. Only one option is such that, which is 0.29 by K. So there are two methods to solve this question. You can solve it by solving the expression completely or analyze it. Remember, you are giving a paper based on science, and science is about logic. So if you are developing a logical ability, an analytical ability, some of the questions are going to be solved at the much easier way. Okay? Moving to next question now. Mr. H, organic has been already taken, right? Organic has been already done. Consider a reaction G plus H gives product. When concentration of both is doubled, the rate increased by 8 times. Let's say order with respect to G is X, order with respect to H is Y. So when both are doubled, rate has become 8 times, right? And when concentration of G is doubled, keeping H constant, the rate is doubled. So from here, X plus Y will be 3 if we compare power on both sides. And from here, X will be 1. So X is 1, Y is 2, the total order is 3. The total order is X plus Y, which is 3. This type of question does not require to make rate law or do anything. You can directly solve. If order is X, any change in concentration will have change to the power X effect on rate. If you make the concentration tripled, rate will become 3 to the power X if the order is X. If you make the concentration 5 times, rate is going to become 5 to the power X. So consider the order to be X and Y, and you can see the effect of change on the rate directly. Okay? Now moving on to the next question. The rate law for a reaction is given on doubling the concentration of A, that is 2 to the power n, and half the concentration of B, that is 1 by 2 to the power n. The ratio of new rate will be 2 to the power n minus m. See how easily we could find this by knowing the simple fact. 2 to the power n minus m will be the ratio of new rate to the previous rate. Bhuvan, we will discuss about this sometime later. This is not the right time or place to discuss this. Come and meet me, we will discuss it. The rate constant K1 and K2 for two different reactions are this and this one. Okay, no problem. The temperature at which both are equal. A direct question, condition is given, just have to use Arrhenius equation. So Arrhenius equation K is A e to the power minus EA by RT, right? And we are given K1 and K2 both. Just equate them. 10 to the power 16 e to the power minus 2000 by T is equal to, if both K1, K2 are equal, 10 to the power 15 e to the power minus 1000 by T. Here by divide sign is missing. So this will give you 10 e to the power 2000 minus 1000, that will be 1000 by T. Apply ln on both sides. And ln 10 will be 2.3 log 10. So temperature will come as 1000 divided by 2.303. 1000 divided by 2.303. Okay? Yes, 1000 divided by 2.303. Option D is our correct answer. Option D is our correct answer. Moving on to the next question. Yes. For the reaction A plus B product, it is observed that, again a question on that. I think we have already done. Doubling the concentration, double the rate. So order with respect to A is 1. Doubling both, increase by 8. 8 means 2 to the power 3. So X plus Y should be 3. So with respect to A, the order is 1. With respect to B, the order is 2. This is the rate law. See, these type of question becomes very easier if you understand the rate law. Right? Okay. Moving on to the further. We have to consider this relation and find the relationship between ammonia and hydrogen. See, if you want to solve this question for the first time, suppose you are solving this question or studying chemical kinetics for the first time, can you see that in this question, two different rates are being talked about? And if two different rates are being talked about, we have one relation which relates them. This is nothing but rate of appearance of ammonia. This is nothing but rate of disappearance of hydrogen. So both of the rates can be related by differential rate law. Rate of hydrogen divided by 3 is equal to rate of ammonia divided by 2. So rate of ammonia will be minus 2 by 3 of rate of hydrogen. That is correct. So obviously this is not correct. Option A is our correct answer. Option A is our correct answer. Right? Okay. Let's see this question. The question says, for the first order reaction, the initial pressure is 80 torr and the total pressure at the end of 20 minutes is 122. Calculate the time required for 75% decomposition. See how we will solve this. We are given with the reaction. Let's call this A gives B plus C. A gives B plus C. A, B and C. Okay. The initial pressure is 80 torr. 80 torr 0, 0. That is initial. That I was talking about in equilibrium chapter, that you can solve every question if you can analyze the reaction. Yes, in kinetics, there are not many difference in NEET and JEE level, because for NEET level, the kinetics become automatically tougher because it is math oriented chapter. For JEE level, again, if it is of JEE advanced, they can involve high order integration, differentiation, or even differential equation. But JEE mains and NEET is quite similar. Kalyan, inorganic is more scoring than physical, generally for students. For me, both were equally non-scoring. After 20 minutes, this becomes 80 minus x, x, x. And whenever the question is giving you pressure, if it is not mentioned, this is always total pressure. So we are given with 80 plus x is 120. X will be 40. So this is 40, 40 and 40. Now, we could find K using this relation that Kt is equal to 2.303 log initial by final pressure. But here the question becomes easier. As you can see that here half is being decomposing. The pressure is reducing to just half. That means this is given as half line. This 20 minute is half-life. And for first order, you must have knowing that 75% life is double of half-life. If this was not the case, we could still solve the question. First of all, we will find K. How? Kt is equal to 2.303 log 80 by 40. And then we will find the 75% life. But this half thing has made the question easier. This half thing has made the question easier. That T half is twice of half-life. So half-life is 20. 75% time will be 40 minutes. 75% time will be 40 minutes. Is that clear to you all? Okay. Now moving to the next question. The half-life period for catalytic decomposition of AB3 at 50 mm of Hg is 4 hours and at 100 mm of Hg is 2 hours. Find the order of reaction. Now these questions are called half-life method to find order. Half-life method to find order. Okay. So see here. Half-life is dependent to initial concentration of pressure to the power n minus 1. So we can write T1 by T2 in terms of pressure, initial pressure by initial pressure to the power n minus 1. Now half-life is 4 hours. At 4 hours the pressure is 50 and half-life is 2 hours. At 2 hours the pressure is 100. You have to cross the half-life and initial concentration. If half-life in the numerator, that corresponding concentration will be in denominator. Okay? Yes. So we will have 2 is equal to 2 to the power n minus 1. That means comparing the power n minus 1 is 1, and many students during exam pressure, what they do? They cancel n by 1 by 1 and say the order is 0. Due to exam pressure, they do this mistake. But here n will be 1 plus 1, that is 2. So the reaction is of second order. The reaction is of second order. Let's move ahead. The energy of activation for forward and reverse reaction. I'm just going to make a graph. For forward it is 180. Whenever you are having this type of question, a graph is very convenient. For backward it is 200. The presence of catalyst lower the activation energy of both. Okay, no problem. The presence of catalyst lower both side activation by 100. The enthalpy change. Now see, enthalpy change is product minus reactant. Enthalpy is a state function. Catalyst only changes the path. So the presence of catalyst is never going to change your enthalpy. That is, enthalpy will still be forward activation minus backward activation. All the time you can find enthalpy change by activation energy forward minus backward. Whether catalyst has used, because catalyst will decrease or increase both by the equal amount. Okay, so forward activation energy is 180. Reverse is 200. So that is easily minus 20 kilojoule per mole. That is our activation energy. Sorry, that is our enthalpy of reaction for the given exothermic reaction. We could find that this reaction is exothermic. That enthalpy change is going to be in presence of catalyst as well as in absence of catalyst as well. Okay. Let's move to the further question. For the reaction, we are given with a reaction 2N2O5, 4NO2 plus O2. Rate and rate constant are this and this. We have to find the concentration of N2O5. See, we are given rate and have to find concentration. Rate and concentration are related by rate law. And for rate law, we need to know the order. For rate law, we need to know the order. Find order from here, not from here. This will give you order, the unit of rate constant. This says the reaction is first order, right? Second inverse is the unit of rate constant for first order reaction. That means rate will be equal to K times of concentration of N2O5 to the power 1. Concentration of N2O5 to the power 1. So from here, concentration of N2O5 will come as, now the question is easy. Once you find the order of reaction, the question is very easy. Rate of reaction, let's write it 10.2 multiply by 10 to the power minus 5. Whenever you are dividing, it is better to make the power equal. Okay? Divided by 3.4 multiplied by 10 to the power minus 5. That will be cancelled out. 3 times 3. I think this is approximately 3 molar. 3 molar is the concentration of N2O5 at that time. 3 moles per liter. 3 moles per liter. The next question, the decomposition of a substance follows first order kinetics. Its concentration is reduced to 1/8 of its initial value, is 24 minutes. We have to find the rate constant. See, again this question is talking about concentration and time. Whenever the question is talking about concentration and time, we are going to use integrated rate law. We are going to use integrated rate law, that is K multiplied by time is equal to 2.3 log, if initial concentration is 1, final is 1/8. The initial concentration is reduced to 1/8, 1 by 8. So from here K will be 2.3 divided by 24 multiplied by 3 log 2. 3 log 2, because 8 will become 2 to the power 3. Or if we consider this to be, let me make the calculation easier for you. Consider this to be 2.4. 0.1 into 3 into 0.3. So K will be 0.09 minute inverse. K will be close to 0.09 minute inverse. Which question you want me to explain it once again? If you want the previous question, in the previous question we were given with rate and rate constant, and whenever you are given with rate constant, you have to find order from that unit. Second inverse unit represents first order reaction. For first order reaction, you can directly write the rate law. After that, R and K both were given. So if R and K both were given, we could find the concentration of N2O5 that the question is asking. So the concentration of N2O5 will be rate divided by K. Rate divided by K. In this question, we use the first order rate law. Kt is equal to 2.3 log initial by final concentration. If initial concentration is 1, final is 1/8 of the initial concentration. Final is 1/8 of the initial concentration. Okay. Now we are going to move to the chapter surface chemistry. The last chapter of today's session. Have some water. Till then I will also drink some water and we will start it now. Till then, if you have any doubts in the kinetics chapter or any other chapter, you can ask it. Okay. So now we are going to start our chapter surface chemistry. Surface chemistry is the one chapter which you can use to solve. You can score more because this chapter has very easier question. And the chapter which is simpler, the chapter which is not involving much complication is always scoring one. That's why they say you that chemistry is your rank booster subject. Physics, biology, maths, they can have some complication at some time. But every year you can have history at any time. Every year, chemistry is the one subject that will save your rank. Yes, I had my dinner. This is my dinner. Okay, the next question, I am going to eat all the questions. Nothing better than that. Which of the following electrolyte is least effective in coagulating ferric hydroxide solution? Lecture notes will be on PW app. So all the metal hydroxide are forming positively charged colloid. The metal and metal sulfide the metal and metal sulfide, they usually form negatively charged colloid. And for coagulation, you have to know the Hardy-Schulze rule. What is the Hardy-Schulze rule? Hardy-Schulze rule says that whenever you want to coagulate, you have to neutralize the solution. You have to neutralize the colloidal particle. So every time we are going to require opposite charge valency. For positive, we require negative. For negative, we require positive. And the valency is higher, so the coagulating power will be higher. Let's see. Ferric hydroxide is a positive sol. So we have to look for the negative ion. Bromine, sulfate, chromate, and ferrocyanide. These are the negative ion. Out of these ions, ferrocyanide is having the highest valency. So that will be the most effective. We have to find most, no, we have to find least. So that will be most effective for coagulation of positive sol, and Br minus will be least effective for the coagulation of positive sol. Yes, positive coagulate negative, negative coagulate positive. Very good. Yes. Okay. Moving to the next question now. One desire to prepare a positively charged sol of silver iodide. This can be achieved by, we have to tell how much we have to make silver and iodide. So silver iodide sol will have colloidal particle of silver. Now the charge theory says that charge appear on colloidal particle by preferential adsorption. By preferential adsorption, charge appears on a colloidal particle. What is the meaning of preferential adsorption? That AgI will have a tendency to absorb either Ag plus or I minus. If we want to make a positively charged colloid, we should have excess Ag plus so that it can be absorbed. If we want to make a negatively charged colloid, we have to use excess iodide minus so that iodide minus can be absorbed. So we should have more amount of AgNO3. This is incorrect. First option will give you negatively charged colloid. Those who are saying first is the correct answer, first option will give you negatively charged colloid. A small amount of Ki to excess AgNO3, that will give you positively charged colloid. Option B is the correct answer, not option A. Option B is the correct answer. Remember, the preferential adsorption means when whatever the ions are constituting the colloidal particle will be absorbed preferentially. That is, it has a tendency to absorb either Ag plus or I minus. Yes. Moving to the next question. Freundlich equation for adsorption isotherm. So Freundlich graph is x by m is equal to kp to the power 1 by n. X by m is equal to kp to the power 1 by n, where 1 by n is in between 0 to 1. 1 by n is in between 0 to 1. So log x by m will be equal to log k plus 1 by n log p. This is the Freundlich isotherm equation which represents three phases. First is linear dependence, second is less than 1 dependence, and third is saturation state. So log x by m is equal to this one. This is the correct equation for Freundlich isotherm. Option B is our answer. Yes, option B is the answer. Okay. The size of colloidal particle is of the order. What is the order of size of colloidal particle? 1 nanometer to 1000 nanometer. So that will be 10 to the power minus 3 micrometer, because nano and micro are differed by 1000 to 1 micrometer. This is the size of colloidal particle. So this should be less than 1 micrometer. Colloidal particle have size less than 1 micrometer and greater than 0.001 micrometer. Less than 1 and greater than 0.001 micrometer. Right? Option C is the answer. Which of the following constitute irreversible colloid in water as a dispersion medium? So now this is a factual question. Irreversible means lyophobic. As lyophilic are easier to prepare, we can simply prepare lyophilic by shaking it with the dispersion medium. So lyophilic are easier to prepare. Lyophobic, once coagulated, cannot be reversed. That's why lyophobic are called as irreversible colloid. And mostly inorganic salt are lyophobic. Platinum inorganic lyophobic, ferric hydroxide inorganic lyophobic, clay inorganic lyophobic. So all of these are irreversible colloid. All of these are irreversible colloid. Option D will be the answer here. Yes, very good. I think surface chemistry question can be solved in 5 to 10 seconds, and that is the beauty of this chapter. That's why this is going to increase your rank. This is going to save your time. So this will work in a two-way. First of all, it will give you +4, as well as it will give you time to solve other question. Okay. Position of non-polar and polar part in mishell. So in the mishell, if this is an oil droplet, the non-polar part goes inside the mishell. This is a 10th level question. And the polar part remain outside the mishell so that the polar part can interact with water. Polar dissolves polar. So if you want to form a mishell in water, you have to have polar part outside. So in the mishell, we have polar at the outer surface and non-polar at the inner surface. Polar at the outer surface and non-polar at the inner surface. Yes. The cause of Brownian motion. Why Brownian motion? Brownian motion is what? The zigzag motion of colloidal particles. Now, why this zigzag motion occurs? Why this zigzag motion occurs? Because of the collision of colloidal particle with the dispersion medium. Because of the collision of colloidal particle with the dispersion medium, due to that collision, they are shifted in the random direction, and that's why we have zigzag motion. That's why we have zigzag motion. Option C is our answer. Option C is our answer. Yes, this is last chapter, so this is going to be over. Bhuvan, no, right now I am not doing 10th. I am not teaching for 10th right now. But we have done all that. Which of the following curve is in accordance with Freundlich isotherm? So we have already derived the equation previously. Log x by m is equal to log k plus 1 by n log p. So that means a straight line with positive intercept and positive slope. Log x by m versus log p, a straight line with positive intercept and positive slope. Right? Option C is the answer here. Option C is the answer here. Okay? Moving to the next question now. A colloidal solution is subjected to an electric field. The particle moves towards anode. Come on, tell me the charge on colloidal particle. Tell me the charge of colloidal particle. The charge on colloidal particle here. Palak, this is last chapter of today's discussion, which is surface chemistry. What is the charge on colloidal particle here? Yes, the battery is good. Yes, C is correct. I am asking the charge of colloidal particle. Yes. Whenever you have anode, so always remember anion. Anode word is given from anion. Anion move towards anode and cation move towards cathode. So if the particles are moving towards anion, anode, they are going to be negatively charged. So +3 will coagulate them effectively, then +2, then +1. This will be their effective coagulating power. Okay. Moving to the next question now. Which of the following is most effective in causing the coagulation of ferric? Okay, we have done this. The most effective will be this one, right? Already done this. Ferric hydroxide is a positively charged salt. Ferric hydroxide is a positively charged salt. Okay, you are still there. Whether JEE will get postponed or no. Okay, moving to the next question. Alum helps in purifying water. The formula of alum is K2SO4 dot Al2SO4 whole thrice dot 24H2O. This is the formula of alum, right? Now, if alum is used to purify that water, what does the alum do? This produces so many ions, positively charged, negatively charged, and all of these ions helps in coagulating the mud particle. The dust particle are coagulated, and by that alum purifies the water. So the action of alum is by coagulating the mud particles. Which is not correct regarding the absorption of gas on surface of solid. So the gas adsorption on the solid surface is mainly physiosorption. Now let's see what is not correct for physiosorption. On increasing temperature, adsorption increases continuously. The first option is not correct. For increase in temperature, it is going to provide more energy to the binded gas particle. The particle which is bonded to surface is going to have kinetic energy. As a result, whenever you increase the temperature, particles tend to move away from the surface, and that will result in decrease of adsorption. Rest all are correct for gas. Enthalpy and entropy chains are negative. Some gases which are more easily liquefiable can be more adsorbed, and all are correct. So option A is the correct answer here. Yes. Let's see what is our next question. Okay. For adsorption of a gas on solid, the plot of log x by m versus log p is linear with the slope. We have seen this equation third time. Slope is 1 by n. Freundlich isotherm is used for any physisorption. For any type of physisorption, you can use Freundlich isotherm. So log x by m is equal to log k plus 1 by n log p. Yes, Rahul, I have already said that 2 or 3 hours before. This is applicable. Okay. Moving to the next question. Which of the following will show Tyndall effect? Tyndall effect is what? Bending or deviation or scattering of light by colloidal particle. So Tyndall effect is shown by colloidal particle. Now what is CMC? CMC is used for associated colloid. All the associated colloid, soap, detergent, surfactant, all are normally behaving as a true solution below a certain concentration. If the concentration is less than CMC, they are going to behave as true solution. Only after achieving CMC, critical Michel concentration, they join together to form associated colloid. And colloidal solution shows Tyndall effect, not true solution, right? So this is not going to show Tyndall effect. This is true solution, this is true solution. So only option B is the colloidal solution that is going to show you Tyndall effect. Option B is the correct answer here. Option B is the correct answer here. Moving to the next question, peptidization involved. What is peptidization? You can think of, this is reverse precipitation. Reverse of precipitation. There are many times questions asked on the definition of peptidization. What we do here? We take a freshly prepared precipitate mixed with a particular DM, that is dispersion medium, and a stabilizing agent known as peptidizing agent. a stabilizing agent known as peptizing agent. And when we shake them together, we get the colloidal solution. That is the meaning of peptization. You shake a particular fresh precipitate with dispersion medium and a stabilizing agent to get a colloidal solution. Precipitation of colloidal, no, it is reverse of precipitation. Disintegration, no, it tends to form aggregate. Evaporation, no. Yes. DM have an impact on colloidal aggregate to form colloidal solution. Here option D will be the correct answer. Option D will be the correct answer. Yes, that's right. The next question is, which one of the following statement is not correct? The value of equilibrium constant is changed in the presence of catalyst. Remember, catalyst has only one function, only one goal of its life, and it is doing that only. It decreases or increases the activation energy to change the path of reaction, to change the speed of reaction. To change the path of reaction, to change the speed of reaction. Catalyst never changes the state function, right? So catalyst cannot change the equilibrium constant. Enzyme catalyzes biochemical reaction. The definition of enzyme. Enzymes are biocatalysts. They are made to catalyze biochemical reaction. Coenzyme, like for catalyst we have promoter, for enzyme we have coenzyme. Coenzymes are promoter for the enzyme. Coenzymes are promoters for the enzyme, that is, they will increase the catalytic activity. Catalyst can initiate a particular reaction. Okay. Do anyone know? The reaction that is initiated by catalyst, but catalyst in general does not initiate. Catalyst can only increase or decrease the rate of reaction. So only incorrect option is option A. That will be our correct answer. Option A will be our correct answer. Okay? Yes. Moving to the next question now. At high pressure, the entire surface gets covered by a monomolecular layer of gas. Follows. See, at high pressure, all the active sites have been covered. So after this, when all the active sites have been covered, there is saturation. If there is saturation, that means it is not going to have any change with concentration of gas. You can have more gas here, but it is not going to add over the surface because the surface is already saturated. And whenever the speed of process becomes independent of concentration, that is called as zero order reaction. That is called as zero order reaction. Right? Okay, the next question is, at critical mixture concentration, we already defined this CMC. CMC is the concentration above which association takes place, above which particles associate together to form colloidal solution. To form colloidal solution. Is that correct? Yes. Okay. Okay, I didn't know this was over. So thank you all. This is all about today's session. We have completed physical chemistry. And I hope for you also the physical chemistry is now over. Now I hope you can cut this physical chemistry from your revision chart. Right? So we will meet someday again. If we go by the date, then tomorrow you have your D-Day, the judgment day. Just think of two things in the tomorrow exam. First of all, about your parents, the happiness they will feel on their face if you are selected. If you are selected, right? And this can create some pressure. So be stress-free totally. You know what you know. And you don't know what you don't know. So if you know what you know, that means you are going to do well in your exam. Okay? You are going to do well in your exam. So have no stress while solving the paper. This will only bring you down. I am telling you again, if you are solving stress free, just When you are in the exam hall, that three hour time, when you are in your exam hall, just forget about everything else. About your friends, your relations, your phone, your all the responsibility. Forget about everything. Forget about all the past, present, future. Just live at that moment. Forget about what the result is going to occur. Forget about what the next question is when you are solving a particular question. Just enjoy that time. Because whether you are selected or not, an competitive exam tells you a very good learning in life. How to handle mental stress. How to handle mental stress, because in future, this is nothing. In future, you will have situations that are more difficult than this. And you will be able to fight with those situations when you have a stress-free life. Okay? So have a fighter attitude. Keep fighting. And remember, losers are not those persons who fall or who fail. Losers are those persons who after falling or failure do not get up again. So if you are doing hard work, you are struggling again and again, then you can never be a loser. You will always be a warrior. You will always be a warrior if you are failing, even if you are failing, but still you are doing your effort, you are doing what you need to do. Okay? So all the very best. My all best wishes are with you all, and I hope every one of you is selected in MBBS. Every one of you has been selected in MBBS. We will meet again someday with another session, another type of thing. Sometime you will find me in Hindi medium, sometime you will find me in English medium. So we'll keep on meeting. Okay. Tata. Have a good night. Have a good night's sleep also. Yes, just one thing I forgot to tell you. Before exam, at least take 8 hours sleep. 8 hours sleep is mandatory before exam. If your mind is not slept well, it is not working properly. Okay, Tachi. I hope this is true, and all the very best again. Love you all. All the best again.